Hi guys and girls all over the world, welcome to the Cloud First. This is the first actually, indeed this is the Cloud Native European Conference and you won't be sorry to be here today. This is made by developers and for developers. We're so happy to have you here. Let me introduce myself real quick and know that this event is en français et en anglais, in English and in French. I'm Charline, I'm a Dev PMM, Developer Relations at Microsoft. Je suis Charline, Developer Relations chez Microsoft. Ravie de vous voir nombreuses et nombreux. Et je ne suis pas toute seule dans cette histoire. Adrien, camarade.
Salut Charline, moi je suis Adrien. Hi everyone, I'm Adrien. I'm come from Belgium and I'm a Microsoft MVP and finally I have my own company. I'm freelance in Belgium. And I'm not alone with Charline, we have also Philippe. Hi Philippe.
Hi guys, hi girls. I'm Philippe. I'm from Strasbourg, France. So je suis bien français et je viens de Strasbourg. And I'm a passionate developer, passionate by cloud native architectures and development. With all my teammates, we worked really hard to provide you that amazing event. So we are really happy to be here with you. Ça va être une journée très très bien remplie. So let's start over with a little story on how do you cook a little recipe, how do you cook a great tech conference. So this is basically the recipe we took for building the TheCloudFIrst. So we are a six-pack of developers, a six-pack of friends, grown locally and grain-free. We're all passionate and we have one common passion, which is development and architecture, and especially cloud native solutions. And we shared one dream that we nurtured for years as we are strongly working with communities. And we have that dreams to build our own conference, really the conference we dream about. So the instruction for that recipe is that you have to mix all your ingredients and make them emulsify until you have a real good conference project. And once you have your team, your developer and your project, take the best speakers from all around the world, all together and bring them at the same place, same day to give the best experience possible to everyone. And with all of that, you need to add a lot of sweet toppings with all of our friendly partners and also sponsors to make that happen. And today we are at the end of that recipe, and we just need to share the result with you and give you a piece of that, and hope you will enjoy that.
Mais merci Philippe, pardon. Mais cet événement, il est organisé sur une plateforme qu'on va vous présenter juste à l'instant, qui a pour but de centraliser tout le monde, qui est le live TV portal qu'on a mis à votre disposition avec les 3 tracks en français et en anglais. Et on a également mis en place un Discord pour que toute la journée, vous puissiez échanger vos impressions, mais aussi vos expériences tout au long de la journée. Toutes les plannings, toutes les sessions sont disponibles directement sur le site web et seront disponibles en replay par après. Par contre, il y a un truc qui est important pour nous et qui nous tient beaucoup à cœur, c'est que l'événement est suivi par un code of conduct. C'est-à-dire qu'on s'est engagé envers les speakers, on s'est engagé envers nous-mêmes à respecter quelques règles qui se trouvent sur le site web. On va mettre le lien dans les différents canaux Discord. Et on va vous demander de prendre un petit temps pour lire ce qui est le contenu de ce Code of Conduct afin de s'assurer que tout le monde puisse passer un événement dans les meilleures conditions et que tout le monde soit respecté comme il se doit. Vous pouvez tous nous suivre et partager vos feedbacks sur les réseaux sociaux, sur Twitter, TheCloudFIrst.io, sur LinkedIn, TheCloudFIrst, et sur Facebook, TheCloudFIrst.io. Et toute cette journée, nous allons vous demander de partager avec nous vos feedbacks sur le hashtag TF2020.
TCF 21.
TCF 2021.
TCF21. That's the hashtag you want to remember. All right, so you see, it was a very, very yummy recipe that Philippe has going on. So what's the plan? Let's take a look at the menu now. track one. Track one will definitely be the best because I'll be hosting it. No, seriously, they're all fun. They're all amazing, but track one will be in English. So why do you want to be there? You want to be there because you're going to hear about quantum computing, about serverless, about data lake, cloud migration, governance and DevOps, migrating a monolith to cloud native, and IAM and Canary releases. So you want to be there. We have wonderful speakers that are just waiting for you. And see, there's a little, the end with a little question mark there. There's a little surprise for you. Let's see track 2 then.
Yeah, I will be your host for the track 2, which will also be in English. And also on this track, even if I will hosting it and not Charlene, it will also be an amazing track, and you will have, as you can see, a really, really huge amount of very, very interesting conference. We'll talk about first, what does cloud native mean anyway? Because that's the topic of the conference, right? So we just want to take a look at that. We'll talk about reactive architectures, cloud data warehouse. We'll talk about IoT stories. We'll talk about also best practices, multi-cloud clusters, cloud and pipelines, security. We'll talk about production strategy, and also we'll have, you can see at noon 20 that we'll have in each track some lightning talks. You can see it, but the lightning in front of it. So short formats, only 20 minutes, with some different topics. And in our track, we'll have Women in Tech, Ed in the Cloud, Hard in the Community, with Holly Lehman and Isidora Katanich, that will share their experience on the community. When you are a woman in tech, it will be really interesting. So be sure to be there. And it's just before the break, so I will have, I think you will be fully plenty at the end of the day. And so to finish, I will take you to the track 3 with Adrien.
Alors, la track 3, c'est la meilleure track parce que c'est en français déjà. Il semblerait que la France a gagné la Coupe du Monde de football. J'ai du mal à le croire, mais c'est une autre histoire. Et donc, pourquoi est-ce que c'est la meilleure? Ben, simplement parce qu'on a les meilleurs speakers, pas comme les autres tracks, la 1 et la 2, il faut être honnête. Et donc, par rapport à ça, on va parler de FinOps avec un impact environnemental. C'est important aujourd'hui d'avoir une vision sur comment réduire nos coûts au niveau de l'impact environnemental, mais aussi tout ce qui est microservices dans un contexte serverless. On passera ensuite à une application dans le cloud, comment attirer notre attention sur 10 points et conseils importants pour pouvoir mettre ça en place. Les distributed applications, donc c'est important aujourd'hui d'avoir une vision là-dessus et comment faire ça grâce à Stéphane Eikens. Le Lightning Talk, juste avant de midi, parce que là, on vient de terminer une bip, il y aura un gros mot à ce moment-là, de matinée. Et là, dans cette matinée, on va se terminer par un petit kata d'architecture qui est présenté par Alexandre, qui va nous revenir parce qu'il a déjà fait une bonne conférence. Ensuite, on s'arrête pour le break. Il est temps de boire des bières. Non, en France, on n'en boit pas. On boit du vin chaud ou peu importe. Et après, on part sur une après-midi mais de folie avec Laurent Bugnon qui commence par déplacer vos data from the on-premise to the cloud. On va parler d'un peu d'AWS avec comment gérer ses comptes, sa gestion de compte as code, les design patterns pour la résilience de la disponibilité. On va continuer ensuite pour un cache à jour pour toujours. Et enfin, on va terminer, et encore, ce n'est pas vraiment la fin, sur l'industrie 4.0 avec des retours concrets, un retour d'expérience par Vincent qui est un super speaker et il attendra à partir de 16h35 votre visite pour poser plein de questions sur son Rex. Et c'est la fin. Non, c'est pas la fin. Philippe, qu'est-ce que tu en dis?
Yeah, sure. It's not the end, but all along the day, just before we talk about the surprise for the end of the day, all along the day, be sure to share your experience and or everything you can live in that conference on Twitter, each tweet will be another chance to win your sticker pack. We'll have 10 collector sticker packs that will be drawn during the day for happy winners that will receive their own stickers from the conference at home.
And also, if we want to do another CloudFirst, we need to get your feedback. Did you like the session you just saw? How did you love it? Did you think that something could have been changed? We need to have your feedback to make sure that the second edition would be as good as the one you will be following today. And also take a chance.
Yeah, that's really important to us.
It is.
And also to finish the surprise, as one day is not enough. We planned for you to have the possibility to take free workshop with other top speakers that will take place tomorrow. So you will be able to book your seat until tonight to take that workshop. So there are 4 workshops during the day, one in French by Etienne and the other one in English. So you can see that there are different topics, but really, really good workshops that will bring you to try new things for 2 to 3 hours online. So be sure to book your seat. Places are limited, so be sure to check it out and join us tomorrow to extend the CloudFirst experience.
One thing it's really important for that, for the workshop, it's free. It's fully free. You can sit and enjoy.
Yeah, all the event is free.
Yeah, all the event. Et si c'est gratuit, que ce soit les workshops ou les sessions d'aujourd'hui, c'est grâce à nos sponsors, à Microsoft, à Squirrel Mind, à Reboot Conseil, mais à tous nos autres partenaires, Boogler, Microsoft Innovation Center de Mons, Sense of Tech, le DevApps, le Mug, et je ne vois plus le dernier.
.NET User Group.
Merci, je ne le voyais pas. Mais aussi à tous nos partenaires, parce qu'en fait, on n'est pas que tous les 3, on était aussi une équipe, comme pour que la sauce monte, comme l'a expliqué tout à l'heure, pardon, pas Frédéric, mais Philippe. On était 6, on a été rejoints par la charmante Charline, qui vient nous aider à faire le MC tout au long de la journée et qui va venir être dans la track 1, mais si vous voulez voir des sessions de qualité, c'est dans track 3 que ça se passera.
You're the worst.
No, track 2 is the best.
Track 3.
Okay.
That's
so I
it
think,
for me.
Yeah, that's it for us also. So, Charlene, you want to add something else before we go?
I just can't wait to start. And we have people waiting already and just waiting for us to begin. So how come we go into the different track? Just be sure that you don't miss the session you want to see. You'll be sorry if you miss it. So make sure you see all the little schedule that we made available for you guys. Make sure you send all the love through the feedback, through Twitter and all social media accounts. That will mean the world to us, and that will make that experience even better for everybody. So we'll see you in a bit, and have a wonderful experience.
Exactement. Comme Charline l'a dit, vous n'avez
on
aucune...
track 2 and other tracks.
Yeah, no, only on track 3. Comme Charline l'a dit, vous n'avez aucune excuse pour rater aujourd'hui de CloudFirst, la première édition.
Ouais.
On va vous demander toute la journée de partager votre expérience avec nous toute la journée. On sera là pour vous écouter et pour vous accompagner.
Okay, so let's go. C'est parti.
C'est parti.
Hi.
Hello.
Hi, everyone. How are you? Hey,
Doing
David.
Good. Doing
Yeah, can you hear me all right?
Yes, I can. I thought you were
Wonderful.
talking to someone else. That's why.
No, I'm always talking to you, David. You know that.
Thank you.
We're really very, very happy and pleased to have you as our first conference speaker. And we, as It's always a pleasure when we have you. And today you'll be talking about yummy quantum computing. And I know that we have a few things going on for you, and you will have 40 minutes to explain everything. But just I want to make sure that everybody knows a little secret about you first. I've heard that you have like some kind of hidden talent, secret talent, right?
Yes, I've got one. It's a stupid one. It's I can do the laser saber, the sound of the laser saber of Star Wars just using my mouse.
And that helped you getting a job, right?
Yes, thanks to that. Well, so I've been working for Microsoft for 21 years now, and one of my dreaming job was to become an evangelist, which is now more or less a cloud developer advocate. And when I've been doing my interview, so I had technical check from my future boss, and he asked me the same question: Can you do something, really stupid, different? Like I told him, I can do the laser saber, so please do it. So I've done that. And he told me, you got the job. It has stopped the interview, and I was, come on, really? So you don't want to do further technical checks? He told me, no. If you can't do that, I'm sure you will be good on stage. So
Mic drop. You just mic dropped it. That is very cool. And I hope that somebody has recorded this bit, because I want to hear that over and over again.
I don't know how it sounds over the mic, but well, it's more impressive in real life. We will do that in the future.
Please greet us with that next time. This is the only way I like to be greeted now by you, with the saber laser sound. And obviously, you have other talent, and you've been working on the subject of quantum computing for a while. You've worked on a podcast, on an article, and then there's a few crazy people that have asked you to join a conference in Belgium and said, "Hey, you've been talking about it for so long. How come you're not doing a keynote?" And now everyone's asking again. They want more. And you've been working on that topic for a while. It's been growing and growing. So I'd like to give you the floor to give us the whole flavor of that yummy quantum computing. The floor is yours. And we'll make sure you guys to answer your questions at the end of the session. Discord and YouTube are your place to shoot questions. And David will be at the end of the session for you. Okay?
Yeah,
The floor is yours, David. Have
Thank
fun.
you so much. So, hello, everybody. So I will be doing an introduction. I will try to do simple introduction to quantum computing. I am normally a web developer, so I am a developer, so we don't really care about web or C++ or all the stuff kind of development. I'm just a developer. I was highly interested in development for years, since I'm a very young boy. And quantum computing is about to arrive, so we're going to talk about that. And I wanted to understand, and I don't have like a specific, doing specific studies around that. I've been studying a little bit of some of the concepts when I was doing my engineering school, but I wanted to try to understand that in the most simple way and try to help you understanding how it could change the future of development and our life in general. So I'm working at Microsoft in the Windows Plus Devices division. And this is really a real passion. And thanks to that, and thanks to the various conferences I've been doing, like Charlene said, I managed to meet some people really working on quantum computing or quantum in general, which really helped me to understand some of the principles. So first, why do we need quantum computing? So I bet you already heard about quantum computing in a way or another in the press, but maybe you don't know why we are so interested in this new approach. First, you have to know that there is many problems that cannot be solved using what we are going to call now a classical computer. So using the classical transistor CPUs. Some of those problems, for instance, like let's take optimization on the right. I bet you know Waze, the application where we used to take the car and be in a traffic jam. We all think that it's not always working perfectly. Like sometimes you're asking ways to get you out of the traffic jam, and you're going to fall into another one, because this kind of problem are highly complex to solve for a normal computer, and quantum could really be helpful in this kind of optimization issues. So it could be traffic, it could be healthcare, everything that's really going a lot of combination. We're going to see that together is really managed properly by quantum. Looking at chemistry now on the left, we know there's some important issue today, like creating food for the people. We are a lot of people on the planet, and fertilizer are not that optimized today. We could maybe use quantum approach to create fertilizer, and we see that maybe how at the end. And like carbon capture also, so the planet is suffering, we know for years now. There's many options maybe to be able to build a better planet in the future. Maybe quantum could be one of them. And at last, materials. Probably knows that, well, we are about to shift to electric vehicles, cars, and we all talking about batteries. Is battery good for the planet too, like building batteries? So how to build better batteries, like more efficient, but also better for the planet, and also how to now take this electricity from, the nuclear plant, for instance, up to your house without losing power, so without wasting energy, and you need specific material for that. So all this kind of very big problem can be addressed by a perfect quantum computer, and we will see what is a perfect quantum computer. But first, we need to remind ourselves how the classical computer is working. So this is an image from the famous computer, one of the first one built by Alan Turing, the father of all developers. And we're going to bring back some memories. So probably you know that, probably not, but inside the CPU, inside the chip, you have modules that are doing some specific functions. So it can do like computation, like the plus, like the addition function inside one of the module. And those modules are built out of logic gates, which are also well known when we would like to do like low-level programming, really low-level programming. We know this kind of gates. And then those gates are built out of transistors, which is the key elements that we've been using for years. And if we take, for instance, the plus module, it looks like that. So it means that you've got two registries. So it's very simple registry. It's containing only 2 bits of information. So we've got the number 2 in the first register and the number 3 in the second register. And thanks to this magical circuit that we all forgot about, we managed to have the proper result, which is 5. And it's a little bit of magic. So just to remind you that sometimes we are using technology that's working perfectly well, and we just forgot about how magic it is. So it brings me to this famous Moore law. So Gordon Moore is one of the co-founder of Intel and the people building CPUs for years. And he created this law that we all know, that every 2 years we will double the number of transistors inside the chip. And logically, we should double then the performance if we manage to build the right architecture with that. And we've seen that over the years, it has been more or less respected. So for the oldest of the people currently watching, we had some issues with the Pentium. I don't know if you managed to have a Pentium, but you were able to basically put an egg on top of a Pentium to be able to do some cooking on top of a Pentium. And then we decided to shift some of the paradigm to use more multi-cores. And we managed to have a more or less linear progress and exponential also performance associated to that. But let's go back to the transistor and to this famous law. So today, like if you're using the latest Intel CPU, you will have a 14 nanometer, transistor inside that. And let's try to understand how small it is. So if I'm trying to compare the transistor to, the HIV to the virus, which is 120 nanometer, you see that already the transistor is much smaller than this HIV molecule. But in name, I'm trying to compare that to the red blood cell, which is 7 micrometers. You see, I don't know if you can see it, because probably like the compression of YouTube will remove the point, but there is a small green point there, which is our transistor. And we know that today AMD is able to build even smaller transistor using 7 nanometers, just to give you like this sense of scale. So we're reaching the limits of quantum tunneling, and I'll explain briefly what it is. So the latest CPU, if you are fortunate enough to find one of them on the market, are built using 7 or 8 nanometers. The latest smartphone, for instance, like the iPhone I've got, iPhone 12, is being built using 5 nanometers, and most of the recent one are around 7. And to also bring you some sense of scale, 1 nanometers is the DNA's radius, so it's really impressive. Like 5 nanometers is the equivalent of 50 hydrogen atom, but in line, which is really insane when you think about that. Like, it's so small that we are reaching the size of an atom. So we have some experiment working at 3 nanometers. I won't enter into the debate that not all nanometers are equal. For instance, even if Intel got 40 nanometers, you cannot always compare from a factory to another one what those nanometer means, but at least we have an idea of how impressive it is. So there is various ways to improve the computing power. As we are reaching the end in a way of classical computing using transistor, we need to think about other ways to improve the performance, but because we always need better performance to do some of the job, like the first issue we talked at the beginning. So the first one was obviously to add more transistor. We are about to end this approach. The other one was multi-cores, and we are already using that a lot. We have like AMD processor having a lot of multi-cores, GPU having a lot of multi-cores, and the issue that you cannot scale too much the size of the die, otherwise you will have some eating issues. The other one is optronic, is to replace electron by photon, and you will be able to really boost the performance. We have people trying to do neuromorphic processors, like trying to imitate the brain in a way. And this is a slide from a friend of mine named Olivier Zrati, doing a lot of conference about quantum too. And we have frequent discussion about quantum. So I'd like to thank him again for helping me better understanding what is quantum. So let's take a case study. Let's take NVIDIA to help you really understand what happened, because sometimes we tend to forget about that. So I'm a gamer. Maybe as you can see, I love gaming. And I would like to go back in slightly in the past when NVIDIA decided to shift from the 1080 GTX 1080 to RTX 2080. So what we've seen is roughly the new almost high-level GPU, which was a 1080, was equivalent in performance to the highest one, which was a 1080 Ti. And we were used in the past when we 18 months later or 2 years later to normally double the performance. So the most impressive GPU we had at that time was a 2080 Ti, was just 25% stronger than the 1080 Ti, which means that in the past, when we were young, when we were buying a new GPU, the performance were double at least every time. And now we see that these curves tend to slow down. On top of that, we can see that the die size has increased. So if you look to the resolution, which switched from 16 nanometer for the 1080 to 12, for the 2080. So we managed to reduce the size of the transistor as usual. We managed to almost reach 20 billions of transistors on this GPU. And we were forced to increase the size of the dies to manage to find some tricks to improve the performance. And the way to increase performance and to keep in a way the Moore law was in 4K rendering was to use DLSS. So DLSS stands for Deep Learning Supersampling, meaning we are using an AI type of upscaling, which means that we're going to compute the image in a lower resolution and we're going to stretch it in 4K using an AI algorithm. We managed to have almost the same quality as native 4K while having much better performance. And I think it was an interesting case study because it means that we were forced in a way to follow the Moore law, to be super creative in the design of the chip and new algorithm. And I think it will be some of our future as developers is to be smarter and to better use the existing resources rather than being used to have a CPU, GPU being double the performance as before. So now that I've been doing this introduction, I really wanted you to understand why we need this shift in the paradigm. We're going to ask you to open your mind. And if I'm telling you that the circle is equal to square, you're going to tell me that this guy is mad. There's no way it's equal. However, like if you're living in a 2D world, maybe this circle could equal a square. So we are living in a 3D world. We can see 3D as a human. But if you take this cylinder and have a 2D projection of this 3D object based on the way you're going to look at it. It could look like a circle or it could look like a square, meaning that someone living in a 2D world could think that this 3D object is different. And for us being living in a 3D world, this is the same object. So now let's take us as human and try to imagine something in 4 dimensions or 5 dimensions. It's really difficult for us to feel it, to concretely feel it. You see what I mean? So it means that quantum physics is the same kind of thing. It's really difficult to understand. It's not intuitive at all. So I like to go back in history, and the Solvay International Conference for me is one of the key moments in history. So on this picture, I don't remember the number of Nobel Prizes. I think it's like 20 people got Nobel Prizes. You can easily see like one of the most famous one, which is Einstein, and only one woman is there, which is a French woman, Marie Curie, who hasn't worked on quantum. But most of the people has been working on quantum. It's mean that quantum mechanics is quite old now, and we haven't been able to use it in IT for years, and we are the beginning of that. And I'm calling them being built with MS Paint, something my organization is driving. So you can see my awesome design skills. And I'm calling them the Quantic Avengers. To be honest, these are heroes that have been able to build the foundation of quantics. And thanks to them, we managed to move forward and understand more and more things. So you can, maybe if you're done studying physics, you remember like Schrödinger, Heisenberg, people like that, that were key to the development of quantum. One of the most famous guy is also Richard Feynman, that bring the base of quantum computing. And he was doing conferences trying to simplify, the concept of quantum for people. He's really well known to be a really good teacher. And what he was saying to the audience, he was, it's really difficult to understand quantum physics. He was even saying that I can safely say that nobody understands quantum mechanics. So it was a joke, obviously, but it was a kind of a way to say, please relax. Even people working in that area got difficulties to always understand what's going on. So it means that us, as basic developers, we can relax. We need to understand at the high level what's going on. So we will jump into some quantum mechanic basics. So fasten your seatbelt and get ready. So you won't understand everything because this is something impossible to do in 2-3 minutes with this slide, but it's to have some basic principles. First, it's superposition. So if we are comparing classic physics to quantum physics, there is something very interesting in quantum physics, is that some particle could be seen on, could be viewed as being on several positions at the same time. It's not completely true. Everything I'm going to say is not completely true always, because trying to map some real physics on top of quantum computing is almost impossible. It's working well using mathematical equations, but trying to map that to physical environment most of the time would be more or less wrong, but it gives you kind of an idea of the concepts. So it means that let's say the position of an electron, we'll see that it will be on several positions at the same time, and we're going to see how to find the right position at the right moments. So it brings me to the famous Schrödinger cat, which was, an experiment, a thinking experiment of Schrödinger. He was trying to explain also this concept of superposition. So the idea was to take a cat, to put that into a box. Inside this box, there is going to be a chemical product, a dangerous one, that could kill the cat, being controlled by a particle which has a chance in a random way to control the mechanism that will take the poison and kill the cat. So let's put everything in the box. When you close the box, you don't know what happened at a specific moment. Maybe the cat is still alive because the famous poison hasn't been controlled by the random mechanism to open the, to take the poison in the box. Maybe he's already dead because it happened already. So it means that until you open the box, the cat can be seen as dead and alive at the same time, which is not true. Once again, this is not working. We know that the cat is obviously in one of the two states, but he wanted to show something really interesting. The only way to know if the cat is alive in a way is to open the box. So then is to measure the system, and we're going to see that just after that. So something more concrete is this electron, turning around the core of nitrogen atoms, and we can see that it can be at several on several circles at the same time. And also something interesting, can only be a specific radius. You cannot be in between, and this is where we are coming also the name of quantum mechanics. It's because it's on specific radius and circles. Uncertainty principle. When we're going to measure the quantum system, we will have some result in a random way. Well, more or less, we're going to see that there are some probabilities associated to that. Meaning when you're going to measure a classical computer like an algorithm, at the end, you will be certain of the output when you will put something in as an input, and you will always gain the same values as input if you're doing a good algorithm, which this is not true in quantum. And also another thing that is really interesting in quantum is that we will have this superposition of states on the quantum system. And when I'm going to ask to the system, can you tell me what are the current values of all data you have being in a superposition state, you're going to reduce to a specific state, meaning that when you try to measure a quantum system, you force him to reduce the states, and you will have only one values. Another one interesting is the particle wave duality, which brings us to the tunnel effect. So there is a famous experiment when you have this kind of wall with two holes inside those walls, and this was built in the 80s. In 80th century. So someone built this experiment sending like some light inside these two holes, and the expected result at that time, it was to have just two small piece of light on the wall after that. And it turned out as light behave like wave and also behave like particle, which is really weird. You can have interference, which creates those black and white arrays at the end. It's because the light is going to behave like a wave, or it could behave like a particle. And this is the same for electron. For everything that is at the scale of quantum mechanics, a mechanism is going to behave like either that particle or wave, which generates then issues in CPUs, to go back to the quantum tunneling. So if we see this animation, so we can see in a way that you see that if the transistor is big enough, it will stop the wave of the electron. But once it reaches a certain scale, you see, it will go inside the wall. So it's the issue we have in our CPU. So we have maybe 3 nanometers will work, but at reaching a certain scale, the electron will go through the wall that we've been building. Remember the first circuit where we are doing the addition. It means that maybe some electron will switch from one wire to another one, and will break the logical the logical structure of the CPU, which means that we won't be able to maintain some logical computation. So this is the issue we have with classical computer, is this tunnel effect. The last one is entanglement, which is difficult for a French guy to pronounce. And this is the most impressive one. Some particle could be linked in a way, meaning that even whatever the distance between them, if I'm flipping the value of one of the particles, the other one will be affected immediately. So, for instance, I took Alpha Centauri, which is 4 light years away from us. If I would modify one particle on Earth, it would be immediately impacted on the other side of the universe, which bring a lot of debate at that time on how does it kill the Einstein law being built on top of relative, mechanics, and it's not. But I'm not good enough to explain it. So quantum in your everyday life. Laser, so being used in healthcare, DVD player, or fiber. I like to remind you that quantum is already there. Tunnel effect is being used in flash memory, in smartphone, USB or SSD key. So if you search on your favorite search engine like Google or Bing for flash or USB key and tunnel effect, you will find some explanation why it's using tunnel effect to write the 0 and 1 on your USB key, which is awesome if you think about that. Quantum dots is being used on QLED Samsung TV, for instance. So if you've got a Samsung QLED TV or monitor like mine, you're already using quantum technologies. And another one, which is nature. So nature is quantum by definition. And if you think of some of the technology around you, like flowers, plants, they manage to take light and some water, carbohydrates, and generate oxygen out of that by capturing some carbon dioxide, which means that these technologies that we never managed to replicate could be one of the solutions to save the planet. So think about that next time you will offer some flowers to your girlfriend or boyfriend. You're going to offer some kind of quantum technologies. So now let's go to quantum computing itself after all those introduction. So classical bits will have either a low charge, which will be the 0 value, or high charge will be the 1 value. So you all know about that. In the kind of quantum, we're going to use what we are calling a quantum byte, so Q byte. And compared to classical bit, let's take I've got 2 bytes, so two coins, or 1 coin in this specific example. Sorry, so one coin will have either the 0 value or the 1 value based on the side of the coin. So if you like to, for instance, build a number with 5 coins, you will use those 5 coins, and you will be able to have a number that will be 2 out of 5 possible permutation. In the case of quantum bits, it's different. Like, as we have this superposition of 0 and 1 at the same time, 5 qubits, like quantum coin in a way, will have all the permutation at the same time. It's like if I was flipping the coin and there were turning around in the air, and until I'm going to measure the system, it will keep all those values at the same time. And it's weird, I know. So we're going to take another example with only 4 bits this time. If I'm taking 4 bits, you know that it will manage to encode up to 16 values in memory, and you will be able to have only one of their 16 values in memory at a specific time in your computer memory, classical computer memory. In the case of quantum, we will be able to store the 16 values at the same time. Once again, thanks to the usage of superposition states. So it means that we will be able to do much more interesting computation. We can simulate quantum using classical computer, but you'll see that we're going to reach quickly a limit. So for instance, if you like to simulate a quantum algorithm, we'll see that to simulate 20 qubits, you need 16 megabytes of memory. To simulate 30 qubits, you need 16 gigabytes of memory. And to simulate 50 qubits, you need 16 petabytes of memory. And it's going to double, the memory needed is going to double every new qubit added to the simulation. So quickly, if you like to simulate 250 qubits, it needs more states than atoms in the visible universe, meaning that you cannot simulate this kind of qubit or quantum computer. Unfortunately, it starts to be really interesting to solve some issues with 100 qubits, which is already much more than what we can do with classical computer. So how are we going to compute with qubits? So to compute with qubits, we're going to use 3 principles that I've really briefly explained, and if you I will have some resources for you to dip into if you're interested in better understanding what is superposition, entanglement, or the particle wave duality. But we are going to use those principles to build our algorithm and qubits. So superposition will help us to store data in qubits. The entanglement will help us to do some links between qubits. And compared to classical algorithm, as I am not allowed to stop the algorithm while it's being executed, because I will then have to measure the system and break it, we need other ways to link data. So we will use entanglement. And then we will use also the fact that quantum is using is in this specific state where you have the particle wave duality to use interferences also in our algorithm. So which is a free like that. The three main steps, basic principle used in quantum computing. Something very important, I'm going to say that again, you cannot copy values in a quantum algorithm for a specific reason. Once again, when you have all your qubits in a superposition state, if you like to copy a value, you need to measure this value. If you measure the value, you're going to break down the superposition state in place. So you cannot copy a value, which is something we are super used to do in classical computing. There is also a notation that we're briefly going to see. If you see this kind of notation, it means that you're going to see that it's a quantum computing, a quantum algorithm. So if we have 2 qubits, we have 4 possible states that are going to be noted like that. So if you see one day this kind of notation, it means that you're currently seeing like a quantum algorithm. And also you have an infinite combination of those states because it's in superposition states. So if we try now to compare a normal algorithm, a normal computer to a quantum one, the classical computer is going to use logical gates. We've already seen that at the beginning. So you know all of those gates. In the case of quantum, so I'm a huge fan of stargates, and it really looks like that in the various schema I've seen on the web. We're going to use quantum gates. And quantum gates are going to be applied on qubits. So let's take, for instance, these 2 qubits. We always start in a quantum algorithm by setting the value at 0 for all qubits. So this is the state of my quantum bits at the beginning of my algorithm. Then I will apply a quantum gate. Well, basically what we are doing with normal computing. Instead of, in this case, this quantum gate is going to put my qubit into a superposition state, meaning that they will have this famous, multiple value at the same time, which is completely different from what we can do with a normal computer. So this is one of the key gates, because you manage to switch from a kind of a understandable world to this magical world where all values are set in memory at the same time. So in this case, for instance, there is a probability to have either 0, 1 or 1, 0 using this quantum gate. Because don't forget that when we say we have those states at the same time, we talk about probabilities. There is a probability to have one values and a probability to have the other values, and we don't know until we're going to measure. So we're going to end up into this specific state of superposition, meaning that half of the time I will have 0, 1, and the other half of the time I will have 1, 0. Then I can apply another quantum gate to do my algorithm. It's really based on the algorithm you're doing. So there are specific quantum algorithm, and the ended result will be this one. So what we will have in memory will be this specific quantum states. So the question now is, how do I know this quantum state? Because I need to measure to know it. And this is where you need a classical computer being connected to a quantum computer. The classical computer will enable you to create the initial state. Then you will let the quantum chip doing its job. And then you will use the classical computer to read those values. So how to read those values? Because if I'm going to observe the quantum state, I'm going to reduce it. So maybe if I'm lucky, I would say, I will have this value, but maybe I will have this one. So there's no way to, by measuring the system once, to know what was the ended result in memory. That's why we need to run several times a quantum algorithm. And let's run it 100 times, for instance. If we have 50 times the value 0, 1, 70 times the value 1, 0, and then 11 times the value 1, 1, for instance, after running like 100 times the quantum computing and reading that with a classical computer, we will be able to deduce the superposition states. So as we cannot read directly the quantum memory, we have no ways to know the quantum memory because when you measure that, you're going to destroy that in a way. This is the only way to find the answer. So you're going to tell me like it's weird. So you need to run several times a quantum algorithm to be able to find the result. Why is it so better than classical computer? And we're going to see that just after that. So quantum gates are going to apply a shift in probabilities to our qubits and our data. So we're going to shift to rotate some probabilities. So it's pure linear algebra, mathematical computation that we are doing on qubits. And we have various gates. You will be able to experiment in using quantum languages that we have available to be able to learn how to build those algorithms. So it's like the assembly of quantum today. We are not like high-level languages like C#, C++, or JavaScript. We are really at the assembly level today. Quantum algorithm, so there is two famous one. They are based on probabilities. So meaning that as we have this superposition of states that are, split into probabilities, we need to run several times the same algorithm, as we've seen before. But the beauty of that is they're going to compute on all values in parallel, which is going to bring us like exponential performance compared to classical computer. So to do a comparison, if we'd like to get out of this maze using a classical approach or classical computer, you're going to try the various possible exits and going to write down, okay, I've tried to go on the left, it was the wrong path. So then I switched to right and then left, etc. And you will manage by doing mistakes and good choices to find the exits. And you will then do like a depth, search of your tree of solutions. In the case of a quantum computing, what it will do that. It will test everything in parallel, and it will going to tell you this is the exit. But you won't be able to know, the path being followed, because to be able to know the path being followed, you would have been forced to stop the algorithm during the execution and to write down, okay, you decided to go on left, right. This is not possible because otherwise you would, destroy the quantum state superposition. So it's very different. It's much faster, but you don't have the same information in exchange. This is an optimization problem I really like, being shared by someone from IBM, an evangelist, a really great woman doing quantum evangelization. So let's say you think you are doing your weddings, for instance, and you have like table of 10 persons, and you need to choose, the number of combination you could use to put those 10 persons around the table. I don't know if you know that, but the answer is factorial 10. And factorial 10 is 3.6 million of possibilities to put people around a table with 10 available seats. So next time you will invite someone at home, you say, I decided to choose one of these 3.6 million possibility to put people around a table. And quickly, this kind of problem are difficult to solve for a classical computer, and which comes to quantum computing. Something similar, for instance, we can simulate chemistry, so caffeine molecule, something we really love as developers, on the most powerful computer in the world. But the other molecule on the right, which help to create fertilizer for for the food, is impossible to simulate on the most powerful computer, because the number of of variation of combination of the various atoms and molecules are too high to be simulated on a normal computer. If we come back to quantum computing, why is it better than a normal computer? Is once you have a lot of different combination possible, it's much faster. So let's take this fake algorithm that this time got 6 qubits as an input. And we have various gates being applied. So you will have superposition of various states. and this will be there at the end, the result of my algorithm. Let's say that I want to execute that on a normal computer. I would be forced to follow all the possible paths. So I could start on the left, for instance. So I would start there. So then I have multiple solutions. I can go there, 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 and there. And then if I'm shooting to start once again on the left, I've got all these possible solutions once again, which means that the complexity of the graph being built on a normal computer would be much, much complex, really, really complex to be solved. So I've just drawn some of the possible solutions. In the case of the quantum computer, it will require only, you see, 4 steps to do the result. So 4 steps instead of probably million of steps to be done on a classical computer. That's where the quantum computer are much faster than classical computer when we have this number of complexity that has been solved. One of the problems today that can be solved by a classical computer is breaking the RSA key. So you need to find 2 specific numbers that multiply by themselves are going to give you this answer. In the case of normal computer, you need 1 billion years. In a perfect quantum computer, it would require only 100 seconds, which means that it's much faster. So the kind of problem that can be solved by classical computing is, quickly when you have exponential complexity, it's almost impossible to solve because it wouldn't require like millions of years to solve some of the issues. Even if you double the performance every 2 years, which tends to slow down anyway, you see that it's still really, really important. Quantum computing tends to resolve this kind of issue in a linear way. So exponential complexity solved in linear, which means that it's much faster and enable us to do some stuff we wouldn't have been able to do in the past. So I've got 5 minutes left. Let's do a break and let's conclude quickly. Let's do a quantum break. So is it quantum or not? So is quantum dot from Samsung TV quantum? So the answer is yes. You had the answer at the beginning. Is this quantum? So Samsung quantum processor 8K AI. I think we even lack like blockchains inside that. So no, it's bullshit. Just I would like you to get prepared to be influenced by the marketing people about quantum. Pay attention to what you're going to see. And this one is fun because I don't know if in French it was named Code Quantum, which is quantum leap in English. So I wanted to know if JavaScript was quantum. So if you think about that, like variable and a superposition of string, number, Boolean, and object or function at the same time, and you don't have a clue of what's inside until you measure it. It's true, like in JavaScript, sometimes you don't know what's going on and until you measure it. So to my point of view, JavaScript is a quantum language, which is a stupid joke. And I had a demo, but we are running out of time to prove it. So if you like to code using quantum, we have several experimental language. So first, IBM is really good. You can play with a quantum computer being available in the cloud. So you can go on this specific URL. Google also is doing quantum computing as his own quantum computer, and you can simulate, qubits using Chrome and WebGL on this playground. And on our side at Microsoft, we've got the Q# language and the quantum development kit that can enable you to simulate 30 qubits on your 16 gigabyte computer. So here is the type of algorithm you can build. And you see there is some quantum gate that you need to learn to be able to write quantum algorithm there. So to know more, go to microsoft.com/quantum, and you will be able to either simulate quantum on your machine, or you will be able to have the simulator on Azure. And we start to build like the quantum stack on top of that. So we are working with partners like Honeywell, IonQ, bringing several types of qubits. I did not have the time to explain you, but there is several types of qubits available. And then we are building kind of a logical abstract stack on top of that, so you can then play with some of this concept as a higher level without being forced to learn this assembly language. So as shared before, we have initial application. So if we manage to have a perfect quantum computing, meaning having error-free qubits, which is not the case today, if you have like from 100 to 200 qubits, you will be able to create something new using this quantum computing to be able to improve nitrogen fixation. So, and then obviously to help the people to feed the people, the world. We can manage to find a new kind of material that would capture the carbon, like the flower, the plants. So we could be able to find something similar and build something to capture the carbon. We could also improve the materials and build something that will take the electricity using supraconductor working at normal temperature. Today, you are forced to use quantum computing also at super low temperature, even colder than space. So we need to improve that. And we could also improve in some way machine learning with a very big quantum computing with a lot of qubits. There are references that you will be able to find on my blog too. And I'd like to thank you for following that. I know it was fast. I know you probably didn't understand everything, but I was just wanted to do an introduction on why we need to shift to quantum computing.
Thank you, David. I think next time we'll need like 4 hours.
Yeah, no, it's complex.
Like a whole workshop. I don't know. It was very, very cool. Mm-hmm. And actually, a quick question for you, because I don't want to take too much out of your time, is well, this session is like a tiny bit sci-fi, and I just want to ask, like, where are we standing now, and how can we make it tangible for everybody?
So for now, you have experiment being done. So we don't have enough qubits being stable to save the planet yet, but a lot of people are working on it. There's various technologies. We think that we will have some of the technology depend on the people. We're still in the pure research area, but some people are optimistic, saying maybe in 5 years we will have something. Some people are less optimistic, saying that we need at least 20 years. There's a lot of R&D being done. That France has announced a plan on that, a big plan to boost quantum computing too. The US are doing it, China are doing it. So we had at the very beginning. What we need to do as developers is to help building maybe quantum algorithm first.
Yeah.
And then when we will have the quantum hardware, we'll be able to execute them. So we can train ourselves using simulator in Azure on our machine and wait for the really cool future stable quantum computer to do our work. And we have in solution, like we have not perfect quantum computer that still can do some computation that classical computer can't do.
Can do, okay. And any sector where you think this will be more valuable, maybe like health, for example?
Yes. So one of I decided to be interesting into this area because my son is suffering from a genetic disease, and it could help. Genetics also there's a lot of permutation of the genes, and based on the specific permutation, it could be good or it could be bad. Like. I know that we cannot understand everything using classical computer, and quantum computer could probably help this kind of complex problem to resolve. And then everything that links to optimization, healthcare for sure, and also material chemistry, one of the most interesting one, medicines, for instance. But everything linked to chemistry or new materials. So it means that quantum computer, for now, what we see has very specific, usage. It cannot replace your iPhone because it's really bad in doing classical algorithm. It cannot do it, but
it cannot replace like our computers we have today.
No, it will work. It would like a new super GPU in a way. You're not using a GPU to execute Windows directly. You need a CPU. It will be same for quantum computers. It will be in the cloud. That's why we decided to start that. It's linked to the conference. It will be accessible through the cloud and to solve specific problems.
Got it. Next time, I hope that your topic will be even more improved and even more bigger, because I believe this is just the beginning.
It is. And well, I wasn't born when Alan Turing started the first computer, but I managed to follow some of the new algorithm being built computer. We are lucky enough to live this new generations, this new leap. So you can, if you are young and open-minded enough to understand quantum mechanics, try to build to find new algorithm. There is only 40 algorithm today, and we know that we need to find much more.
We need to have more, indeed, to make it work. Thank you, David. It's always awesome to have you. There was the perfect way to start the day in this conference.
Let's hope so.
And please reach out to David on Twitter. He's always awesome and always answering your questions. So I'm sure you will love him as much as we do. Thank you, David, for your time. And
Thank you so much.
we'll talk next time. Next
Yeah.
time, see you soon.
See
Bye-bye.
you. Bye.
Hi again. Hi again. You're still on track one of the CloudFIrst. CloudFIrst is obviously the conference you want to follow the whole day, and we have such a sweet schedule for you. Now, what we're going to do is that we're going to go to Berlin. Yes, I told you this is a European conference, so it's not going to be all France and Paris and all that. No, done. We're going European. CloudFIrst is a European conference, so this is why we're going to Berlin with my friend here, Renato. Hello, Renato.
Hi, everyone.
How are you?
I'm all right. Hello from very cold and rainy Berlin, but yeah, all okay, all great.
Isn't it how Berlin is supposed to be in everybody's mind, like a little rainy, a little gloomy? That's the beauty of it, isn't it? Awesome. Renato, you work at Funimble and you're from Berlin, as you said. We're really happy to have you because you're going to talk today about is serverless the future of relational databases? And this is not a topic that we always have. There's such a huge fuss about serverless everything, and this is why you wanted to talk about it. But first thing first, I want to remind everybody that you can ask your question to Renato in a Discord or in a YouTube channel. Feel free to shoot questions. Let's get this, talkative and starting. And we want to hear from you, have an actual sense of having you, from all over. And this is, again, a European platform, so we should be all together. First, I've heard, Renato, that you try to work from your laptop as much as possible, like outdoor. I can't do that. How do you do it?
Well, actually, Berlin is probably not the best city in winter to do that, but there are quite good forests, really forests in the city. Well, the city is quite wide. But you can really, really enjoy the outdoor, and there's reasonable connection and quite a few benches. And I think it's a good way. If you work always remotely, if you always work from home, I think it's a good way to go out once in a while.
Indeed. Because you're from Italy, but you've been
Italian.
in Berlin. Yeah, and you've been in Berlin for a while.
I've been in Berlin for a while, yes. I've been around Europe for a few years, and then I settled down in Berlin with my family here.
That's
who knows in the
brilliant.
future how long I'm going to be here, but that's what I call home at the moment.
Well, next time if we have the TheCloudFIrst from Berlin, we'll make sure to make it outdoor with you. Like the whole conference will be outdoor. Would that be fun?
Cool idea. But
That'd be cool. Let me put that down so we can make sure to do that next time. Well, okay, so relational database and serverless sounds like a bit of a conflict. So you're going to tell us why, and you're going to tell us if serverless is really the future or a nice marketing label. So we want to get all your questions or remarks in the chat. Have fun, Renato. Here's your screen.
Thank you so much.
See you in a bit.
So, is serverless really the future of relational databases? Well, let's see first what we mean by serverless, because serverless is a quite wide concept. So, first of all, let's try to put a few minimum requirements that we want to have if we talk about a serverless relational database. Because, of course, if we just think about functions, well, that's hardly a relational database. So, let's say that the minimum, different people might have different ideas, but usually there are at least 4 main requirement for something to be serverless. First, it should be highly available. I shouldn't have to play around myself with that. There should be no server maintenance involved with that. Well, I mean, if I have to install my relational database or if I have to patch my database, well, that's probably not really a serverless one. A critical part is as well the pricing component. I should be charged for what I use. So if I don't use it, I should be charged eventually for the storage because I still use the storage. But if there are no requests to my database, I shouldn't be charged for it. And there should be some form of continuous scaling. What do I mean by continuous scaling? Well, is that I shouldn't pre-provision a fixed amount of CPU of memory and have to handle my side the scaling of that part. We'll see that in a second how that works. So I really like this tweet from a few years ago that really makes clear that serverless is simply not a function. So in this presentation, of course, when we talk about relational database and serverless, we are not talking about a Lambda function or any kind of function on the cloud. We are mainly talking about on-demand scaling and a pricing characteristic. So how that is going to affect your pricing as well. You may say, well, we talk about 4 major requirements, and there are already some databases out there that satisfy those requirements. You may say that Cosmo that satisfy that, or DynamoDB on AWS has that. Cloud Spanner on Google probably covers most of the requirements. There are as well some services like PhoneDB that have that. So why do we care? Why do we say that serverless database is such a new topic or something so new? Those requirements can be handled by services that have been around for quite some time now. Well, usually the problem is that when we talk about relational databases, our relational database in our deployment, where we have amazing containers or beautiful auto-scaling group, elasticity at the application layer, usually our database is our bottleneck, at least in the whole traditional deployment. You have a single database running behind our nice cluster, and that usually is your bottleneck when things go wrong. Harder to scale. And as DevOps, as architects, you want to relax, you want to enjoy your life, you want that everything scales automatically. And with serverless, that's what they tell you, that, well, you provision what you don't have to think about anything. You just write your function, you write your code, and the cloud provider takes care of everything else for you. That's the dream, at least. But before talking about the future, let's go a bit back in the past. I really love that old picture from Oracle when years ago they were telling you that Oracle was the database used by everyone, the largest company, whatever. And just over a year ago, there was a tweet from, actually 2 years ago now, Andy Jassy in AWS that said basically, yay, we finally, by the end of 2018, Amazon will get rid of all the Oracle database and move everything in-house to Aurora and DynamoDB. That's cool. That was a great goal. That was 97% of the critical one. That was the goal. 1 year later, they finally managed to migrate everything out of Oracle to Aurora and Dynamo. So why is that important? Why I'm talking about that example? Because that proves how hard that is. I mean, a company like Amazon that has almost unlimited resources, that has a marketing as well goal to get out of a competitor database and move everything to their own solution, took more than 5 years basically to have everything on Aurora, or at least claim to have everything on Aurora. That's quite a lot of time. So if you think about your own deployment, your own service, yes, there are already services out there that we can call serverless. You have Dynamo, you have Cosmo, you have Spanner, but if I have my own application running on MySQL, or if I have my own application running on Postgres, I probably don't want to reinvent everything, redo everything, change entirely the knowledge of my development team to use something entirely new. I might do it, but that's a big step forward. So why is serverless relational database such a big topic at the moment? Because basically it lets you reuse what you already have, or at least they claim you can reuse what you have already with some limitation, and basically just deploy your old style single instance relational database and move to something much more exciting that scales for you without, at least ideally, change any line of code. That's the cool part. So basically what we want to have is an elastic relational database, an elastic relational MySQL, SQL, Postgres. Let's see, what do I mean by elastic? I mean basically that I need to have a database cluster that as a minimum requirement starts up, shuts down if I don't make any call, and scale up and down capacity based on my application need and without any failover, any shutdown or restart be visible to the end user. So from the end user perspective, there should be no scaling. Why is that really, really difficult with relational databases is, well, usually when you think about a simple single instance server, a relational MySQL, there are a few things that are usually your bottleneck. There's some connection limits, usually even in configuration. You might have a max connection defined in your configuration file. You have as well networking issues because you might have a single instance running and in front of it a crazy amount of virtual machine. And when you have a crazy amount of virtual machine, maybe your networking doesn't work anymore. You cannot handle that anymore. You have as well provisioning issues. What I mean by provisioning issue, I mean that, for example, the storage for a database is usually quite expensive because you need quite fast storage. And if you have to pre-allocate the storage, it's quite costly to allocate storage that you don't need. And it's usually quite hard to change increase storage along the way. As well as scaling issue, when you think about your single instance, when you have to add capacity is usually the hardest part is the database layer, not the application layer. And as well, there's some infrastructure as a code issues because yes, you can put some bits in Terraform or CloudFormation, whatever you use for your infrastructure, but the relational database is usually not the easiest part. It's not the most transparent part that you can manage through infrastructure as a code approach. So let's narrow down with example to see what is available and what we can do and which approach we can have to go serverless. And in this example, I'm going to use mainly AWS as a cloud provider, and I'm going to use MySQL and Postgres as a database. All the example will be with MySQL, but basically what is available on MySQL, apart from one exception, is available as well in Postgres at the moment. So there are basically 4 different approaches we can use to do on the cloud and MySQL on AWS. First approach is, of course, the old style approach. Whatever you use a container, whatever you use a virtual machine, whatever you use a bare metal instance, whatever you want, you can have your own MySQL installed on a virtual machine. So you're basically using just the cloud provider. The cloud provider just gives you the basic bits. You get full control, of course. You have root access. You can change maximum flexibility because you can install whatever you want. You can do any change you want to the configuration. But yeah, you can as well have some advantage of the cloud. It's an easier vertical scaling because if you need the double memory or double CPU, you can probably scale it up and up to a certain point at least. But for example, you have to decide upfront how much storage you want to have. Of course, you want in production to have replication. You have to set it up yourself. As well, the failover, backups is all up to you. So maximum flexibility, you can use any distribution you want. For example, for MySQL, you can use as well MariaDB if you want. You can use Percona. You can use the tools you want. You have full flexibility, full control. But if we go back to our 4 initial requirements, we haven't achieved any of them. That approach doesn't bring any of the serverless requirements. So far, so good. Second approach is, okay, I've decided to don't do it myself. I use things that have been around for 10 years. I use a managed service on the cloud. So for example, I use RDS. So RDS has been there as a managed service, has been there for over 10 years now, provide easily vertical scaling, and provide a few other bits that made it really popular in his life. Things like synchronous replication, backup, point-in-time recovery. So I'm getting rid of some of the requirement that I had to do manually. And as well, some more enterprise feature on top of the community edition, things like performance inside that let you better manage your database. Since recently, just over a year ago, you have as well some auto-scaling storage. What does it mean by auto-scaling storage is not really that you pay for the storage you use, but more like that the allocated storage grows according to the usage in small step of 10% or whatever. That's already going in that direction we want to have, but in terms of our requirement, you might say, yes, I don't manage myself the services, the servers. I don't have access even to the servers, so I'm not anymore root. I don't have, I can claim to up to a point that I have some sort of highly available system, but is there really a serverless database? Of course not. The price component is not there. I mean, when I started, it runs and I pay for it. And as well, in terms of continuous scaling, there is no scaling. Apart from a bit the storage now, everything else doesn't scale. Option number 3, you go from a community open source version of the engine, MySQL, you go to a fork. In case of Amazon, you're talking about Aurora. Aurora is what we call a MySQL compatible at this point. Is an enterprise version, target at least, and you have more or less the same you have on RDS, at least for our serverless concept as an idea. You have some vertical scaling. You're not talking anymore about open source here. You have a fork that is private. There's some managed storage, so the storage you really pay now just for the storage you use, so it's a bit more elastic. There's some replication that happens behind the scene and is entirely transparent to you. So you start to don't see anymore the component, how the backup is done, how the replication. There's not anymore the concept of the standard MySQL replication, for example. You can use it for replica, but that's not the standard way Aurora does it. You have as well some more enterprise and new features like backtrack, so the ability with a click of a button or API call to go back to a point in time of your database. You have things like multi-master that target many use cases, but in terms of our requirement to be serverless, we're still not there. We still pay for a service when we don't need it, and it doesn't scale automatically the capacity of according to the usage of your user. Well, you might say, well, that's bad, but how difficult is it to scale yourself the instance? I mean, you might say, okay, I do it myself. I use a managed service or my own instance, and I create my own scripts and my own Lambda function or my own bash script, or use a SDK or whatever I want, and I scale my instance according to load. I might scale it according to specific time of the day, or according to the number of requests I receive, or the average CPU. I can use whatever metric I want. You can do it, but how difficult is that part? That part is usually quite challenging because there are 10,000 different components, and the API call might take a few milliseconds to execute, but that doesn't mean that your database scales in a few milliseconds. You might have a lot of downtime, maybe not just seconds, but minutes. You might have as well a system that is not that flexible. You might scale up the storage, but not be able to scale it down anymore. There are a few components that are not really elastic. So what's there on the market? That's what they call Aurora Serverless. What is that? That's a auto-scaling configuration. So at this point, you basically have the same concept of a CNAME that you call to run your database, but you don't define anymore upfront how much CPU you want to have, or at least you might define a range, but you don't define anymore, I want a specific number of gigabyte of RAM or number of core. And the scaling is transparent to you. It's done by the cloud provider, and you pay for what you use. So if you don't perform requests to the engine, you don't pay for CPU. You pay for the storage, of course. It's compatible, again, it's not an open source edition anymore of your MySQL, and it's compatible to 5.6, 5.7. There's not 8 yet, and hasn't been there for. It's been now GA since August 2018, so it's quite a mature product. Technically, it's over 2 years. Postgres has been introduced about 1 year ago. And the cool part here, going back to our original requirement at the beginning, is that, yeah, we'll see you have API as well if you want, but you can connect to that database using your standard TCP connection. You can use your driver. If you're writing an application in Java, you can use your JDBC driver and connect in the very same way you connect to your own standard database. And that's the cool part, that you can reuse the code you have. How does it work? Well, there's an entire presentation. It takes 1 hour to show you how the logic is behind, but you of course have there's no magic. There's still some server running behind the scene, some capacity, some work capacity, and some logic with a proxy to move your connection from one database to the other one. The main component is a proxy fleet, and behind us a standard storage as the Aurora engine. But at the end of the day, that's really what you don't care about. You don't really want to know how they implement it. You want to use a database that is serverless. That's why you go to a cloud provider and you want to use it. And there's use cases for this. Well, definitely there are cases where you have an unpredictable load. If you have an application that scales a lot during the day and you have no idea how it's going to handle the traffic, well, that covers quite well. There, of course, it might be quite useful for development test scenario where you don't need always to have a server running. Anything with intermittent, even planned intermittent load. If you have an application for, I don't know, food delivery that has peak at lunchtime and in the evening, it's actually quite useful to have something that scales according to that. And any serverless application where having as well a serverless engine behind could help. Of course, AWS is not the only cloud provider providing elasticity in that sense. Azure provided for Server SQL, with much more on a focus on price performance, and that's quite an interesting point of view. But I have to say I was lying when I say you don't need to know the details behind. So till now we said, okay, our database scales, and they tell you that the database scales from a user, from who is making the call, in a way that you don't even need to know what's happening behind, because they're not going to drop any single connection. That's cool. No connection drop. That's magic. Well, the problem is you can't have the best of both worlds. The way the implementation is done is, of course, that by default, if you don't drop any connection, if you have any long-standing query or any transaction or any temporary table or anything that runs for more than a few milliseconds, your database might not scale, because either it drops a connection or you scale capacity. So you can change the default. You can have that it drops connection to scale according to the load, but at the end, you cannot have both, that the connection are not dropped and that the database scales. In that sense, it's actually quite then important that, of course, your application layer is able to reconnect. Okay, so till now we would say, is there really a serverless database, or is just a auto-scaling database, a database that scales? Well, one of the main differences, well, there are some data API. So you can use your JDBC driver, you can use your TCP connection, but you can as well access in a quite simple way, providing a query through the API, of course, with a bit more latency, because you're not running it through your standard way of opening a connection and run multiple queries. So you might have more latency, but you can do it on API request. So what are the drawbacks of this approach? Well, there are a few limitations, of course, is the more you go from manage your own database and have the full flexibility to go to a fully serverless database, you start to lose control of your database. So you start to have many more restrictions and many more things that you might not be able to change yourself. So how does it really work? Well, in the case of Aurora, for example, you have a range of what they call ACU, that is the range of capacity. You might limit it, but basically it goes from a minimum to a maximum. So it doesn't scale in an infinite way. You still have a range. It's just compatible to 5.6 and 5.7 of MySQL, and as well on Postgres side, there's a limited number of versions supported. That means that, for example, the latest, most common MySQL 8 is not there, so you cannot use it. There's some scaling time still, so it might take up to 1 minute to scale. That means that if your application scales too fast in a very fast way, you might not be able to keep up with your demand. The way it scales according to two default metrics, and they are the only metric used, are CPU and connection. So it scales up if either the CPU is above 70% or connection above 90%, and scales down if both connection are below 30, both 40% and CPU below 30, I think. And there's as well some wake up time. So we said before, one of our requirements is if I don't perform at all any query, our database should not be built and the database should shut down. Yes, it shuts down, but it still takes a lot of time, many seconds, up to 30 seconds sometimes, to wake up on the first request. That might be okay in many scenarios, test, development, whatever. It might not be okay in some production one. Again, there's a limit on the ACU, so it means as well a limit on how much RAM and how much virtual core you can throw to your database. So it's still a vertical scaling. Limitation, we see most of them. There's no auditing, the max connection, you have no control. You access the database from only inside the Amazon network. You cannot open it to external IP addresses. Is MySQL compatible. It's not a MySQL open source community edition or whatever. And as well, in terms of configuration, there's very, very limited things you can do. So for example, most of them, if you need to enable the event scheduler because you have some scheduled MySQL task, well, it's not there. You can implement it yourself in other ways, whatever is a bash script or a Lambda function or whatever else, but you cannot do it on the serverless database. Is that elastic? Well, yes. I mean, we got our 4 requirements at the end. The price component is there now. I definitely have no access to the service. I don't need to patch it. It's highly available. And the final one is scales automatically. So all great? Well, even Amazon doesn't think it's all great, because actually no more than 2 months ago, at the latest reInvent, they introduced an even second version of Aurora Serverless, and it's called Aurora Serverless V2. That is entirely separate API, entirely separate concept. There's nothing in common between the two. So it's not an iterative approach on the current one. It's you technically are going to choose between 2 different products. And that's because there are still many, many limitations on the current Aurora Serverless. And what is the V2? The V2 is provide the same endpoint without instance size, of course, so covers the same requirement, but you pay per use again. But there are a few bits that are the main problem of the existing, and the V2 is still just preview. The current one, you scale in an incremental way, we see in a second, but basically you always double capacity. So that means that it's almost similar to what you will do doing it yourself. You cannot say, I increment by 10% my capacity because my load went up 10%. Either it doubles or it doesn't double. That's as good as it goes. Current Aurora Serverless is not multi-AZ. What does it mean? It means it's in a single availability zone. It means that for many production deployment that doesn't work, it's not good enough. The new Serverless V2 is only MySQL 5.7 compatible, so even narrow even more at the moment the option you have. And it's just in preview. So, sorry, preview since December 2020, not 2021. So when we say about the scaling, until now, all the scaling done manually, the scale done by RDS as a managed service, or the scale done by Aurora Servers, has always been done by doubling the capacity. So if you have like a capacity of, I say, 1 CPU, you go to 2, you go to 4, you go to whatever, the same for a gigabyte. With the new Aurora Serverless, the concept with the V2 will be that the incremental, actually half unit, you'll be able to do incremental change. Still not there, so that's just nice to have. We'll see if that works. What's the problem with that? Well, there are few missing bits that usually you need in production. You're still basically doing a vertical scaling. That you always have to keep in mind. You're not doing any scale out. You have no managed replicas. You have no action on the serverless, on the current one. There's no way to put any read replica, so you cannot even do yourself a scale out using for the read traffic. There is no sharding. I mean, if you want to use sharding, you have to implement it yourself using Vitess, using whatever else. It's a single region, so it's not a database distributed worldwide. So if you need a multi-master in different region, whatever, that's not the solution. And I would like to close with a key point for me of relational database, quote a tweet from the founder of Percona that basically say that autoscaling can convert some performance bug to very large bills. And that's usually true for serverless application. For databases, the good and the bad is sometimes queries can be so badly written that there's no fix. I mean, it's not the problem. The database can scale as much as you want, but it's not going to address the problem. But here the key concept is always remember that an automated scaling, as much as cool as it is, it can help for bugs, it can help for peaks and whatever, but it means as well that any bugs, any bad query is going to basically spike up your database. With that one, thank you. Here is a collection of resources of the article that I use for this presentation. And yeah, that's it from my side. Available now for the question.
Thank you, Renato. We do actually have a few questions. And first thing first, thank you for your time. And I believe that this topic will be, it's an infinite topic, I believe, again, always growing. So I'm sure that maybe next year we'll be able to hear some more. One question for you. What about the cost? Because you said that is always
that's a very good point. About the cost, one key aspect is, of course, one of the main reasons, and that's why I say, for example, that Microsoft really focused a lot on selling it as not much as a serverless technology, but more like you're going to pay for what you use on the database as well.
Yeah.
The cost is a key part because, of course, if running a database always, if there's no difference between running it as a serverless database and running it always up, there's no price difference. Well, at that point, I don't care. I leave it running full time, and that's it. And that's part of it. The key aspect, there are two, to me, main aspects when talking about cost. One is to make sure to always compare the same things. So, for example, a common topic about the serverless one is like, oh yeah, well, I run a serverless database, but it still costs me more than running the cheapest single RDS. Then I prefer to run a single database as a micro instance, whatever. That's true, but the key point is of a serverless database is not simply that it's the cheapest, but is able to scale when you need it. So talking about being lazy and enjoy my weekend, I want to make sure that my database is not only the cheapest. It means that if the weekend the traffic scales up, even unexpectedly, my serverless database might scale up. It should, hopefully, while my single cheapest instance running alone all the time, it certainly won't. So in the cost component, we should consider as well how much we value the elasticity, not just to be the cheapest, but as well to be able to scale up if we need.
To scale up, exactly.
The second aspect of it is, of course, a database that is very predictable as a load. So a database where we know that the load is consistent during the day, or where we have a very certain pattern that we can predict and scale ourselves, the database is usually cheaper if you manage it yourself, because there's I would say a component in the cost, a premium component that makes it not ideal. A database that has a very fixed load usually is not really ideal for a serverless, as well for a cost component, because it's not the cheapest.
Okay. And what about vendor? Because is there like some kind of risk that you can assume?
That's one of the reason I mentioned at the beginning, the Oracle scenario, is that we tend to think Oracle as the bad guy from the past, where we all migrate to the cloud and that is all great and we have our new databases and whatever. We need to remember as well that one day we might need to move out from this vendor solution and move to a different one. Whatever is, which one is better, it doesn't matter. It's just there to have the flexibility to move out. And moving databases has two major components. One is usually not simply moving a virtual machine or a container or a Kubernetes cloud or whatever. It's just involves data. And usually data is a costly affair, even just on data transfer to move it out. And that's the complexity of the engine. So if you stick to a vendor-independent engine, usually you are in a better scenario than on a solution that, let's say, for example, yes, I can use a NoSQL solution from Amazon and use DynamoDB, but that means that if I want to move out, well, I'm not going to Mongo in a single step. I mean, I can do it, but someone will always tell you it's always feasible, but reality then is the friction to do it, is the cost to do it. Usually you are not going to do it. You're going to take years. If you say you're going to take 1 year to do it, you're going to, at the end, take 5 years to do it. I mean, that's why I say if Amazon takes 5 years to move out from Oracle, or even more than 5 years, I doubt that a single smaller company can really do
that. Makes sense.
that with. And in terms of using the serverless version, the main advantage, you are still technically on Postgres or MySQL, for example, but you have to remember that you are now in compatible version and a few things are not there. So it is not as straightforward to move out as it was, for example, if I use a managed service, I can always start a replica and start a replica outside the cluster. So today, if I use RDS on Amazon, I can start a read replica on Azure or on my own data center. It might cost me something, but I can do it, and then I promote my replica, and I have my server database in-house. With the serverless one, there are a few more limitations. That's why, for example, I mentioned the one about not being able to access it from outside the cloud or not able to create replica. That makes it harder because you then need to dump the database. You can do it. Can you do it? Yes. But maybe a production database of a few terabytes of data, at least, you might do it in theory, but you're not going to do it in practice. So I will always keep an eye that, to me, the more you go towards a vendor solution that removes the complexity from your hands, the more you know less about the database. So the more likely you're going to be stuck. But that
makes sense. Yeah, I believe that people know when they get into it. I'm sure they do. But thank you for giving like a few ways of workaround about it. And also multi-cloud, is that something you talked about it a little bit, but should it be considered?
Ideally, I love a lot the concept, not just for databases, on the multi-cloud approach. Reality is almost all for MySQL, Postgres, whatever is the maximum you can achieve on a multi-cloud is probably replicas in different data center, replica in different cloud providers. In that case, you're already out of the serverless world because that's not available at the moment. And as well, then you might be able to do it in theory, but you then have to take into account all the extra cost as well, data transfer or whatever else. So, but with limiting at the serverless option of Amazon, at the moment, you cannot do it. So that's as well something to keep in mind if you are working in that direction.
And last question for you. What's next? What should we expect?
Well, to me, the what's next is the most exciting part. I was really surprised that Amazon came up with an entirely new version of the engine. They just announced it. But to me, first, it means that there's really a market for managed services that go as well for the database towards, if we want to call them serverless or simply more managed services, basically the idea is that you want to have just a database that they take care of the scaling part for you. That's the idea behind. The fact that they had to come up with an entirely new version too, that is very uncommon, at least for as far as I know on AWS, means as well that they had to hit some certain limitation on the version 1 that they couldn't get out, keeping the same approach. So I'm curious to see what's going to happen and how much more databases are going towards the direction to offer serverless version of current open source databases, or anyway current standard, what I would call standard relational databases, versus offer SQL compatible database or kind of variant or engine like from Cloud Spanner, or as well Dynamo as well offers now SQL interface. Like if they're trying to move the developer more away from standard SQL, or they're trying to offer the full solution. I don't have I still think that relational database is here to stay, because moving out entirely it's going to be
Yeah.
a long way to go.
A hell of a job, indeed. Indeed. Thank you very much for your time, Renato.
Thank you.
I'm sure we can reach out to you through Twitter or LinkedIn. You're always available if people have follow-up questions. Awesome. Thanks a whole lot, and we let you go back to your wonderful Berlin.
Okay.
See you next time, Renato.
See you. Ciao.
Thanks a lot. All right, everybody. So we already are up to our third talk, but before that, we're having a short break. And I just wanted to show you as well that you'll see on your screen that, well, just look at the free workshop for tomorrow. There's free workshops that are available. This information would be available during lunch break, so don't mind the little lunch break at the top, but please look at the free workshops that are available tomorrow. We have 4 different workshops, and believe me, you don't want to miss them. You can still book your seat at the link that you can see below. We have people coming from all over. We have 3 workshops in English, one on DevOps, the other one's on building microservices, and the third one on Cloud Native Java. And the fourth one is the French one with Etienne Deneuve, Infra as Code. Well, you know, this is everything we're talking about at the moment, so please don't miss them. They are still available for now, so don't miss it. All right, you guys, I will leave you to a short break. We'll be back in 10 minutes. I'll see you in a bit. Hi again. Isn't this music awesome? I mean, I don't know about you, but I've been dancing over here. So, again, thank you to the artist and the whole design team that's been doing this wonderful job. TheCloudFIrst is really gifted with a wonderful brand and a wonderful design and everything. Gotta love it. That's what makes a cool conference as well. All right, everybody. So it is 10:40 Paris time, and we are welcoming a second French speaker. We will obviously be speaking in English for you guys and girls. I will welcome right now Johan Lazorza. Lazorza.
Hey,
I'd like to
everyone.
pronounce that right. Hello, Johan. How are you?
Oh, very good. Thank you. And you?
Doing awesome. I'm being energized by the whole, spirit of this conference. So yeah, doing great, and very happy to have you this morning. Johan, where are you located right now? Where are you based?
I'm in Grenoble right now.
And you're lucky you're not in stupid Paris as I am. So thank you for being here. And actually, I've heard a few things, and I can see in your background that you have an arcade machine right there. Is that right?
Exactly, yes.
Is that the one that you built yourself?
Yes, it took me like almost a year to build it, but I'm quite proud of it. It has been a dream for me like since I was a little kid and spent too much time in the arcades.
So now you don't have to actually pay for it every time. You can just use it as you want, right?
Yeah, but I was considering adding this coin setup so my kid don't spend too much time in my office.
That's very smart. And where did you get that one? Where did you get it?
You can just order it on the internet.
And then you just build it yourself. So can we place order?
I had a friend who tried, but already with 2 kids right now, I don't have the time to build another one.
Oh, come on. I'm sure you'll find sometimes. We'll make it work. I promise we'll make it work. Another thing that I find out about you is that you're a Beat Saber fan. And I'm as well a Beat Saber fan. I'm not a fan, but I'm working my way there. So what are your best tips to be a champion at Beat Saber?
I'm not sure I will consider myself like a champion at Beat Saber, but one thing that helped me quite well just try working with the higher difficulties is like just like train a bit, take some time every day, like 10 minutes a day, just to try to improve again and again. And just don't. The one thing that I didn't like is like if I don't like success in a specific song, I just try another. I just don't get stuck on the same one.
Don't get stuck. Yeah. I'm trying the campaign. I'm trying to go through the campaign so I can improve my level. But it's a nice way to just breathe at the end of the day. Gotta love it. I think I will do that, the whole of us, at the end of this session, at the end of the TheCloudFIrst this tonight. We'll go blow some steam on Beat Saber, I believe. All right, let's get down to business. You are going to talk about highly available, distributed, and resilient software team. We're going to talk about human today with you, Johan, and you're going to give us a few inspiration from the architecture of our applications to improve the communication within the teams. Thank you for doing that, because being all distributed today, it is a pain, and I'm sure that we can learn a ton from you. So here you go. I let you go into your presentation, and everybody feel free to show your questions so we can get them at the end of the session for you. And have fun.
Thank you very much, Aline, for the introduction. So I'll start with this talk that will present like how I worked for like the past 2 years in a fully remote team, but you'll see that it will have like a small twist in the way I'll present it. So I first start just by giving you a bit of a backstory behind this talk. As Charlene said a bit in the introduction, I live in Grenoble, and I'm a developer at heart that grew up in this region. As you can see from the picture, it's quite beautiful. And it happens that I like to share a lot with others around many subjects that includes tech. And since about 2 years now, I wanted like to take a change in my career. I've worked for more than 10 years as a software engineer, and I wanted like to try something new, and I wanted like to try this new role that has been like taking me for a long time. It was the job of developer advocate, but it came with one issue. It's like quite a restricted club with very few open positions, and most of these positions in France are in Paris, and I don't live in Paris. So that's ultimately what led me to start a new job as a fully remote in a fully remote team. Even through really at core, I'm like a person who prefer in-person interaction. But we all have to adapt, especially with these times. So why this talk? For the past 2 years, I learned a lot about working remotely, like not having your colleagues in the room next to you. And I wanted to share a bit of what I learned on what works and what doesn't. And as I already tried a few times to talk about soft skills, but since I'm mostly a tech guy, I try to like tie this talk about tech concepts that I found for me much easier to explain rather than tying directly to explain how things works for human. So you'll let me know at the end of this talk if you find this approach interesting, if that works. So who am I? So I'm Johan. You already learned a bit about me in the introduction, but what is most important is that I now work as a cloud developer advocate at Microsoft in a team that is distributed worldwide. As you can see from this picture, all these little dots are like about location for all my colleagues. If you zoom in a bit, you will see that it's very more scattered. That's what it appears on that picture. And we are about like 150 people in that team, and everyone is working remotely. So what this talk is really about, it's like an experience feedback from these 2 years I've been in that team. And what I would like to give you is maybe some ideas to build or improve your own communication model for you, especially if you're working remotely right now. So I will talk about distributed system because that will be like my main angle of approach. And I will talk mainly about 3 specific pain points of this system that are geographic distribution, how to scale distributed system, and how you make sure that they work reliably over time. So for you to be able to follow along with what I will be explaining, here's like a very basic mind map, as I will be explaining mostly tech concepts. And then we'll do like a mapping with how this translates to the human world. But when I will be talking mostly about data, that means that you can map them to like information you may want to circulate with other people. And when I will be talking about service, that mostly maps to a given team. So now let's dive into what kind of problems you may have regarding geographic distribution when you're working with a distributed system. I will only cover some of the most common problems, and one of the most common issues that you may experience that is different if you like have all your servers and all your services located at the same place is the latency issue. If you try to request some data to a server, for example, that is located at the other side of the earth, you may experience a delay in receiving this data, sorry. And that ultimately may lead to some kind of synchronization issue. For example, if you try to send data to service A, and this service A need to process that data, do some stuff, and then send back some other data to another service that may require also this data, it means that at some point, at a given point in time, your data may not be fully synchronized between service A and B because they are not located at the same location, and obviously there's some kind of latency due to the network transport and the distance. And this leads also to a new kind of problems that you may experience is that you may experience also, and you have to take account currency issues. That means that data across the network may not be the same because you have all this synchronization and latency issue. That means that if you're querying data from different sources, you may not experience the currency you would want to expect, or at least that's easier to have when you have everything at the same place. So now let's talk a bit about possible solutions that you can use to overcome this kind of problems. First, to overcome latency in distributed system, there's something that is very common that we use all the time, is caching. And especially if we regard latency that is tied to the geographical location of the data of your service and servers, is that putting in place a CDN, a content delivery network, meaning that basically you use servers that are as close as possible as the service or clients that try to consume this data, to reduce the latency as much as possible. So that's one possible approach to overcome this kind of latency issues. Now there's another possible approach, is to use aggregation whenever it's possible, meaning that instead of querying a bunch of servers, each time you need some information, you try to regroup all the data you want to query, send one request, and then gather this data before sending it back to the clients, to reduce the number of back and forth over the network, and ultimately reduce also the latency. Now, jumping a bit forward to talk about currency, it may not be what you would want, but one approach to overcome currency, if it's a critical issue for your system, one of the simplest way is to centralize the data at some point, because if you want to be sure to have 100% currency for that specific data, you just put it at one place, so you're sure that if it's changed at some point, everyone who will query it won't have any synchronization issue. Of course, that may be a bit difficult if you use a CDN or something else to reduce the latency, but that's a possibility. Now, talking about the most difficult one, synchronization. You really can't overcome synchronization over the network when things are located in different places, because it's not possible to have the data teleported instantly at different place at some point in time. So what you can do through is implement a transactional system, meaning that the time you want to pass on the data and make sure that it's synchronized within all your services within a given system, you block simply all other clients to make sure they wait until you have the go to know that all the synchronization you need has been performed. So other clients are sure that they can query data from a stable system. So of course, this little schema is very simplified compared to what you would find in a real distributed system, having an implementation of two-phase locking and things like that. But it explains, in simple words, what is the principle in how you can solve this kind of issues. Now I've talked mostly about systems, but how does something like this translate to the human world now? So again, a little mapping table that I will take some time to explain. So when we are talking in distributed system about caching system or CDN, and also kind of different issues, but aggregation, how do you overcome latency? One thing that has been really helping us in my current position, but also in my previous job when I wasn't working locally, but the teams remotely, but the teams were at different locations, is having this role that we call in Microsoft PM, Program Manager, but the job title might be a bit different, but the idea is that you have a team, you have some people that are not directly in engineering teams, but make the link between all the engineering teams and support people and everyone. Basically, they act like horizontal bus to like make data easier to circulate between all these teams. They can also aggregate data from you. For example, if you need some information from different teams, but you don't know who you should be asking to, that's like your main point of contact that will help you tackle this kind of issues. If you're in the development team, your team lead might be also like one point of local cache for information, especially about technical question you may have, instead of going like company-wide asking question about how you can tackle a specific issue. And for any HR question or discussion you may want to have, like your manager is like your HR local cache. So as in terms of people, that works a bit like that. As for centralization, you really don't want to put people like as a one centralization point, especially if you're working remotely, because just like in distributed system, that person will become instantly like the single point of failure. And in case something goes wrong, like you lose any mean to like have backups and things like that. So really, you don't have like to centralize information behind a single person, and you want to avoid that at most cost. Now, speaking about tools, because there's not always a way to map like some approach to like people. As for caching, one thing that we can do, like and that we did in like my 3 previous companies and also at Microsoft, is that like we have regularly, almost every week, all hands meetings, meaning that all the leadership team can explain what's going on with our current project, and people can take and speak in front of every teams about how things are going and share their experience and their project and things they learned. So it's a great way like to distribute information among a large number of people. Among like smaller team, your inner circle, it's also really important to record every meeting, just to make sure that everyone can catch up and get the information if they miss the meeting because of like personal organization, or just because you can't attend it because it's not as a right time for you. And something also that may come really handful that we have, especially if you have a lot of meetings to catch up that you can attend, is having like this minutes email. Basically, it's a recap of everything that was discussed during the meeting, just the important points, the question that may have been asked, and the decision that are taken during these meetings. So you can just, instead of recording like watching a full length 1 hour recording of every meeting you may have missed, just read like this 5-minute recap email and be up to date with everyone. As for aggregating data, especially as remote workers, we try to rely a lot on asynchronous communication. I don't know if you are aware of the nohello.com website, but basically it's like a sort of common etiquette when you're working with asynchronous discussion tools like Slack, Teams, and so on. Is basically just don't ping people with just saying hello and wait for them to answer before asking your question or starting the discussion. Just give them a bit more context. So as a developer, I really hate when I get interrupted if I'm in the middle of a particular development, and just see the message that just say hello, and then I need to come back and answer and wait another 5 minutes for the other people like to give me what they were really wanted from me. So just give more context, and that works with emails too, especially as remotely we may exchange a lot of emails. So just don't assume that the people that will be reading your emails already have read like your previous email from a week ago. Just always give back a bit of context in every email you send, so that you don't have like to ping back the people to say, but okay, you need help, but what is exactly your project, where I can get this information? Just give all the context you need for an email, especially if you send it to a lot of people. That's what I really learned, and that's what really changed for me working in a remote context, as opposed as like if you send an email to your coworker that is working alongside you every day, you may not have to give all the time this bit of context, but in a remote team that really helps. As for centralization, surely you don't want to have people, as I said, but as for tools, it's really important, like at some point, to centralize specific bits of information at one place to make sure that everyone's know where to find, for example, how to find some tech information and what you're working on. So having some kind of knowledge base, like in Internet Stack Overflow or Wiki or something that works best for you, is really important. Basically a place where you know where you can get information before having like to find some people and like bother them to ask questions. And also something that we didn't use at the beginning when I joined the team, but we started to use it more and more, is like to act like any engineering team. Even though I'm not doing like developing a product every day, we still use a backlog for every task we do. And this has the benefits of giving also visibility on what you're working on and creating also opportunities for collaboration because you see what other people are working on more easily. As for transactions, there's like no way to synchronize everyone at the same time other than like having meetings. I personally avoid meetings as much as possible because like it's up really easily a lot of your time, but sometimes it's really essential like to have everyone synchronized at the same time, especially from your inner team. This is something you can't avoid, but you have to use it really sparingly. Of course, I made this parallel, but we have also, we are not machines and we have our very own human issues. And one of these issues is that we have, unfortunately, we have downtime. We can't work like a full day, 24 hours a day. We have to sleep sometimes, we have to eat. So that's why when we're working remotely, we have first to think about asynchronous communication. But some kinds of things that you can do also is to always let your coworkers know when you're up to work and to have a chat, and where you're not there to answer them, and the answer that may come later. And especially if you work like me in a worldwide distributed team, this kind of website will become essential for you every day because you will always be wondering in which time zone your coworkers are. That means that if you have this kind of team, synchronous communication is like something really difficult. So first, you really want to like try to get the information you need through asynchronous meetings using chat and emails first. And this is something really that you have to learn to do with, especially having been a developer for so many years and having like my coworkers just in the chair next to me. I know this is most probably not the best way to get something answered, but if you have like a tech question and you know that the person just right next to you have the answer, sometimes like even though I might be bothering him, like having a 2-3 minutes chat about it might be the quickest way to solve my problems. Unfortunately, that's sometimes that you can't exactly replicate when you're working remotely. You don't know if your coworkers are right behind the screen at a given point in time, so you have to organize your work around asynchronous communication. So now, next thing is other kinds of issues is how do you scale when you're in a distributed system? Some kind of issues. The first one is the overload. If you like have your service just you send it too many requests at some time, it may go down, like everything's crash and you don't get any answer. Another kind of issues is how do you make sure the data circulates correctly? How do you make sure that like you won't end up in a mess of communication mesh like this picture? So possible solution to overcome this kind of issues. So for load issues, you may already be aware of that, but most likely, if you want to scale up a server, you have two kind of possibilities. First is like to add more power to your very own server. That's called vertical scaling. You add basically a better CPU, you add more memory and things like that, or you change up your virtual machine for a bigger one. And the other solution is like you take your service and you replicate it, and then you distribute the load between all those replicas. That comes to another parallel that is like more an architectural solution. Instead of having all your services coming from one server, with everything being like in a monolith at the code being run from the same place, you just split up every service you need in different server. That's exactly what you do when you're implementing microservices. And the fun fact is that there's not really a need for parallel here with humans, because microservice also aims to solve issues that you may have with big teams when scalability at some point may become an issue. As we are also here at Microsoft, instead of working all the time like with 150 people, we are also split in smaller teams that are focused on different things. So that's what you do with microservices. And so when you try to overcome load issues in terms of data, if you have too much data, how can you split it like in different databases at different points? So you use sharding, of course, but then the most important question is like, what is your criteria for dividing this data? Do you do it by user? Do you do it by like a kind of data, like images, JSON, or things like that? Or do you do it like by geographical location? There's like kind of other questions to solve that, but basically you split up your data to not have too many at the same point. Now, how you like try to reduce the lines of communication between all your services. Basically, what you want is reduce at as much as possible service-to-service communication, and to do that, one of the best way is to try to make each service as autonomous as possible, meaning that you try to decouple things as much as possible. In a microservice world, it's already a best practice to make sure that you have like one database for each service, so you don't have like to go through another service to get some data or update some data. Another approach regarding data this time, if you have like a very huge amount of data, if you're doing big data, you can't like process this data at one place because it might be located in a different place at a time. So what you have is like this MapReduce approach, where first you try to process the raw data that may be located at one place to make it like in a more usable shape, and then aggregate this data from different places and try to process it then to extract the essential information you want. That's one of the most common algorithms that you used in big data systems. That can also be translated to the human world. So just as last time, I'll talk a bit about how we can translate this kind of solution to human. First, as for scaling, that might be obvious, and it's something that as engineers we don't like to hear, but recruiting more people is like one of the only way to try to scale up, but doing it just the right way is really important, because as you may all know, just adding more people to a development team doesn't really make it faster. That's where also it may also be important to think about maybe creating new teams or just reducing the scope of your team to make it more focused. That's also the point with microservices. The idea is to always keep small teams at the time. And in my larger team, we're all split up in I think the biggest team is like 5 to 6 people. And we all focused on different subjects. That's where you can really translate sharding, is that you give each of your team, each of your small team, really focused specialty. And to give them also a sharp focus, one of the tools that you can use is to define team-specific objectives and key results. So you're sure that a given team just don't wonder too much about working on subjects or tech questions that aren't really their focus. So by giving them specific objectives to each team, you're sure that every team is focused on a different set of working points. And then one of the most important questions is to reduce communication as much as possible, and especially back and forth when you're working remotely, is to give as much as autonomy as possible to each team, meaning that each team should be able to like make its own decision without like having go back and forth with the leadership all the time, or getting approval from other teams. It may be needed sometimes, but by giving each team as much as autonomy as possible, that's really one way to go way faster, especially in regards to communication. Now, as a translation to map reduce, I think your manager may already know doing that very well, especially because like he's most likely the person that gets the information from above, from its own manager and the leadership team, and then translate it and give you like a resume of everything. And as for tools, if you want like to aggregate data from a lot of people at some point, I find the Ask Me Anything format that we use also at Microsoft company-wide. So meaning that any person could ask question to all the IRBs, meaning especially like the CEO and CTO. That's really useful, like if you want to have all the data at hand from everyone. And again, having minutes from meetings is also a good way to be able to follow along with what has been said in like teams or meetings that aren't like your priority focus, but you may still be interested on what's going on in other teams. So having minutes and debrief emails might be really useful for that. Now, I'll talk about a different kind of problems you have also in distributed system, is like making sure that everything works smoothly. And how do you tackle like reliability issues? So some kind of issues that you have is, of course, as with any systems, you want your application, you want your big system to be available all the time, meaning that you make sure that you have like no service interruption if one service goes down for one reason or another, like having a DC that goes down suddenly or things like that. You don't want to lose data, of course, especially if it's like a user who's trying to save, who sends some data into your service, and then your service suddenly something goes wrong and everything crashes. You certainly don't want to lose any data in the process. And how do you make sure, especially if you don't have like all your server in the same room as you, how do you make sure that you can monitor everything to make sure that your system still works fine? So some kind of possible solution for that. So when you want to implement high availability, the first thing that you want to do is like load balancing to make sure that you just don't overload one given service at time. And the idea is that you divide the load between different services. That's the role of the load balancing approach. And one thing also is to plan ahead in case of what if something goes wrong. You must implement like a strategy in case like if your service goes down at some point, how do you like continue to make your system working? So you have to plan and have like a failover implementation. The key is probably to have some redundancy in the system, or at least like to know that if some server goes down, you have like another one that you can use or put up quickly to just take the relay of the one that went down. To overcome data loss when you have like storage issue, this is something that we should all do all the time. It's backups, because once your data is gone, it's really gone. It's not like a server or an application that you can just spawn a new VM, even if it takes some time, or just spawn a new container. If you lose data, you have already no way to recover it. So you really have to think of a backup strategy. When it's time like to write some data and you want to make sure that the data is delivered at a given point, That's where message queues might be really useful. Basically, you use like an intermediate storage that implements some kind of delivery guarantee, meaning that if your service goes down at some point, it's still okay, because when the message queue didn't receive like the acknowledgement that the data has been resaved and stored correctly by these given services, it's still saved in this storage queue, and the data will be sent back later if the service is done at some point. Now, if you lose data when you're trying like to query some data, if you're trying to read some data, the solution is like more easy. If you don't receive the data that you want, you just retry. You may retry a few times. If it's not working instantly, that may mean that your service is down. So you just try again at some time later until you get the data you want. As for monitorings, there's a lot of ways to implement monitorings, and one of the simplest solutions that you can put in place to have like this minimal monitoring is having a central place where each one of these services just report back, like maybe every minute, every 10 seconds, just to say that, okay, I'm good, I'm still there. That doesn't mean that it's still working correctly, but at least you know that it's there. And if some service doesn't respond back, you know that's probably something is wrong with this one. Now, if you really want to implement proper monitoring, you need to measure your system, and what to measure. This is really the quick question here. Especially, you may all know, but you need to measure what matters really for your given use case and application and what you are trying to accomplish. From the data you get, you try to define metrics. And basically, metrics define what are the goals for your application, for your system, what are you trying to achieve. And you surely want to be to know if something goes wrong along the way. So you have to set also alerts to be sure that you can react in case there's too many errors because like the latest version of the software you just deployed didn't work correctly, and your API just send errors half the time. So you have to set to use the data that you have to set up alerts. Now, how do you translate it to the human world? There's a much to cover there, but most likely in terms of disaster recovery, the first thing you want to think about in terms of people is that your teammates are in best position to help you, if you have an overload of things to do. That's how you can leverage load balancing, just distribute all the tasks between your teammates. And if you also have some personal issues and you need to be off, even if it's at some point you didn't want, for example, if you break your leg during the ski season, which is not really likely to happen this year, but it's good to know that your teammates know everything about the work you're doing and are able to continue, and not everyone is stuck because you won't be able to just work on the things that you plan to. They're also good backup solution in any case someone you're not there, for example, during a meeting, and someone just has to answer some question related to what you're doing. As for load balancing, in terms of tools, time zone actually might become really handful, especially if you need to have on call, and if you have SLA for your services, you can just divide the work among the different time zones to make sure that you don't have to get up at 3 a.m. in the morning because you're on call. But it's really even more important than where you have your colleagues locally with you, is that you need to write a lot of documentation. If you're doing development, pair programming is still possible remotely, and it's even more recommended to do more of that, especially if you're working remote and you need to share a lot more information that what you should do when you're having all people at the same place. It's really important also to put as much as data in your knowledge base. And one thing I also very like to do before going off, for example, for vacation when it's planned, at least, is like to send this handover emails, just like a quick email to your closer team to tell them what you were working about and what's the status of your work. Is it finished? Is it half done? And things like that. And where to find like the information they need, like the code or the docs, if they need to take over the work you were doing, or if they need to answer a question about this work while you're away, they can do that. Basically, it's like making the life easier for everyone while you're off, and it's like a really good backup plan. As for make sure that everything doesn't go unnoticed when you're remote and you don't forget to do everything you need to, having like a backlog, especially for your team, is really important. But in terms of backlog, I mean for every kind of task you may need to do, not only like the development tasks, but also like the kinds of maybe like writing a documentation should go in your team backlog. Any kind of task like maybe entering your expense or anything that might take some of your time should like go in this backlog. So first for you, because it can also act as your to-do list to make sure that you don't forget to do everything, but also to show you what you're working on and give some visibility to your team. It's really easy when you're working remotely to like miss some call from your colleagues and to miss some information. So that doesn't mean that your colleague don't want to work with you, or like they don't like you. Sometimes that comes up a lot for first people trying to work remotely. And I was like wondering for a few times, like, hey, why this person doesn't want to answer me? Is it because they don't like me? No, most of the time is that just they didn't see your message, because for many reasons, everyone has like his channel preference. Some people prefer like to work with emails. Some actually don't and prefer like to have you send you like a message or on Teams or Slack. So just try different channel. Make sure you follow up with people when basically you're working together on something to make sure you know the status of your teammates and if they has any issues. And also as for keeping your team up in shapes, having some kind of some sort of health checks within your team is really important. That's the role most likely of your manager, to make sure that everyone is okay in your team and don't experience any blockers or any kind of other issues. But it's also your role as a teammate to make sure that you know that all your other coworkers are okay, especially if you don't have like them under your eyes all the day. It's easy when you see if someone goes down because it's like 1 meter away of you. It might be a bit more difficult when you're all working remotely. So it's really important like to have this casual chats or like maybe just remote coffee, things like that, to make sure that everyone is okay within your team. Something I also enjoyed doing, but for now it seems that it has stopped, and for me it's like a shame. I did that for like about a year in my team, is like sending a status report every week. It was like a quick status to the wider team about like the 3 most important things you did last week, in just a few words, the 3 most important things you plan to do for this week. If you're blocked on something, if you have something like any more to share, and how you are feeling to go into the next week. If you're down or something for maybe personal issues, that's also a good way to let other people know. Just ping some people, maybe just if you don't have like time for a full chat, just send them like some friendly message. It's always appreciated. And as for if you're like a manager and would want to get a picture and also honest answers about how things are going on, anonymous surveys are really like useful for that, especially as some people maybe don't speak up like in meetings, or don't want to say that something goes wrong. So sometimes it's best to do things anonymously. And as for monitoring, that's probably the most important thing to do for your leadership team, and define like the objectives, create dashboards, and most importantly also give full transparency about where you're going as a company, as a wider team, to give you like the direction. So of course, there's a lot more that I could speak about, but our time here is limited, so I'll conclude this talk. And my conclusion is that, it might be helpful like to modelize your organization as a software architecture. It might help you maybe to find some more pragmatical solution, but you don't have to lose the fact that there's something essential that you might be missing, especially in this distant world where like we tend like to no longer exist only through what you're producing and not because of yourself. We're still human after all, and we need positive things in our daily job. Like we also need to be able to tell if something is wrong. So share fun facts, just ask, are you okay, to your colleagues, and also share success. Something that was really great in my previous company is that if something like I made some sort of accomplishment, like the new feature delivered in production, you just send this woot email to everyone in the company. Also, it's even if you're remote, it's possible to have like team activities, like games, cooking classes, do some like remote coffee sessions or remote escape games. You can think of anything, and don't forget to take break. Thank you. I hope you enjoyed this talk, and if you want like to get access to the slides, you have this link there. And if you have any question, let's go ahead with that.
Yeah, human after all. I like the little Daft Punk reference here. Much needed. Thank you for all those good reminders. We have one question for you, Johan. If you had to start from scratch, what would be the first two things you would do with a brand new team and everything?
One thing I did when I started, and I will do today if it was again, is like just try to casually catch up with as much as possible with everyone in the team. At first, I was like a bit timid and afraid to like bother people doing that. But I think it's the easiest way to like get friendly and get to know the other people in your team, especially as when you're all together in meetings, you don't mostly have the chance to get to know each other. But doing like just short one-on-ones, maybe 10 minutes with like everyone in your team, just to get to know each other a bit, is really helpful, and really helps after that when you're working together.
And one last thing that I will take away also from your talk is you talked about OKR and how we can make them as transparent as possible. I believe that most of the time we don't know what other people are working on or how we can help them. By making sure that our OKR are transparent and available to everybody. Well, at least this is something that I take away from your presentation, and I would like to implement on my end. So thank you for your time, for all the good tips, and for talking about who we are, humans after all, indeed. Thank you so much. And we can keep up with you on Twitter, and
Yes.
You're always available. And thank you for that a lot, Johan. Let's talk soon.
Thank you for having me.
Yes, and thanks again, Johan. Let's talk soon, and we'll move into our next session within the few minutes. So let's take a quick break. See you.
See you.
Hi again, everyone. I hope you're still energized with all that great energy and music going on. So next up, Radu will talk about everything you need to know about cloud migration. Let's welcome Radu. Hi.
Hi guys, Servus. Thank you for joining the conference and my session.
Thank you so much for being here. Where are you based, Radu?
They're pretty good. I'm very happy that we have a good weather outside and we are now able to do more sports and activities around the house and maybe somewhere, anywhere from our offices or rooms where we stayed for 1 year.
Cool, cool. And where are you based? Where are you right now?
Well, I'm based in the middle of Transylvania in a city called Cluj in Romania.
Awesome. Again, we have people and speakers coming from all over. This is what's so great about this conference. And Radu, so I've heard that you're a bit of a crazy Azure certification guy. You did like some kind of a speed run with Azure certification. Isn't that right?
Yeah, exactly. So in the last 6 months, I've put it as a personal objective to take all Microsoft Azure certification. Initially, I thought that there are only 3 or 4, but I think that in total I had to take around 19 or 20 exams. So it was a pretty
in 6 months.
Yes, in a 6 months period. And now I've done the next phase for the next 6 months, targeting the AWS ones. The same thing as for Azure. So let's see how things go in the next months.
I'm sure you could share a few tips to people that are, starting and having the same goals as you. It must take like some strong commitment.
Well, if you want to find more about, just write me on Twitter or LinkedIn, and I'll be more than open to share. I don't want to share during the conference some names of the training vendors that I used, but there are some very cheap video content that can be used to be able to get trained. So for example, per exam, the cost of trainings were around 50, 60 bucks. So it is pretty cheap, but you need to know exactly what are the right trainings that you should use for each exam.
Yeah.
And be ready to learn a lot.
Be ready to learn a lot.
Yeah.
And that's what is this conference also about, learning. And what we're going to learn from you is everything you need to know about cloud migration. I'm sure there's a few things that we believe are true and that we should be maybe careful or aware of. So I'll let you go with your presentation. You have fun, and everybody feel free to shoot your questions or remarks in YouTube, chat, or Discord. See you then.
Okay, guys, so let's start. For the next 40-45 minutes, we'll talk about cloud migration. Well, even in the title, we say that everything that we should know. The reality is that there are so many things that we are not aware of, we don't know. And I was impressed about how many cloud migrations are failing. And the most challenging part is at the moment in time when you are looking on why different migration failed, and it's not about technical causes. Most of the cases are from the planning, how you are taking into account different things, how you do the planning, the KPIs, and so on. And this is what I want to focus. So it will be a mix between some tips and tricks about different things that we need to take into account, and the moment in time when we decide to adopt a migration framework, and some more hands-on and technical side things that we need to be aware of. So let's start with an example. Imagine that you need to do a migration of a warehouse management system that has around 3 different warehouses on a radius of 10 kilometers. There are around 800 employees that are working 24/7. And usually you have around 20,000 goods that are entering in the warehouse. You need to prepare them. You have a lot of integration with third parties, delivery companies, and so on. The initial vision of the migration looks very simple, very good. Well, we are taking everything that is on premise, we are putting inside the cloud. The operational cost will go down. It's more easily for us to do running optimization when we need to scale up and things like that. Everything sounds very good, except when you end up with the reality. When you realize that from the final cost of the migration, the additional cost that was added is 200% more. Not only this, but the initial program was a 9-month program, and after almost 3 years, you are still not fully migrating. You are lacking of features that were migrated, or there are some systems that were not able to be migrated and to run as expected. And the operational cost, even if the initial estimation was that it will go down to around 40-50% of the on-premise cost, you end up with 1.5 more operational cost than initially. And why? Because you have at least 2 different environments and 2 different type of systems that you need to manage, the ones that are running inside cloud and the ones that are running on-prem. There are a lot of things there that you need to be aware, you need to take into account, and let's talk about them. I was already presented. What I would like to mention from my side would be that I'm working for Endava as Group Head of Cloud. I started to work, my first commercial project inside Microsoft Azure was in 2010. And also around 3 or 4 years ago, I started to work very intensive with AWS. And I'm also Microsoft Regional Director and Microsoft Azure MVP. If you have any kind of question related to cloud, how to learn, how to train, or you have issues, especially with Microsoft Azure or with AWS, please let me know. Just drop me a line on LinkedIn or on Twitter, and let's have a talk. Okay, let's see some statistical information to realize the gap that we are at this moment in time from how well we know to do migrations. Statistically, 90% of the companies are on the cloud with one or multiple services. Don't think about that they are fully in the cloud. No, they have some services that are from the cloud. Worst case, only Office 365 or some storage, but also in other cases, they could have more application, more systems, and things like that. From that percent, cost optimization is the primary reason for around 50% of the enterprise that are looking at cloud and why they want to do migration. Even so, cost optimization is not something that is very easily achieved if you don't plan very well, if you don't know exactly what you want to do, because otherwise it's very hard to track the success of a migration. And only after 1 or 2 years after you finish the migration or are struggling with it, you realize that from the figures point of view, if you are where you had to be, or there are some things that you need to work on. Especially starting from last year, everybody's loving cloud. I see a more trend that multi-cloud becomes more and more appealing. Even so, remember that when you start a migration and you have a multi-cloud strategy, you might not be able to use so many software as a service and platform as a service offers that different cloud vendor has, and this might generate some extra cost, and especially from the learning curve and from the migration effort, that could have a direct impact. Now, public cloud adoption continues to accelerate, and especially with the last few days, when maybe you heard that there was a small cloud vendor provider somewhere in Europe that had fire, and one of the biggest and most used gaming platform lost part of the data. This is very important to know exactly. Even if you go on a public or private cloud, think about the quality attributes that you would also have normally on-prem. Don't assume that are by default active inside the cloud. Ensure that they are active. DR, backups, especially backups in other regions or in different locations. And this is why I usually recommend for people to go with large public vendors. And why? Even if in one place, in one country, you have only one region from that cloud vendor, that region, the cloud region, is formed from multiple data centers that are connected between them. So backups in the same region are done on the fly, and the risk to lose data, or even, let's say, the worst case to lose the backups of databases, are very, very small. Even so, even if we have all the PaaS and SaaS offer, companies are struggling to control the cloud economic part, to be able to control the cost, the running cost of the cloud, and so on. And we will see a little bit later why and what we could do to be able to do some optimization and to handle this. Now, what we'll cover, there are 4 main aspects. Why a cloud migration fails. We'll take a look on Azure CAF, Azure Cloud Adoption Framework, a very similar framework you will find from AWS, and something more simplific, I would say. You also can find on GCP, but basically the ideas, those concepts are the same. Also, we'll take a look and we'll combine this framework with what kind of tools and templates can be used to ensure the success of your cloud migration. And in the end, we'll take a look on different strategies from the migration point of view, and we'll have 2 hands-on part where we'll see exactly what kind of migration strategy we should use on different contexts. Now, how a cloud migration can fail? Well, the causes are a lot. There are a lot of causes: time, budget, scope, SLA, quality metrics, KPIs, NDS, skills. I would say that this one, we are forgetting about the skills. We are assuming that we have people with the right skills that would do the vision, the strategy, the implementation itself but there are a lot of skills that we need to take into account. If you are migrating to cloud, doesn't mean that you don't need any more an infrastructure guy. No, you still need that person that would do the infrastructure landscape, the design of the design of the landscape of the infrastructure, networking, appliances, virtual appliances, IP class, and so on. So there are small things that we are assuming that we don't need them anymore inside the cloud, but the reality that we still need them, even if in some cases the effort from different roles might be a little bit smaller. Something that I was impressed, and it's still shocking me, is that 3 or 4 applications migrated to cloud moved back on-premise after failing to achieve the anticipated benefits. It means that around 75% of all migration projects and initiatives that started failed. And customers, stakeholders, business key people, what they decide to do? Let's move back on-premise. And I saw in many discussions that people are complaining about the cloud vendor that they don't have very good they don't have very good services. They don't receive what it is promised, and so on. But if you go in an analyze part and you try to do a post-mortem to understand what happened in reality, guess what? The framework, the way how the migration of the system was done or was designed was not aligned with recommendation best practices, and was more something like, okay, let's try to take 1 or 2 apps and let's see how they will work inside a cloud vendor without applying all the recommendations that the cloud vendor have. Okay, one of the main causes is failure to adapt to the cloud. So sometimes organizations expect that you would run in the same way the cloud application as you would run them on-premises. Also, we need to remember that the cloud is built in such a way to use resources only when we need them. From the cost point of view, this is very important because it's very easily to scale it up. It's very easily to put more powerful tiers that are, of course, are more expensive, but not too many people are thinking about, okay, how I could optimize the cost. Why I need 12 virtual cores more that I had on-prem. Why I need them? Maybe it's not because that cloud is lower. No, maybe during the migration somebody changed something in the code and the application is not so optimized. Let's take a look on the application itself and not just pushing more and more resources. Also, for the on-premises, the way how you do orchestration and the automation is very different from the one that you have inside the cloud. The only exception there, if you already use an on-prem microservice approach, like for example, orchestration solution like Kubernetes or OpenStack, then you might have a similar experience inside the cloud. But otherwise, if you would have the classical racks with bare metal machines on top of virtual machine and so on, you need to rethink the way how you do the orchestration and the control of the solution. And also the way how public cloud and in general cloud matters is that you pay for each thing that you are using. On-prem, if you just buy 40 terabytes additional storage, you just pay a little bit for the energy and nothing more than. But on the cloud, you'll pay for each of byte that you're storing, you are consuming, even the data that you exchange with outside the cloud vendor and things like that. So you need to be very careful exactly what you are using, how much, and if you really need to have that kind of service or to have the kind of feature. Also, we are forgetting to bring all the stakeholders on at the tables. And why? Many times I see that migrations projects are driven by IT departments. Yeah, this is great, this is awesome. Even so, you might not have the right key people on the table. You bring them only when it is too late, and you don't have clear business KPIs that would motivate business people to support and to sponsor that migration. If they don't see a real improvement on their business, they will not be very excited of of the migration itself. And the operating model that you have inside the cloud is not the same as you would have on-prem. It works very, very different. And even the procedures that you would have for a DR or for a failure are very different. So you need to take all these things into account in the moment in time when you build a vision and the cloud migration strategy and how the landscape inside the cloud would look like. Tracking, logging capabilities might be very, very different. And also, people are forgetting about cloud economics, how to handle them, what are the procedures, how to do the optimization, how to track cost. Nobody's taking this into account. We just have a bill at the end of every month and we are paying. And in most of the cases, we are seeing that the value is growing a little bit every few months. And after 6 or 12 months, you realize, oh my God, I'm paying 3 times more than was estimated, even if the number of users of the load didn't change. And this is crazy. Lack of planning, wrong migration approach, no testing, lack of vendor selecting, because I see that sometimes we are deciding what kind of cloud vendor to use based on personal preferences. Nobody takes into account the feature, the thing that we really need to take into account. Governance part, it's something that very rarely is done. Access control, security, compliancy usually are pushed somewhere in the future. We will do it, and you end up with the deadline to go in production, to go live, and you realize you don't have security, you don't have compliance yet checked, and you're trying very fast to do all these checks, and time is not enough. Also, the integration with different systems can be external system, can be on-prem system, needs to be taken into account. How you do this kind of integration? Do you need a VPN? Do I need to change the communication protocol? I might switch from HTTP to a message-based communication, or the other way around. Can I communicate still synchronous on a custom protocol over TCP? Or I need to switch to HTTP, a message-based or event-based solution, and so on. And let's talk, and later on I want to talk more about testing, because I also, over there, I see a lack of testing, not the application itself, but the things that you are building to be able to run that solution. So let's talk about a little bit about a landing zone. What is a landing zone? Think about it as an analogy if you are living in a big city. Everything that is seen as an utility, like water, gas, electricity, transport, are part of a landing zone. In our case, policies, access control, I usually compare landing zones from this point of view as a template, as the default template where you can layer your application or application. You might have only one landing zone. You might have multiple landing zones that could have a foundation one. Depending, for example, if you do a migration with 1,000 different systems, you might identify some patterns. Some of them are virtual machine where you're doing just a lift or shift. Some of them are web application and can run with success inside the Docker or inside Azure Web Apps. Just give you an example. Some of them are data processing and data reducing, things like that, and you identify other ways of how you can run them, and also the landing zone might be different. So landing zone is covering basically the primitives part and the governance part. A managed group, resource group, naming standard. So think about the way how you are doing the naming, the way how you build the original network landscape can be defined and reused inside the landscape. So when you decide to move another application, you don't start everything from scratch. No, you have one or some landing zones, and you can decide which one you want to use internally that is already compliant with all the organization requirements, from the legal point of view, from integration with other systems, from integration with on-prem solution, and so on. And also, of course, you have the governance part, where you have the cost monitoring policy. So basically, you are aligning different components. So Even, for example, the shared resources, you can identify and specify in a landing zone what are the resources that can be shared. Can be storage, can be a virtual network, can be a VPN connection, can be the way how you can monitor, you can define template, or even you can share the monitoring components, the access management, the policies, and so on. And I have a question for all of you, and maybe it would be useful if you could, for example, just write a +1 in the chat or in the comments if you have ever done a test on a landing zone or something equivalent to the landing zone. Do you have tests? Do you do test-driven development on the landing zone? I didn't heard very often, and many times we are forgetting about even the landing zone can be tested. And why this part is very important. Think about the way how you are doing the test of a landing zone can ensure that in time, even if the landing zone will evolve, will change, because you are adding new features, new requirements, you are adding maybe more components from the security, audit and tracking part, you still need to ensure that the original features, original requirements that were in the original landing zone are still checked. So as you are writing code and you do a test-driven development, the same approach you can have with landing zone. So basically you can write tests to validate a landing zone, validate different requirements. For example, from the policies points of view, if you are in the Azure area, Microsoft, you have the Azure policies, and to ensure that they are enforced and they are respected. After that, you can do the testing on the landing zone, and after that, you can add more and more feature. You can do refactoring if you want to do some optimization. You deploy the landing zone, and you're just testing it. And you have multiple ways how you can test. Yeah, it's not the same way as you would write a unit test for an application or for some lines of code. Even so, you have the ability to do this kind of test to validate that the landing zone is compliant with some organization requirements, with some local laws, and so on. Now, coming back more on the framework part, why do enterprise need to do a cloud migration? Most of the cases, the cloud adoption and cloud migration is driven by new revenue stream, cost optimization, new opportunities, and things like that. This is why it's very crucial to have the business stakeholders on the table and to have clear KPIs, how we are monitoring it. What does a cloud migration mean? Don't think from the technical point of view. Think about from the business point of view, because if you can respond to this question from a business perspective, you already have more chances to do a successful cloud migration. As we said before, we create a new business value and we enhance new modern features and capability to the solution. But in the end, it's all about cost. It's all about cost optimization, improvement, more easily to be able to scale, and so on. So how we do a cloud migration? How we do a migration? As I said, each cloud vendor has different frameworks and way of doing things. Let's take a look on the way how Microsoft comes with this how Microsoft comes to on this table with some recommendation, and we have the CAF, Cloud Adoption Framework, that has very clear ways how we can do a migration, what are the main drivers, and so on. So if you are talking about CAF and cloud migration, there are 4 steps that we need to be aware of: define strategy, plan, ready, and adopt. And later on, we'll talk about govern and manage. When we're talking about define strategy, it's about identifying the business stakeholders, write and a clear business justification why we are doing the migration. It's fine. Be very careful. We need to align the stakeholders. We need to identify, if you are part of the organization, the partner, can be internally, can be externally, that will support our cloud migration, to document very clear the vision and the strategy, and also identify exactly the KPIs. What are the KPIs to be able to do something like this? What Cloud Adoption Framework is offering to us? Some tools. like Cloud Journey Tracker or business outcome templates that can be very, very useful at the moment in time when we need to do such a migration. Because many times we are thinking about how we should put this on paper, where we are at this moment in time. So, for example, if we are taking a look on Cloud Journey Tracker, what will do will help us to know exactly where we are, what are the things that we need to improve. So there are just a few questions. Usually, if you are part of the organization that is doing the migration, it will take you around 20, 30 minutes to be able to fill the form. If you're not part of the organization and you are a partner or something like that, it might take you 4 or 8 hours because you will need to go to ask the right questions to different stakeholders and so on. But in the end, what you will get, you will get a clear view related to where you are at this moment in time, and what are the areas that you should improve. There were some questions that I skipped. I just want to show to you the final output because I find it very, very useful. And one second. I'm just putting something randomly because the previous session that I had was lost. So over here, I'm just putting now just some random responses because I want to show to you exactly the value of it. So now we should be fine. And let's see the output. And what is the nice of the output? That we have a guidance based on all the phases of a migration. Strategy, plan, ready, govern, and manage. We can identify the areas where we need to do some improvements. And also, we have some recommendation. What are the things that we should cover, the things that we should take into account, and so on. So it's very easy to do an assessment of the current organization or the migration that you would like to have, and based on it, to decide exactly what are the things that you want to improve. Now, the strategy template is very similar, but from another point of view. When you start the discussion with different stakeholders, you have here all the things that you want to identify. For example, what are the business drivers? What are the KPIs? What are the capabilities that you need to take into account? So you can define very easily what are the things that you are looking for, how you need to cover them, and so on. The next phase is the plan. When basically you are doing the plan, you identify, you gather all the data, you do the assessment, what are the workloads that you need to migrate, you put more on the business case, you create a migration plan, and you start to do the assessment of the digital estate. At this phase, usually the expectation from the customers is that you should start to have something. And it's a very good moment in time when you, for example, you can use Azure DevOps demo generator to scratch a little bit how things will look like. After that, you are in the ready phase where you have an MVP or you are doing a POC. You are defining the landing zone. So at this moment in time, you have the first version of the landing zone. And don't try at this phase to include everything. Just try to include or to cover the most important things. You start to share the plans with people from the organization, and this is a very important thing. Remember that the cloud migration itself doesn't have an impact only on the technology, also on the people, on the different departments of the organization that is doing the migration. So you need to talk with people, you need to make aware of this migration, of the things that might change. You need to assess the processes that might change and start to prepare the processes and the people for it, because people might change the way how they interact with organization, with different systems, and so on. And also they need to start to be aware and to be ready to do this phase. During the adoption phase, we basically are starting after a success POC to do migration of different systems. You can do this in parallel. Or, for example, you can do it one by one. You are starting to train people to know to use the new platform or to do the to be able to use the cloud services and so on, and you start to have a direct impact on how the internet is working across processes and so on. Now, there are two items that we didn't talk yet until now. The govern part, that is basically is you are designing and you do enforcement of access control, compliancy, you define the initial governance foundation, and you're doing the handoff of production workloads to cloud governance and so on. And what is important here that this is started usually from day 0, and in time you are adding more and more things here. So don't expect to have the perfect solution from day 0, no. But in time, after the POC, after a few systems that are migrating, you're adding more and more on this part. Because if you expect it from day 1 to have everything in place, it will be pretty hard. And this is how also the landing zone evolves. Because basically the landing zone evolves with every new iteration, adding more and more from the overall requirements. And also if you have a lot of business stakeholders, it's very hard from initial moment to have all the requirements covered and all the thing over there. The operational part it is in the menu that also is covering all the phases. And besides ensuring that the solution is working as expected, you need to be aware that you need to optimize resources here and consumption. So it's something that you are doing day by day, and also we can use different tools that each cloud vendor is providing to us. Don't forget that at each step there are clear tools and templates that can be used to spin up or to add more structure to the migration approach. This is where Cloud Option Framework, for example, is coming to help us. Now, let's talk about migration strategies. The migration strategies that are available on AWS and from Azure are to be different. The approach that I really enjoy and like is the one that is provided by AWS that have 3 different types of main migration strategy: rehosting, replatforming, repurchasing, refactoring, retiring, and retain. What rehosting means is basically just taking the machines, the virtual machine or bare metal machines, and just running them inside cloud somewhere. So you don't do any kind of changes to the systems. You, for example, just taking the Linux machine and the database, and you're just running on top of other machines inside the cloud. Replatforming is something that is something like a lift and shift, but you're starting to do some small changes configuration in the configuration or in the setup to be able to use some feature that the cloud vendor is offering to you. Repurchasing is the one that I really like, is at the moment in time when you can identify a SaaS service that is provided by the cloud vendor or by a third party that can fully replace your initial solution. And that's great. What you need to be aware that usually in this approach, the licensing model is changing from a license-based cost to a subscription-based. But also you have a lot of benefits. Refactoring architecture, basically it's you are redesigning the solution for cloud using all the juice things that cloud is offering to us. Retire is the moment when you realize that, oh man, I don't need anymore that app or the system. I don't know who is using it. Especially large organizations, it's easily to find, for example, a few systems that are just running. There's no business value to them. People are just pushing also data there because this is the process or this is the way how they used to do. And retain is at the moment in time when you decide, okay, we realize that it doesn't make sense to migrate that app at this moment in time or in the future. We will keep it on-prem for the next 3 years, and after that we will retire. Or we will, in 2 years' time, we'll do assessment again to decide exactly if we need to move it to cloud or still keep it on-prem or just retire. This is a diagram. I was not able to find a better image of the diagram that AWS is providing, but I really like the way how it looked like because it summarizes exactly what are the main steps that you need to do for each for each way of migration strategy that you can use. Remember that in general, when you're doing a migration, you will not use only one strategy. You could have a combination between them. Can be per application that you're migrating, so for each application to decide what is the strategy. Or you could, or in a large systems or application, you could have different strategies for different for different components. And we'll talk a little bit later over an exercise how this could look like. So when to use what? Let's start with the rehosting. Usually rehosting goes very well when you don't want to do any kind of refactoring or any technical activities related to the system that you have. You just want to take the current system that is pretty flat from the load, from the number of user and so on, just push it inside the cloud. In most of the cases, rehosting, the lift and shift goes very well. But when you want to do some upgrades of the application and some improvements of the core system, and you want to improve basically some quality attributes, replatforming might work much better, because you can move from the IaaS approach to a more platform as a service, where you start to have some quality attributes that are already provided out of the shelf by the cloud vendor. Repurchasing is one of the things that are can give you a high success of the migration in the moment in time when you identify exactly what you can use. A service that can fully replace a system, you just need to migrate the data. And you have zero cost of the maintenance and updates and operation. Everything is handled by the provider, and you just pay the subscription. Refactoring is the one that is more involved on the technical side. You need to do the assessment of the system. You need to change the architecture, the way how it is implemented. You might reuse some component, but not all. And it's very, very risky, especially for legacy systems where the business flows, the way how different flows are covered by the systems are not documented anymore or are not up to date. Because many times you need to do reverse engineering to analyze what are the things that were happening behind the scene. We have retire and retain that we already talked about, and especially when you're doing large migration, very easily you will identify apps that can be fully retired because nobody are using them. And this is pretty interesting because you need all the time to have in mind that not everything is to be migrated, and maybe there are some systems that nobody are using them anymore. Okay, let's start with an example. Let's take a look on an example to make an idea about how we could use different migration strategies. Let's imagine that we have the following system. We have a big organization that has marketing tools. It has a CRM solution. It has different auxiliary services. It has an ERP. He has some. He has a BI tool. He has an ESB service of message-based communication to be able to connect the CRM and the ERP with the data warehouse. You have on top an ETL, also a small accounting systems, and on top of that you have different web application, an email server, a voice IP server. You have payment support, and also for signing you have an e-sign service and the document storage. Looks pretty nice, works very well on on-prem system, and now you're in the phase of thinking about how we could migrate this to the cloud. Now we have the 6 strategies that we already talked about: rehosting, replatforming, repurchasing, refactoring, retire, and retain. Let's take a look how we could have different approaches, strategy approaches for each of these systems. Please remember that sometimes there's an overlap between the strategies. So depending on the way how you are looking on strategy, could be called in one way or another. And also because each cloud vendor has so many services, also it is important to be aligned with the organization IT strategy and vision for the next 3 or 5 years, to be able to be fully aligned with the ways how they would like to go with the enterprise architecture and blueprint that they would like to have. So The first thing that can be replaced is the ESB system, where very easily you can replace it inside Azure with Azure Service Bus. So basically, it's a repurchasing. After that, let's take a look on voice IP services and accounting system. And you realize that it is still used. The accounting system is planned to be replaced in 2 years' time with something else. So it doesn't make sense to do any kind of changes here. And voice IP services, even if it's still used a little bit, you already see more and more traction on other ways of calling customers, for example, from Teams and other solutions. So these two services, you decide, okay, let's keep it as is, let's retain them and do it in 2 years' time to do an assessment. What's next? Let's take a look on the data warehouse. The current solution works great, but do you want to do the operational and management of it? No, I don't want. So we have the option, for example, as Azure Synapse, to move fully the warehouse in a more platform as a service, where already you have strong SLAs and there's not too many things that you need to do around it. Of course, the second thing that you need to do an assessment is the ETL service. And here the ETL service, let's imagine that was built on top of SQL Server, and you had the SSIS packages, and you're thinking, okay, what I could do to reuse all the SSIS packages without doing any kind of changes. And guess what? You can use Data Factory for this purpose. So no changes to the way how you process data in the SSIS packages. You just running them in another big container called Data Factory. Okay, pretty good. You have a BI tool, a reporting tool on premise. It's nice, works pretty okay, but the UI and the kind of chart that you can extract are not the ones you expected, and also you will need some ML features. So you are deciding to fully replace it and do a repurchasing and go with the Power BI. You need to rewrite all the reports. It is true, but you're starting from zero. What else? You are now thinking about what are the other things that I could replace. The marketing tool you are deciding to retire because you realize that nobody's using it anymore. Everybody's using Google Analytics and the services offered by Google, and there were some marketing tools that were used in the past, but now they are just used just to push data there for some reporting and nothing more than that. So you can fully retire it. Next, you have the CRM and the ERP system. When you do the assessment, you are deciding to use Dynamics 365 for both of them, and also there are other services when you are thinking about, okay, what else I could do, and you go with web apps, document storage, and so on. For some of them, Office 365 and another e-sign service is a very good solution. Now, let's take 1 minute before the closing to remember what are the blockers. One of the most common blockers is, for example, let's imagine that we have a customer that has an objective of 100 workloads living in the cloud. To get there, the customer will likely deploy their first workload, then the first 10 or so workloads before they are ready to release one of those workloads to production. Eventually, they will reach the objective of the adoption plan and have a robust portfolio in the cloud. However, there is a problem. This step, they blocked. Because usually organizations are stuck because they are waiting 100% alignment with everything, security, compliance, and so on. And they are stuck on first phase, 4 weeks, months, and so on. This is why I said that the landing zone will evolve, and the way how you are complying with all the things will change in time. And remember all the time that it's very easily if you have 2 different teams, one that is focusing on the migration, and the second and the center of excellence that can stay ahead of what they will need to prepare the landing zone, to add new features, and so on. Now, take a look on Cloud Adoption Framework to ensure that you are aware of all migration tools that are offered, not only to define the way how you do the migration, but also how to migrate data, how to migrate computation resources, and so on. And my final thought would be the following. Even if you're using AWS, Azure, or GCP, take a look on the migration framework that is provided by that cloud vendor and try to use it as much as possible. Don't spend time reinventing the wheel. Thank you. Thank you very much. If you have any kind of questions, feel free to ask me now, or you can contact me later on Twitter or LinkedIn, and let's have a talk.
Yeah, thank you for sharing all of these. And yes, we should follow the CAF guide. There's already so many documentation that has been out there. Thank you for this reminder. I believe this will be very useful. And again, if you like this session, please provide your feedback. This thingy is in French, but it says if you like this session, then provide feedback just right here. Thanks a whole lot, Radu. I will ask people to ask their questions to you directly to the social media. That will make much more sense. Feel free, Radu, to send in the YouTube chat your credentials. I mean, not credentials, but how we can reach out to you so we can get the conversation going. Thank you for your time and commitment, Radu. Let's talk soon.
Thank you. Stay safe.
See you guys.
Cheers. Bye-bye.
Bye-bye. All right, everybody. We'll be back in a few seconds, and we'll soon welcome Annie. We'll talk about top new CNCF projects to look at for, and you need to believe me when I tell you this sounds quite thrilling. See you in a few minutes. Hi again, everybody. So before we're going into a much needed lunch break, we have something special for you. We have something special and it's right here. Top new CNCF standing for Cloud Native Computing Foundation projects to look out for. And I'll be with Annie Tarvasto. How are you, Annie?
Hi, doing good. It's wonderful to be here today.
Well, we're really very happy to see you and have you in this conference. Where are you based, Annie, for everybody to know?
Yeah, well, normally I'm based in Helsinki, Finland, but currently I'm actually in Zurich.
There you go. Again, we can't stop the TheCloudFIrst conference to break frontiers and barriers. We have people coming from all over. Thank you, Annie, so much for being here. And actually, there's a cool thing about you. Well, there's tons of cool things about you, but there's one thing that I really enjoyed when we got talking together, is that actually we need more women in tech, and you're actually coming from a long line of engineers. Is that right?
Yes, it is. Both of my parents are engineers. All of my, I think, four brothers, all of my father's four brothers are engineers. My grandfather is an engineer. So there's a lot of engineers in the family for sure.
And it goes to little boys and little girls. And this is what we love about it. Thank you again. So we have a quick talk. It is quite short, so we'll make sure to make it as effective and nice for everybody. So let us know, what is the Cloud Native Computing Foundation first, and what is new? What is happening?
Yeah.
All right, I'll let you go into.
Perfect. Let's get started then. Welcome everyone for sure on my behalf as well. I'm really excited to talk through today for you top new CNCF project to look out for. Let's get into it. So, what value do you get by attending this talk? It's a very short version today, but I hope you get inspired and you get to know cool CNCF projects as well. And I hope everyone gets something out of this talk. So, who am I then, you might be asking. So I'm Annie. Nice to meet you all in this virtual way as well. So I'm a tech and startup community builder. I've been organizing the Kubernetes and CNCF meetup as a co-organizer for over 3.5 years in Finland. I am also a startup coach, and I also host a podcast called Cloud Gossip. You can find it at cloudgossip.net. More on that later. But yeah, I have a lot of hobbies, from playing tennis to reading way too many webcomics. I do have to say that I am rather affiliated with Microsoft, but today I'm here just talking about my love for community as well as cloud native in general. So let's get straight to it. So what is Cloud Native Computing Foundation? It's a foundation that's aim is to build sustainable ecosystems for cloud native software. It's part of the Linux Foundation, and the goal is to bring together the world's top developers and users and vendors, and runs as well the largest open source developer conferences, for example, KubeCon, and all of those other fun events that everyone can attend as well. So I think most of the people probably in this conference are very familiar with the impact of cloud native in the world. The use of containers in production has increased so much. The use of Kubernetes in production has increased so much over the last few years. And I think one of the great resources out there is the CNCF 2020 survey, or it's a survey that they do every year. So that's super helpful, and it really tracks the impact of CNCF and Kubernetes in the world. And I think we're all kind of aware how hyped up some of these things are, but I also think there's a lot of value there, and I hope this talk can show you a few bits and pieces of the ecosystem that you can utilize in your day-to-day life, hopefully as well. So how does the whole landscape actually look like? How does the CNCF landscape look like? So this is how it looks like. I know it's a lot. There's so many ecosystem players, so many partners, so many providers, so many different kind of places. You can see that the slide is very crowded. But for today's purpose, we're going to focus on a few projects from the ecosystem to kind of a bit go through them, but there's so much to kind of unpack in the whole ecosystem. And for a bit of a more simplistic, simplified view of the ecosystem from the direction that this talk is looking at the ecosystem is this one. So there are 3 stages for CNCF projects. So there is the sandbox phase, there's the incubating phase, and then there's the graduated phase. So if a project starts with the CNCF as a small project, it will start from the sandbox phase, then move on to incubating phase, and then go on to graduated phase from there. And just to give you kind of an idea on how many projects per phases there are and how hard it is to actually get to the graduated phase, there are 44 projects in the sandbox phase, and there's 23 in incubating and 14 only in graduated. And when I started doing these kind of talks a few years ago, then there was only 1 or 2 projects in the graduated phase. So it's steadily increasing, and more projects are getting through the kind of process, but it is still something that is you have to kind of mature throughout the thing. And I think a really great way to highlight the kind of what does it mean to be in sandbox or in incubating phase is this really nice image. When you are talking with the sandbox projects, they are, the innovators, the techies, they are for the early adopters, really cool, really neat new stuff, but probably not in major use yet. And then you have the incubating stage that then, goes further to early majority where the practices can actually start using them. And then when you go to graduated phase, then you're talking late majority, and conservatives are using them as well. So it kind of really is about how many people are using it, how ready is it for widespread use as well. So then we can kind of talk through what projects will be actually in today's session. So the selection method for this session for the top projects is not a scientific method for sure, nor am I a fortune teller. So I do not know what happens in the future, unfortunately. And as an expectation management for this session as well, usually CNCF intro to project talks are around 30 to 40 minutes per project. They are obviously a bit of a more deep dive, and this talk is covering 4 projects in a much shorter time. So you will not see any deep dive into a project here, but there's a lot of resources where you can kind of get learning more if you get inspired from one of the projects. And then the selection process is essentially what I find interesting, what are the communities finding interesting, what my friends find interesting. So that's something that to keep in mind. So I'll be going through Helm, Linkerd, Kuro, and Keda today. I have a small Helm demo as well. For a longer version of this talk, I would have a Linkerd demo as well. But today you'll just get to hear what is it about and how is it used. But let's get to the actual projects then. We're then moving to Helm for starters. So this talk also has multiple stages as far as the project goes. So Helm is a graduated project, so it's one of the more widely known ones from this talk. Linkerd is an incubating project, and Keda and Kuro are sandbox projects, so they're a lot earlier phase in their life cycle. So Helm is the package manager for Kubernetes, and it's the best way to find, share, and use software built for Kubernetes. And then it is very similar to Homebrew, Snap, or Chocolatey, but just for Kubernetes. And I think a really great way how a Helm maintainer has kind of really dove deeper into what does package management mean, is that it is tooling that enables someone who has knowledge of an application to package it up, and so that someone else who has neither extensive knowledge of the application or the way that it needs to run on the platforms, that they can use it. So that is truly the power of package management, and then the power of Helm, which is really great and complements Kubernetes very well. So what are actually then the benefits of using Helm? You can really manage complexity charts describe even the most complex apps, provide reputable application installation, and serve as a single point of authority. It has really easy updates. It has a really simple sharing. The charts are easy to version, share, and host on public or private servers, and it has really good rollbacks as well. You can use Helm rollback to an older version of a release with ease. So it is very beneficial. So what are kind of like the principles that Helm has been built around? Helm takes security very seriously, and it has been around for quite a long time, so it can be also recommended for public deployment. It has multiple maintainers, multiple companies behind it. It supports Mac, Linux, Windows, and it has already passed 1 million downloads a month already in 2019. So it is very mature in its kind of path. So how is it then used? It's used using charts, and there isn't that many prerequisites. There's only that you need a Kubernetes cluster, and then you need to decide what security configurations to apply, and if any, and installing and configuring Helm then. So, and as a kind of bonus project, just as a quick mention, there used to be a place by Helm where you could find Helm charts, but nowadays there's actually an Architect Hub, which is another CNCF sandbox project. So the bonus project for this talk that you can use to find Helm charts easily, and it's really great tool as well there. So then we have a really quick Helm demo, quick if the demo effect doesn't get me too much. But then let's get to the demo real fast. So there you should see my terminal there. And if we do AZ account show, we can see that there I am. I'm logged into my Azure subscription. All is looking fine and dandy there. And then we do kubectl get services. Then we can see that there is an empty Kubernetes cluster running there. But actually, that's not kind of the whole truth. So if we do get services all namespaces, we can actually see that, oh, I actually have a lot of things running around there from Linkerd side particularly. But we don't let that bother us this time. But as you can see here, if you're using Helm list, you can see that there's no Helm releases either. So then when we get to it, we do Helm repo add bitnami to really get us started. But since I've obviously done this demo before and I've tried it out, for me, it just says that it exists. But for you guys, if you were doing it the first time, it would then give you new things. So we can do Helm search repo WordPress there. And there's actually a bit of something going on there, but that's totally fine. There's a WordPress there. And then we can do kubectl get services to see that, yes, the external IP is not quite there yet. But we don't let that bother us because we have to keep on moving. We can try it again. Yeah, but let's see. Then actually we can, if we had the external IP, we would then copy it to the browser. And after a while of it getting running up, we would then see that, oh, the WordPress is running. And then we would get the password, the secret from the Kubernetes as well, and then we could actually get it running, working and running. And I could, start troubleshooting this, but I think our talk is in such a tight schedule, so I will not start doing it. But essentially, after the demo, we would have installed WordPress and MariaDB to our Kubernetes cluster, configured WordPress, and stored the admin credentials securely as Kubernetes secrets. And I do highly recommend this. It's really nice and easy to do it. Yes. Then in the interest of keeping up with the time, let's get moving to talk about Linkerd a bit more. So Linkerd is a service mesh. It's ultra light, it's ultra fast, and a security first service mesh for Kubernetes. The overall goal is to really reduce the mental overhead of having service mesh. It's very similar to Istio, but it's actually the first service mesh around. So it does observability, service level important metrics such as success rates, latencies, ATC, or reliability, retries, timeouts, and security as well. So what are the benefits of Linkerd? It has a really thriving open source community. It's 100% Apache license with an incredibly fast growing, active and friendly community. Highly recommend joining there. It has a simple minimalist design. It has no complex APIs or configuration. It has deep runtime dynamics, and it's ultra light and ultra fast. It's built in Rust, and it's Linkerd's data plane proxies are incredibly small and really fast. So it installs in seconds with zero configuration, and it has really actionable service metrics with best-in-class observability that allows you to really monitor the golden metrics that I was talking about before as well. So the Linkerd principles really is that it just works. That's kind of like the basic thing. But it's also ultralight, so it's the lightest service mesh around. It's simple to reduce operational complexity. Security first, it's a default, not an extra. And it has its own proxy, so not Envoy, such as another CNCF project is using. Other project might be using. It has its own Linkerd proxy. It's kind of like built around bare minimum principles, but really fast, really efficient. So the Linkerd demo that I have for longer talks, it's really neat, it's really cool. You can obviously check that out online as well and see what benefits it is, and we see the power of real-time insights from there. And using Linkerd is super fast. It's essentially just as easy as using this command and just injecting Linkerd to your Kubernetes. Then to the second last project here, which is Kudo. It's stateless. It's a Kubernetes universal declarative operator. So then we get to the stateless versus stateful apps. So if all apps were stateless, everything would be really simple in Kubernetes, but unfortunately not all apps are stateless. So stateful apps need a lot more logic, specific knowledge to run a certain application, for example. And Kubernetes has been really focused on stateless, and stateful apps do not really like it that much. So Kubernetes created stateful sets to fix this issue, but they kind of haven't solved the fundamental issue here. But operators fix that. So operators manage and monitor lifecycle, but operators building them requires a lot of custom knowledge. Each operator is unique and purpose built for each application, so there's so many resources needed to do them. But here is a nice solution. So Kudo, Kubernetes Universal Declarative Operator. Rather than using a custom operator, Kudo provides a universal operator with the concept of plans inbuilt, which is really useful. So what are the benefits of Kudo then? Kudo can create operators without needing deep knowledge of Kubernetes or coding by defining lifecycle stages. It's just Kubernetes APIs, a lot easier to learn, and it has native management, aka using kubectl and other familiar tools as well. Then do the last project of today, so Kata, Kubernetes event-driven autoscaling. So Kata is focused on serverless. To focus on your code, and event-driven code and scaling, on-demand compute, and pay-per-use as well. So default Kubernetes scaling is not well suited for event-driven applications, and Kubernetes is more for resource-based scaling, GPU and memory. But really, event-driven scale controlling can run inside any Kubernetes cluster, and it can monitor the rate of the events preemptively and act before CPU is affected. So you can install it into a new or existing cluster, and extensible and pluggable scalers to grab metrics from multiple sources as well. So the Kata principles are not building anything that Kubernetes offers out of the box. It's single purpose, simple, and non-intrusive, and works with any container in any workload. To wrap up things very fast, since we are running out of time very much, We went through a CNCF overview. We went through a few projects, Helm Linker, Decoder, Geta, and kind of a bonus of Artifact Hub. And here is some learn more resources for you guys to see more. But I think the most important link here is in the end. That's the AKA MS Annie materials. From there, you can find these slides. And there you can find actually all of the links from there. So no need to stress about getting all the links here right now. Highly recommend checking out my podcast episode on adventures in open source with Tom Kirkhope, who is the maintainer of Geta, if you want to learn more about being a maintainer of open source CNCF projects as well. And I hope that today you have learned new things and you've been inspired. And if you have any questions later, super happy to if you reach out to me on Twitter through that nick there. And as always, I think sharing is caring. You can tweet to TheCloudFIrst IO there, and then the feedback as well. If you have any, happy to hear them out.
Awesome. Thank you, Annie, so much for your help and support. And actually, I have a question for you. How do I get started if I want to contribute to the CNCF project? How do I do that?
Yeah. So if you're interested in contributing, that's amazing. That's super cool. There's a lot of resources online. I recommend finding a SIG that really works for you in a topic that interests you. And I highly recommend, there's a lot of talks from KubeCon on how to get started in contributing. So there's like a 20-minute really quick talk. So watch those and get started there.
Well, I believe that people have now everything in all the toolbox ready to get started. Thank you so much for giving us this talk and for giving us the time. We love having speaker like you join TheCloudFIrst, and hopefully maybe next year we'll see you again and you can expose the few new things we have happening with CNCF, right?
Yeah, for sure.
Awesome.
Glad to be here.
Thank you so much, Annie, and we'll see you next time. Bye-bye.
Bye.
Okay, everybody, gals and girls, we're going to have a lunch break. Yes, we need to get some food in. And we'll be back with Andrew from Fastly for design factors for decentralized age applications. And we'll be back at 1:15 p.m. Paris time. Before that, I will leave you with a few notes for workshops and a little note for one of our sponsors, Microsoft. See you soon, guys. See you. Yeah, less than 30 minutes. See you. Hi, everyone. Microsoft is very, very happy to support this one-of-a-kind conference, TheCloudFIrst. And this is not our only way to support developers and communities, isn't it?
No, it's not. And we are all part of the developer relations team here at Microsoft. And you may have already seen us at other conferences or events. We are here to meet you and help you familiarize with our tools like Visual Studio Code, Azure, .NET, and many others.
You can also find us on Twitter at msdev_f4. We are also there on meetup.com, where you can find lots of Microsoft communities that we support. And lastly, find us on YouTube at Microsoft Developer France. Also, if you have a second, have a look underneath the video at the link to register to our monthly newsletter. We hope to see you soon and enjoy the conference.
See you guys.
Bye.
Hi, everyone. Hi, everybody. I hope you had a good quick lunch and you got some, fuel in. You needed to refuel definitely after these wonderful sessions we had this morning. And we have packs of cool things happening this afternoon. And starting off with Andrew from Fastly. Hi,
Hello.
Andrew. How are
Hello.
you?
I'm well, thank you. I just realized you unmuted me. I was going to unmute myself, but it's all magic.
It is all magic. It's
great.
I wouldn't say
Amazing.
it's part of the conference, but it's all magic. Indeed. Thank you so much for being here, Andrew. Just to give us a little note, where are you based now?
Right now, I'm in Lisbon, in Portugal, and I am trying to renovate an apartment. It is not going very well, mostly because of you know what.
Yeah, I've heard.
But we'll get there in the
things.
end. We will get there in the end.
I'm sure you will. And it's kind of cool because we had people coming this morning from Finland, from Berlin, from all over. And now we have wonderful speakers like you coming from Portugal. Thank you very much for being here. And Andrew, I've heard that you wanted to stay at Fastly forever and ever because you're our head of developer relations and loving it, right?
Well, I don't know about forever, but it's
I've heard.
it's making me happy right now. So it's a very interesting time to be working with edge networking and edge computing. So I still have plenty to do.
This is what Fastly does, right?
Yes, exactly.
Yeah, awesome. And a little thing that I've heard also about you is that you are a mixology champion. So it's not like we can go out and dream about bars and cocktails these days. So let's say that the TheCloudFIrst conference will be our only opportunity to think about cocktails. Is there any one that you actually master, that you're actually the best at?
I wouldn't say I'm the best at making any drinks, especially when you go to some bars and you see how amazing some of the bartenders are. But I like making an aviation, which is a violet cocktail with a cherry at the bottom. It's beautifully colored and it has a lovely taste.
I'm sure I'm sure you cannot invite people over, but at least if you can invite a few over, they must be thrilled and have wonderful parties at your place.
I look forward to being able to do that again for sure.
Yeah, definitely. Well, let's jump into business. And you're going to talk today about edge applications. There's actually, it's a very, very cool talk, I think. It's about how to make sure that how we design applications will make it work for decentralized edge apps. And you have tons and tons of tips to share. I will let you go into it, and people feel free to ask your questions in the chat. We'll make sure to get them covered at the end of the session. Have fun, Andrew.
Thank you. And yes, as Steen said, I'm really delighted to answer questions, so there should be plenty of time to do that at the end of the talk. Hi, I'm Andrew Betts. I do developer relations for Fastly. I like thinking about the way applications are built and structured. I've been writing them for a very long time, since the late 90s, and I feel like virtually every year someone comes along and says, you've been doing it wrong and this is the new way we should build distributed applications. Certainly, COVID has given us ample opportunity to see people in extreme circumstances trying to create systems and processes to deal with emergencies. And, sometimes that works really well. Sometimes, I am not focused on the right window. Sometimes it doesn't work so well. And this is one of my favorite examples from the pandemic of how distributed systems can sometimes be made using really crazy bad technology. And it almost always comes back to a spreadsheet at some time or other. And I know Microsoft is a sponsor of this conference, so I should say other spreadsheets are available and they can all be misused in the same way. So this is not a very good way of creating a system which is supposed to be scalable and distributed and work across the whole world. So today I want to spend some time with you thinking about what better ways of creating distributed applications are and how we should be rethinking these for a world where we are increasingly running applications on client devices and at the edge. So traditionally, when we think about a stack of components that go into building a system, we think about these things: hardware, operating systems, server processes, and code. And traditionally, we would manage all of these components to create our full system. Now, very quickly, we realized that hardware is pretty utilitarian and pretty much a commodity. And so we don't really want to manage that ourselves if we want to focus on building our applications. So pretty quickly, people transitioned to systems of virtualization, allowing hardware to be pretty much abstracted away and for us to use it much more efficiently. But we also realized that we didn't really want to manage all of these components either. So we end up with providers like AWS giving us technologies that allowed us to use other people's infrastructure. And so, the world of cloud computing was born. And the first foray into that was infrastructure as a service. Now, providers like Heroku around sort of 2010, 2011 come along, and we realized that actually a lot of the stuff that we were still doing in the world of AWS, we really didn't want to do any of that stuff either. Things like managing container engines. And so we move up a level of abstraction to platform as a service. And this is where things get really interesting, because this is where we start to experience trade-offs between the things that we can do with our application design, the full kind of flexibility that we can bring to bear on the decisions we make about how we structure the components of our application and how they talk to one another, and the benefits that we get from using a particular platform with particular constraints. So with platform as a service came a kind of new design paradigm, which was, I would say, pretty heavily influenced by Heroku. And in fact, Heroku published a set of design guidelines that they called the 12-factor app. And even today, I think the 12 factors that were published, I think this was in 2012, still hold up pretty well against the way we design web applications today. I'm going to just highlight a few of them here. So these were the 12 factors that Adam Wiggins, who's one of the founders of Heroku, came up with. Let's pick out those that are particularly relevant today, even as we move from platform to serverless. It's things like having stateless processes. And we'll come back quite frequently to state as we talk about how we scale applications across the edge. It's the ability to run processes concurrently. It's having processes that you can terminate randomly and still have the system be resilient to that. And it's treating other systems as attached resources. So no diving into the database through Unix sockets or anything like that. We have, we have things like message queues and databases and query engines that we will attach using common protocols like HTTP. So if we think about these principles, and then we move on to the next stage of our serverless journey, we arrive at Lambda and all of the things that came after Lambda, which give us another layer of abstraction. So we move up from having platform as a service, where we're still managing our server process, to having functions as a service, where we're not even managing our server processes anymore. We're literally just shipping code and having that run in a defined environment. Now, in this kind of situation, we have to accept more constraints and more principles that we need to apply to the design of our applications. With serverless and functions as a service, we typically have to deal with restricted memory for each invocation, restricted CPU, restricted runtime. We don't share state between invocations of our functions, and we often don't have access to any kind of file system I/O. But on the flip side, as a benefit of accepting these constraints, you get enormous scalability. And you also reduce the maintenance overhead of the application considerably. Some of the other benefits we have are, that's interesting. Sorry, my computer's running rather slowly. No idling costs. So when your application is not doing anything, you're not paying for it, you have much looser coupling between the components of the application. And of course, you now only have to manage the code that actually defines the logical function of your application. You no longer have to worry about patching the OS or upgrading the web server or anything like that. But all of these things really just improve our developer experience. They're not really changing the fact that our end users' experience of our application is basically unchanged. So to improve our end users' experience of our application, we've typically leaned heavily on caching and caching the application and the result of the application around the world. And this is a fairly typical architecture where we have, we have our core infrastructure in one place, which is doing all of the processing and intelligent logic, which creates our pages or resources that users are going to download. And then around the world, we have in various locations storage facilities, which can cache the result of URLs and resources that people are trying to visit. This is the basic principle of a CDN, a content delivery network. Now, we can improve on this, of course. We can deploy additional elements of infrastructure around the world in various locations to distribute the load to allow the application to scale globally. But you still have to manage all of that infrastructure yourself. Think about in terms of, for example, deploying Lambda functions, you still have to choose a location that you want to run that serverless function in. And you might choose to run it in multiple availability zones, for example, so that you can get to it quicker from anywhere in the world. So let me return to that sort of original stack of infrastructure, which defines a full stack of components for an application, and reflect on the fact that we've now abstracted away almost all of this. And we've got to the point where we could conceive of actually running this code in lots of different places. In fact, we could think about having a pipeline in which we have the same code or related code that all forms part of the same application, running at different stages, different positions within a pipeline that is strung out from a core of infrastructure in one place, which maintains some element of global state, through to an individual device that represents a single end user. And between those two, you have potentially other locations in which you can run logic or store state that relate to your application. So for example, in your core infrastructure, you probably want to be storing your global state, and you probably want to be doing any really heavy lifting that relates to very large amounts of data, say processing offline analytics, that kind of thing. But the disadvantage of core infrastructure is that it's a long way away. In fact, if your core infrastructure is on the other side of the world to the end user, then doing completing a TLS handshake with that location and getting a response back to a request could take half a second or more. So then we have the edge, providers like Fastly, where you've got hundreds of instances and they're probably around 20 milliseconds away from the end user. And then you could think about even 5G, which is introducing the idea that potentially we could have tens of thousands of locations that are probably 2 or 3 milliseconds away from the user. And then, of course, there's the device the user themselves is using. In each case, we have different constraints and different benefits. With the end user, of course, you've got local processing, so everything's very fast, but you only have one single user's view of the world, and the capacity you have for processing is fairly limited. At the edge, you've got kind of a middle ground. So you probably don't have full access to global state, but you've got access to more than one user's view of the world. And you've probably got a lot more compute capability than you would do on the local device. So let's think about some examples of how we can deploy these different parts of the pipeline in relation to one another. This is an example that one of my colleagues at Fastly put together running on our edge compute network. It's a pretty contrived example. You type Markdown into a text area in the black text area on the left, and then that is sent to the Edge platform, which then converts it into HTML and returns it, and then we render it. And the round trip time for these requests is under 10 milliseconds. So, and that includes the processing time on the Edge server. So that makes it possible for us to make those requests on every keystroke. That's actually a feasible way for us to do this. And of course, you know, this being a Markdown processor, of course, there are Markdown implementations in JavaScript. So, you know, this is a process that we could be doing on the device itself. And in fact, this is the sort of decision that we need to start making in relation to almost everything that our applications do. Think about factors like, where does the input come from? Where does the output go to? How heavy is the code? How much memory does it need? How long running is the process? Does it need any inputs from anywhere else? And when we consider all of these factors in relation to this particular problem, we would conclude that this Markdown processor probably ought to be a local process on the device. But let's think about a different scenario. What about one where we are creating pages from a content management system? So the request from the end user is, I want to see a particular page from this, maybe a news website. And we need to make a query to a content management system, get some data back in the form of a JSON response or GraphQL response or something, and then do some templating to create an HTML page and then return that HTML page to the user. So in this case, we have a dependency on an external system. And the most efficient way to do this is probably to have the Edge compute network make the query to the centrally run CMS, get back a nice, small, efficient package of data, and then use that to template HTML, which we can then transmit to the end user. Very efficient way of creating pages very quickly and very close to the end user. Another thing we could consider about this solution is that we could combine multiple external systems together to create those pages. So it doesn't necessarily just need to be the pages from the CMS. The data from the CMS, it could also be data from advertising systems or personalization systems. And we could take all of that data, combine it together to produce pages. That potentially means that two users wanting the same page would end up using largely cached data. The second user would want all the same data from the CMS, so we wouldn't have to go back to the core infrastructure to get that, but we might need to make a query to the personalization system to understand what that user's preferences are in terms of how they want the page formatted and so on. So those are a few use cases. Let's look at some others. So anything really involving personalization, localization, authentication, authorization, what I like to think of as like the outer layers of the onion. So if you have an application which is structured in a sort of middle series of middlewares, it's a fairly modern way of thinking about application design, then those outer layers are often ripe for moving to edge computing. You could think about things like personalized app shells when you do server-side rendering of React applications, for example. Moving that to the edge could potentially open up the opportunity to personalize those pre-rendered applications to each user. Or indeed template rendering, which I just talked about in the context of content management systems. Other use cases that I like include beacon termination. So if you're deploying things like real user monitoring to end users, and every time somebody loads a page, you need to receive a beacon back to the server to record things like how long they spent hovering over a button or something like that, then all of that data can be collected, aggregated, and then transmitted from the edge to some kind of central collector. This might include, even more, exotic use cases, I guess, like IoT telemetry. We could be thinking about telemetry from things like smart meters or vending machines or self-driving cars. A lot of the physical world around us now generates a vast amount of data, and edge networks are a really good location to collect and aggregate and process that data. Facades are a good example of a sort of compatibility layer that's often implemented as a middleware in front of an older application. Those are often excellent things to put at the edge, because it means that you can improve performance for the end user, and also you get great separation between that compatibility layer and the original application. So lots of potential use cases here, but these are all really just ways of getting benefits from edge computing that you can integrate into an existing application design. So all of these kind of use cases, typically we already build applications like this anyway. I think the more adventurous ideas here come from rethinking what it means to have a distributed application in the first place. And I love Pat Helland's writing on this. Is a Microsoft engineer who wrote this blog post in 2007 that said that all computing is memories, guesses, and apologies. This MSDN article you can't find anymore, which I think is kind of ironic given its content, but you can dig it out of archive.org, and it's a really interesting read, and it's actually very short. It makes you think that as developers, we often want to build applications where certainty is highly valued. And that isn't necessarily a good thing. If we get distracted by the need to be certain about everything, then we actually sacrifice a lot in pursuit of that perfect knowledge. What if we didn't need that perfect knowledge? Could we redesign the application in a way that we would get significant benefits from? And I say yes, we can. So for example, it's very uncommon today for applications to accept writes at the edge. Content delivery networks in their traditional form are read operations, right? You receive a request from an end user in the local data center, and if the data center has a copy of the object the person wants, then it returns it, and if it doesn't, it goes and fetches it from the core infrastructure. That's basically how CDNs have worked for a long time. And very few of them today are accepting writes. But there's really no reason why we shouldn't start to do that right now. We can do it for aggregating logs. That's a really easy thing to do, and a lot of Fastly customers are already doing that. But we can also do it for writes that need to be synchronized and eventually consistent across the world, but where we don't need that consistency to happen immediately. And I'm thinking about applications here like, say, Uber, where you have some hyper-local data sets where the data tends to need to be accurate in the location where it's being written. It's actually not that useful or important for me to know that a car has moved 10 meters down the road in Paraguay. If I'm in Lisbon, I want a car here. I'm very unlikely to want a taxi in Paraguay if I'm sitting in Lisbon. So certain types of data doesn't necessarily need to synchronize across the world very quickly. And yes, as I mentioned a minute ago, aggregating data at the edge is a really obvious use case for accepting writes, and we already do an awful lot of this. Now, with crushing inevitability, I am going to go all kind of universe brain on you at this point and say, well, do we actually need the core infrastructure at all? Are there any use cases that we can satisfy by creating applications whose architecture is entirely distributed with no centrally controlled state? And I think the answer to that is yes, absolutely we can. I don't see why we can't rethink a good portion of the applications out there today in a way that doesn't require large, expensive, centrally controlled state. So as an example, one of my customers is a big newspaper, and they said to me, you know, we have this big infrastructure that we have in GCP or AWS or wherever, and we have to choose where to put it. And there's always a big argument about, you know, which of our global offices should it be closest to? Why can't we just upload all of our editorial logic and state to the cloud and have the platform determine where the primary source of that data is? And in fact, it could move around the world. So as people come to work in London, the primary database moves to London. As people, you know, go home in London and start working in Los Angeles, the primary data store moves to the west coast of the US. Now, this seems like something that's completely crazy when you think about it in terms of how we design applications today. But if you had a platform that managed all of this kind of stuff completely autonomously, then it would completely make sense to do this. In the same way that, for example, let's say I'm operating a flight booking engine, the availability of tickets on a flight from London to San Francisco is of most interest to the people who are in London, in the same way that the opposite flight from San Francisco to London is of most interest to people who are in San Francisco. Now, it would be crazy to like shard your availability data across the world just based on like the origin city of each flight. That would just be a crazy amount of orchestration. But why not if it's completely automatic and doesn't come at any cost? Another interesting use case that is increasingly important to developers is compliance and regulation. And you may find that you are operating in an environment where you have a legal obligation to store and process data within a certain geographic region. And edge networks can help here because users who are physically close to one particular data center may not be able to route their request to that data center because it's in a different regulatory environment. So clever routing can take care of this by ensuring that users who are within the same regulatory regime are routed to servers that exist within that region. Rate limiting is something that I think is a really interesting use case for local versus global state as well, because users who are behaving nicely will tend to send all their requests to one single location because they are not moving, or if they're moving, they're not moving very fast. So the duration of their session, they're likely to be in contact with one single data center. Whereas an attacker who's trying to overwhelm your system is more likely to be sending requests to all of your data centers at the same time. So whilst we may want to implement rate limiting globally, we don't want to slow down the vast majority of people who just stay in one place. We could think about ways that we could distribute this state in a way that allows for both of those possibilities. So as a good user, I'm staying in one place. I want my request to be counted in that location. And because I never send a vast number of requests, there's never any reason to transport that state across to the rest of the network. Whereas an attacker is going to send lots of requests, and at some point it's going to trigger some local threshold, which might anchor that person to that location, so that if they send requests to a different location, those requests get proxied to the location where we're counting them. You can think about these kind of rules allowing us to create applications where the state is still globally distributed and there is no centrally held store of global state, and yet we are able to use global state when we need to. And I haven't really talked about peer-to-peer, but there's a whole wealth of use cases involving peer-to-peer communications, which can be improved by introducing edge computing into the mix. So instead of users attempting to send messages directly to one another, and game updates and chat relay are really good examples of this, we can improve the reliability of those communications by using existing wideband established links between well-connected data centers. So user one and user, so the two users here are connected to data centers very local to them, and then those two data centers are connected to each other via very high capacity links that are always open. So in conclusion, I would like to return to Heroku's 12 factors and rethink some of these for the new distributed, serverless, no centralized state world. I've highlighted the principles which I found most important when I was applying these principles to my own application design. So we had stateless processes, concurrency, disposability, separate build and run stages, and having disposable attached resources that are using common protocols. To these, I think I would like to add two more. Oops. There we go. The first one is remote state. And this is an assumption that persistent state is never local to logic. So an edge application should assume that persistent state is controlled remotely and cached locally, and that we can update local representations of remote state and make use of mechanisms in the platform that reconcile updates to that state asynchronously. So the process of dealing with state, where it needs to be, how it gets there, how we reconcile conflicts, on all of that kind of thing should be separate concerns from the concerns of where we are doing the writing and where we're doing the reading. We know what shape we want that data architecture to have, and we know the parameters that it needs to, we know the sort of promises it needs to fulfill in terms of how quickly we need it to be consistent and what we need to do when conflicts arise. But we should try to separate those concerns into separate architectural solutions. And if we can do that, then that gives us the opportunity to solve those problems in the platform itself. And this reminds me of a case of, there's one famously large social media company. I can't remember exactly which one it was, so I'm not going to name it just in case I'm wrong. But they were using App Engine, Google's App Engine platform, which is quite a high level abstraction that provides various storage solutions that look like common protocols that you might be familiar with, like Memcached. And this particular app was using Google App Engine's Memcache-like API, but to store something like 100 terabytes of data. Now, you can't use Memcached on a single node to store 100 terabytes of data, or maybe it was even more, I don't know. But the important thing was that they didn't care, because Google was providing a contract in which they said, we will provide you with an API that looks like Memcached, and you should not care how under the hood we've made this work. And that is really what I'm getting at here. I think we will increasingly see more and more of this, and it will happen at a larger and larger scale. The other principle I wanted to add is that I think that there should be no single view. An edge application doesn't need to have a complete and up-to-date understanding of the world in order to operate correctly. And for me, this is a complete rethink of the priorities which I put into designing applications. I'm the kind of developer that feels comfortable and confident and happy when I feel like, I can query my entire data set and, I can hold it all in memory and all this kind of thing. And as a result, these are the kind of instincts which make applications difficult to scale. It's the kind of thing that, gave rise to the early scaling challenges that blighted sites like Twitter and Facebook, for example, where they suddenly had to face problems like, overflowing a 64-bit integer, or, problems that they just had not even conceived of when the application was originally created. But many of these problems don't need to exist at all if you take the view from the start that you never need a complete understanding of the world at any one time. So I'm going to summarize the 5 of Heroku's 12 that I think are the most important in the serverless world, and add in my new 2, remote state and no single view, and say, do you agree? Do you think that the edge application paradigm, if you like, I hate that word, but this new world of designing applications for serverless world, is this the right way to look at it? Is this the right way to create our new generation of web applications? I would love to know whether you agree. And I will say that is all I have. Thank you very much for listening. And if anyone has any questions, I'm very happy to answer them.
I'm sure you have a few questions on your Twitter account. Thank you so much for sharing. It was very cool. It was very cool, and thank you for. I've been sharing a few things as well on your talk, and we have a few questions or remarks here and there. So take a look at your Twitter account. I'm sure you'll have your remarks there.
In my Twitter, okay.
Yeah. I have a question actually for you. What is you talk about how new it is and how it needs to be reinvented every time. What is the potential for standards in edge compute world?
Yeah, that's a very interesting question, and the basic kind of nub of it is competition versus standardization, I guess. I used to be on the W3C's technical architecture group, and I remember we had a lot of debates about things like privacy mode in browsers. You know, when you go into private browsing mode in Chrome or Safari or Microsoft Edge, doesn't quite mean the same thing in each browser, and should it?
Yeah.
Or is it reasonable to say that privacy mode is a thing that browser vendors have invented to make their browser better than other people's browsers, and therefore it actually is pretty fair game to be territory on which they can establish differences and say, you know, you should pick our browser because we have a better privacy mode than other people. So the same is going to be true of edge computing and distributed state management. And the more we standardize, yes, the more we can, kind of move on from those problems, and we can address new problems. But also, there's always going to be a force kind of pushing in the other direction, saying, well, our thing is unique and different and special and snowflakey and is never going to be standardized because, you know, we want ours to be best.
Exactly. And in that sense, does edge compute suffer from vendor and the lock-in that might happen there?
Yes, and a lot of people will say to me, you know, as what Fastly and our competitors are all frantically doing at the moment is trying to convince everyone that, you know, you shouldn't just use a CDN to cache your images and your style sheets and things, but you should instead, you know, move wholesale large pieces of logic to the edge. And, you know, if you believe what I'm saying today, then even you could move your entire application to an edge computing platform. And if we do that, then, you know, aren't we, subjecting ourselves to vendor lock-in? And I think, well, the answer is yes, to some extent you are, but no more so than you are with your existing cloud provider. And, you know, I would challenge anyone to lift and shift a significant application from AWS to Google Cloud Platform, and, you know, not have trouble doing that.
That's true, indeed. Well, thank you for your time. And also, I'd like to add, I don't know if you had that at the end of your slides, but we have a feedback session. We'd like for all of our speakers to get feedbacks from the audience. So feel free to share feedbacks to the link that we will shoot in a few seconds, maybe in a YouTube channel chat. And again, Andrew, have fun working forever and ever at Fastly. And I hope that the remodel of your apartment in Portugal goes well. And that, so. Yeah, fingers crossed. Fingers crossed.
Thanks,
indeed.
Charlene. It was a pleasure.
Thank you so much. We'll see you soon. And to everybody staying with us now, we will be back in a few minutes, actually, with Gert coming about cloud governance and autonomous DevOps team. Yes, we're going to talk about DevOps. It had to come at what point? And it's coming at 2:05. So let's catch up a quick break. See you in a bit. Hi, everyone. Microsoft is very, very happy to support this one-of-a-kind conference, TheCloudFIrst. And this is not our only way to support developers and communities, isn't it?
No, it's not. And we are all part of the developer relations team here at Microsoft. And you may have already seen us at other conferences or events. We are here to meet you and help you familiarize with our tools like Visual Studio Code, Azure, .NET, and many others.
You can also find us on Twitter at msdev_f4. We're also there on meetup.com, where you can find lots of Microsoft communities that we support. And lastly, find us on YouTube at Microsoft Developer France. Also, if you have a second, have a look underneath the video at the link to register to our monthly newsletter. We hope to see you soon and enjoy the conference.
See you guys.
Bye.
Hi again. Still me. Still the same person taking care of you for the for our track 1 at TheCloudFIrst. If you wanna tweet, please use this hashtag. We've been using it just to make sure that we get all of your messages, questions, remarks, encouragement, any ideas that you would like to see for next year. So please use this hashtag at TheCloudFIrst.io on Twitter if you want to reach out to us. All right, it is 2:04, about to be 2:05, sorry, and we'll be with Gert. Now I'm welcoming Gert. Hi.
Hello, good afternoon.
How are you?
Yeah, great.
Awesome.
Really excited to be here. First time I heard about TheCloudFIrst, so it's really cool to do this this event now.
Yeah. And where are you based, Gert?
I'm from the Netherlands.
From the Netherlands. Awesome. You're the first person that we have from Netherlands today. We have people from all over, but not Netherlands yet. So kudos to you to do the first one. It is indeed a European conference, and this is why we'll have people from all over the world, at least Europe, that we can do. Okay, so today you're going to talk about DevOps. How can you as a developer not be annoyed working with central IT department? And this is thanks to DevOps. But first, I've heard that you've been doing online meetups before the whole COVID trend, right?
Yeah, so I like to do presentations and working with the community, doing conferences like this. And we had this idea about 1.5 years ago to say, well, there are so many people that live in further away places that have a hard time to join these meetups that are most often in the bigger cities, etc. So we said, let's do all these things, start doing a meetup online, because nobody's doing online. And we started with that.
Well,
yeah, we started with that last year, like end of January, beginning of February, when COVID was non-existing, at least in Europe yet. So yeah, after the first 2 or 3 meetups that we did, well, COVID hit, the whole world started to do online meetups. So yeah, now
you were already trending.
yeah, so now we're just one of the thousands of online meetups. But
and
yeah,
you have the Azure Community Live meetup, is that right?
Yeah, we call it Azure Community Live, and we host it on a global scale. So we have hosts from Europe, that's me, from the US, and from Australia, so we can cover all time zones as well.
That is cool.
Yeah,
that is cool.
We still think that we were trendsetters and everyone followed us, but yeah.
You know what? Yes, you are. Let's say that. Let's just say that. Thank you for doing it, because the community has been as helpful and supportive as ever to help and learn and teach each other about cloud, obviously Azure, but also other cloud providers. So thank you. This is an opportunity to say a warm thank you for the communities for helping us. It's the world to us. It means the world. All right. Well, let's get started. Cloud governance and autonomous DevOps team, friends or not? All right.
Yes.
I'll let you to it. Have fun.
Okay. So yes, you can see my screen. There's stuff on my screen that should be gone. Okay. So let's do a quick introduction so you at least know who's talking to you. So my name is Geert van der Kruijsen, which is a really unpronounceable name from anyone not from the Netherlands. But I work in the Netherlands for a company called Xspirit. We're a consulting company helping other companies build better software using the cloud, using DevOps principles. And that's what I really love to do as well, and love to share that knowledge with the community as well. So as we just talked about, I'm one of the hosts of Azure Community Live. I'm also a Microsoft MVP and love doing stuff with Azure, building software with .NET or other languages, and DevOps combined with the cloud. And when I do these things at my customers, trying to move them to a more DevOps style way of working, I often run into a lot of conversations with developers, but also IT operations teams. And from that perspective on, I came up with this talk because I think there's a lot of ways that we can improve, and especially in large enterprises, this is often really slowing down the adoption of DevOps practices. So let's look at what we're in the end all trying to achieve. But in the end, we as developers, but also IT departments, in the end, we want to have more value for our clients, right? We want to build better IT systems that deliver value to our end customers. And the way we like to do that, or at least the way I like to do that, is by using DevOps practices. And what I always use to describe DevOps is this description from Donovan Brown, one of the advocates at Microsoft. His description was, DevOps is the union of people, processes, and tools or products to enable continuous delivery of value to your end users. And the key word here is not people or processes or products, it's actual value, right? That's the reason why we build our software. And that's where cloud really can enable us. But the cloud does give us a lot of tools to build stuff in an anonymous way or autonomous way and really speed things up. We don't have to go to IT departments to order servers anymore, right? We can just create them ourselves. And what I often hear in all the sales pitches around cloud and why we do cloud is everyone is focusing on the speed, right? You can really easily create new resources. It's so fast to just spin up resources, delete them again, be really flexible in scaling and all those other kind of things. That sometimes we also have to take a step back, is can we actually handle all this speed? Because at a lot of companies, we have to work in a highly regulated environment. Looking at banks, insurance companies, companies that work with private information of users, or maybe credit card information. You want to do that in a secure way as well, right? So can we handle that with all the regulations that are there as well? And this is often a real struggle between DevOps teams that really want to go faster and faster and deliver more business value, and then also other areas in the companies that want to make sure that everyone is also applying all these regulations that we need to do. So that's what my talk is really about, finding the balance between autonomy for DevOps teams and control of how do we make sure that everyone stays in check and works in a compliant and secure way. And over the years, I've worked at several companies as a consultant, and I often have these discussions with business teams, DevOps teams, IT departments, CTOs, etc. And often I see two camps, and they all tell different stories about how they work together. So to wrap that up, if I look at DevOps, if I talk to DevOps teams and ask them, how do you see your IT department or your security department? And they see it as the big police force that do not allow you to do this, they do not allow you to do that. If you want to open a certain firewall, you have to go through all these papers, and in the end, 3 weeks later, they will open it for you. That's the general conversation I often have. And then I start talking to these IT operations teams, security departments, and I start talking to them about the DevOps teams and what their goals are. And the image that they tell me about these DevOps teams is, well, these DevOps teams, they really don't know what they're doing. They don't know what is secure. They just want to get stuff, new features out of the door. So they don't care about all these really important features like regulations, compliance, and security. So in my opinion, this is not the thing that we should focus on, right? These two teams really rely on each other. So what I would rather see is building a team combining teams that really focus on building new value for the customers, but working really closely together with security departments, with central IT departments, to together bring the best value to your customers. But why are these two groups in organizations so much different? In the end, this often comes down to that these departments are valued through different KPIs. They have different things that they are measured on if they are performing well. Let's have a look at these differences. If you look at DevOps teams and how they are measured, they have a goal to, in this example, supply better digital services for our customers. That's the end goal that we want to achieve. And to do that, we have certain KPIs. We want to ship more features. We want to release faster. We want to do more experiments so we can learn from our customers and know what they want. Then on the other hand, we have IT departments, or maybe security departments. Their goal is exactly the same, better digital services for our customers. But then from a whole different perspective, they look at the same goal. And they have KPIs like having a stable environment. Business value, like features that a DevOps team build, are only delivering value if the application is actually stable, running in a production environment. If there's no downtime. Are we compliant with all the regulations that we need to be compliant with? Do we need to check all kinds of things with our auditors? Do we have a full audit trail of everything that happened? Those are the things that central IT departments are often measured on. So when these teams are measured on different things, how can they actually work together? Because these things really collide. Having more stability is the opposite of doing more and more changes, right? Because every change is a certain risk. Although, of course, we could work on certain things to make these risks smaller and smaller. Doing nothing is probably even more stable. So in this talk, I want to work or together with you, talk about how can we build this organization or these teams that actually work together to supply this value. And I think the key in that is to really define who owns what in the whole software development lifecycle. I'm from a world that really embraces DevOps. So I want to go to a world where we actually have a team that build the application and run the application. So as a product team, you should be responsible for the whole life cycle of that application and everything that is connected to it. I really like that quote, you build it, you run it. It's initially coined by Werner Vogels, the CTO of Amazon, but it's really the mantra I like to use when building DevOps teams. So looking at who owns what, it's really the product owner. And when I look at companies, when I visit a lot of these companies that build software, they often have product owners and they're really focused on all the features that are in the application. Right, so that's often when these companies are transitioning to a more agile and DevOps style of working, these companies have product owners that focus on the features. And then we have other departments focusing on other areas. But when you build and run your application and be responsible for the full application, you as a product owner should be responsible for far more than just the features in your application. You should also be responsible for the infrastructure that your application is running on. You are responsible for the security. You're responsible for the compliancy of your application. You're responsible for the full cost of the application, the development team cost, the infrastructure cost, risks of security issues, the costs that could be implied with that. All those costs should also be part of what the product owner owns. So he or she can actually make the right decisions between, should we invest more in security or should we invest more in features, for example? And in total, this product owner can therefore really own the full business case of why are we building this product. And together with that, when you really own this product, you can define your own SLAs or SLOs, service level objectives. And SLA is really something that you define together with the business. So you're building an application, you're saying, well, my application will behave in this way. It will have an uptime of 99.99%, and otherwise you will get a certain discount or we will pay a fine, and those kind of things. And SLO is something that you use internally as a development team. So you can aim for even, well, it should be a higher number than your SLAs, but having a objective that your team works on, so you actually have certain room of that you can use to do certain experiments, but also make decisions of how stable is my application, and do I need to focus more on stability of my application or on the resilience of my application, or can I focus more on experimental features and those kind of things? So all in all, this is quite a broad set of things to think about as a product owner. So how do we face all these things, and especially all the compliancy and security things? What I really like to do together with product owners and central IT departments is really start looking at the risks that we actually take. And what I really love is this website called Dear Auditor, which is a website created by the DevOps community, and it really states a number of risks that you could handle as in a DevOps way. So it really works for either both DevOps teams and your IT department, and you can say, well, we will handle all these risks that we can do on our own. And from a central IT department standpoint, you can support these teams in actually mitigating these risks easier and easier. So let's look at some of the risks that cover a lot of ground, looking at compliancy and security. One risk that is a quite simple risk is that you never want to have any unauthorized changes to your production environment, right? That's something that you want to eliminate. You always want to make sure that everything that's running in production is the actual thing that you were supposed to have in production. So things that you could do to solve this is have a fully auditable overview of all the changes. If all your changes are in source control, then at least you have an audit trail of all the changes that were made. And if then you add a secure way of automating all the deployments of these code changes towards your production environment, then you have a fully auditable pipeline of every step that went to production. What I really like to love to add to these workflows is also adding a 4 eyes principle. If you're working with Git and you're using pull requests, this is a great mechanism to always have someone review certain changes before they end up in production. And with that, you really eliminate certain risks like having a rogue developer do certain changes towards your production environment. So setting up such a workflow is not that hard. But what is really key to that is automation. We want to have a lot of automation in place that make it easier for all these teams to create these kind of workflows, and for them to make it easy to check that everything is compliant as they were supposed to do. When I look at compliancy at a lot of my customers, all these teams have to fill in a lot of Excel files or other paper processes where they will define that how they will make sure that no changes will happen in production, and they will only do that on in a paper process. So they will say, well, we will make sure that no unauthorized users will have access. Okay, they go to the Excel file, they check that box, and well, then they're secure. Of course, they will actually also check if there are no users, unauthorized users present in all their systems. And then they will go over a lot of these checks manually, and they will store it somewhere in an Excel file or any kind of system that will store all these compliancy settings. So what often happens when you use these kind of processes is that you start off on the top left with 100% compliancy. And then over time, things change. Developers can change role-based access somewhere, add some users. They forget to remove some people who left the company. All kinds of other changes happen. And then over time, your compliancy goes down and down and down. And then your yearly or monthly audit comes up, and everyone's looking at the papers again, is going through all these checks and make sure that everything is correct again. So then compliancy goes up to almost 100% again. And then the same stuff happens again. People start working again after the audit, everything was A-okay, so we can just continue our work, and small changes happen, and slowly our compliancy level drops down again. What I would really love to see at more and more companies is something that I tend to work on with my customers, is really automating this process. So instead of having all these checks in a Excel file or somewhere in a document, really have a lot of checks that are actually automated and can be checked at every moment of the day. So we have a continuous check that runs for the compliancy of our system. So we don't have to look at it once more when the audit comes up. We are always almost at 100%. There might still be small slips, but at least we see that within a day or within a couple of hours, and we already can take measures instead of doing that when a certain audit comes up. And by automating this also gives us the insights to development teams so they can check their own compliancy and security level. Because all these checks are automated, we can send the results to these teams or give tools where they can see those things on a daily basis, so they don't have to check that every year, but they can constantly be involved in working on their own compliancy and security level. If we look at the cloud, Azure policies is a great way to do this. We can really define a way to what we allow as a company on our Azure environment and what we do not allow. What I often see is that these large enterprises, they tend to build certain building blocks, and then as DevOps teams, you can do your own things in an autonomous way, as long as you use these predefined building blocks. And at first, that might sound like a good idea, and I think like maybe 75 or 80% of the times, this is good enough for a lot of smaller projects or initial proof of concepts. This works quite well, but there are so many times that certain teams need certain exclusions from rules, and they want to make these exclusions in their own time. And since the product owner is owner of the full application, in my opinion, he or she should be able to make these decisions if they want to break certain compliancy rules, because there is really a need to it. So having these predefined templates do not work, because I think you should not enforce the way of working on that teams, but just have automated controls that work with any kinds of ways of working. If a team wants to deploy their infrastructure on Azure using ARM templates or Terraform or Azure CLI, in my opinion, it should be everything should be possible. On the other hand, Azure policies block certain things that you decided as a company in a way that it doesn't matter how you actually deploy towards your infrastructure, it will always check about certain rules. Another thing that you need to take into account is when you want to create a really compliant and secure environment, is that you want to eliminate almost any human interaction on your production environment. So how I normally do this is by having fully automated pipelines that are the only way to access your production environment. So how I often set up the governance in cloud environments on Azure is we give each team or each product at least 2 subscriptions. One subscription containing non-production workloads and one subscription that contains the workload. So for the non-production subscriptions, I normally tend to give development teams full contributor access. So they can do everything on that environment except for changing role-based access. And on production, well, they should not be contributor because everything should be changed through pipelines, because then we have fully audit trails, fully view of all the changes that were made on production. We can enforce 4 eyes principles. So at least 2 people looked at certain changes before they went into production. So on production environments, I tend to only give reader access to all the teams. All the teams can still do everything they want, just in an automated fashion. And when I talk to these teams, they agree with these ideas that having automated pipelines should be the way to go. But sometimes there's just stuff that happens, like production incidents or things that went wrong, and nobody knows what the exact state is of your application. But then sometimes you just want to go to your production environment and be able to fix certain incidents. So I don't think you should get access to that environment, But if you want to have it, there should be ways to have that only for a limited amount of time. So what I often do in Azure is using privileged identity management from Azure Active Directory. So you can actually give someone more permissions for a short amount of time, and even request that themselves in a self-service manner, and have other team members approve that this person will have temporary more access on the production environment. Great thing about privileged identity management is that it will also track all the changes that were done by this human interaction. So you still have a full audit trail of everything that happened on your production environment. So to make this easier for all development DevOps teams that you have within your company, is that I often see cloud centers of excellence or cloud platform teams created. And I really don't want to have these cloud platform teams be the single point of knowledge about the cloud. They should really be an enabler for other teams to be autonomous in the cloud. So in my opinion, these teams should be really accelerating other teams, making it easier for them to do their job. What they could do is enabling self-service. Instead of being a ticket machine where you always need to get a ticket to get certain things done, I rather have self-service portals or tools where you can get your stuff done yourself without having to wait on this central platform team that all the other teams depend on. The platform team can also really help you give insights to other teams so they know what is right and what is wrong in their environments. But then again, giving these insights to the teams themselves so they get a good view of how their environment is doing themselves. And in the end, they can also help with certain alerts or inform them about things that are misconfigured in their environment, or give them advice on how to make things better. But in the end, always put the responsibility back to this actual teams that own these applications. What I often see is that these teams begin with these principles, but then in the end still become the sort of central security or IT departments that they often grew out of. I really want to change the role of these teams from being the policeman to being the lifeguard. I think that when we create a safe Azure environment, I see that as a safe swimming area where everyone should be able to swim themselves, but only when things go wrong, then the cloud platform team can jump in. And for the rest, they just help in making a secure environment that works for everyone. So let's look at how to build this safe environment. So what I often do is, as I said, I create a number of subscriptions per team called landing zones, where they can do their own stuff. So I like to call them value streams, building teams that are really focusing on value for the end customer. So focusing on building part of that value stream. And then we give them a number of things when we start such a value stream. So on the one hand, we give them Azure subscriptions where they can run and build their own infrastructure. But we give them insights like cost insights or security center insights. So the team knows that there are certain security incidents or that there are compliance checks that they are not checking. But I also like to give them a full environment, for example, a Azure DevOps environment that helps them build automated pipelines, store all the code that's really tightly connected towards these Azure environments. So when I provision these environments and create them in a self-service way, I like to build an environment where a team just gets a Azure DevOps environment, including a number of Azure subscriptions, but there are already service principals and service connections made available in Azure DevOps. So when people start creating pipelines, they can automatically deploy to these Azure environments in a safe way. So that teams don't have to think about setting all this up and just making it easier to do things in a compliant and secure way. What I often see these platform teams do is, when you want to get things done, is, well, you have to send them an email or go to ServiceNow or other ticketing systems to get your stuff done. I'm a developer from my background, so what I'd like to do is build automations for it. Build solutions for other teams so they don't have to wait for tickets and those kind of things. They can just build it themselves. And what I've been doing at several customers over the years is really setting up this governance and provisioning of Azure clouds through code. So what you could do is just defining the team that you really want as a file somewhere stored in source control. And from there on, follow all the same principles that you would like to see your development teams follow, but then to provision this team environment. So all these definitions for all the teams, who has access, what environments they have, what subscriptions they have, is all stored in a Git repository. And everyone can read them because there's no secrets in them. And also everyone can change them. We want to have this self-service. So if a team member needs to be added, they could edit this file themselves. But then when they commit this back to the central Git repository, they have to go through a pull request. And this pull request can either be reviewed by one of the other team members or someone from a certain security team, depending on the type of changes. They can approve these changes, and then everything else will be provisioned automatically. So this makes it a really good way of provisioning your Azure environment in a compliant way, because you get all the audit trails of all the role-based access that were set for free, because all these changes are stored in your Git repository. You have all the changes who had ever had access to your environment. You know who created which environment and when. All that's being stored in your Git repository, so that's really a great way to do this. And it's easy to just create automated pipelines that trigger on these pull requests that will actually execute these changes in your Azure environment. So provisioning your Azure environment is one thing. You could take this a lot broader. You could look at setting up your firewalls and your network access as code. If you want to hook up to API management in a central environment, you could have teams do that in a central repository where they create pull requests to add their changes. If you want to do things like a enterprise service bus, one service bus that all kinds of teams should have access to, you could do it in this way. If you want to have role-based access in any other kind of system, you could do it here. So all these things, you could follow this same pattern. What I really love is when you try to do these kind of things, really build a enterprise open source solution. So everything is open for everyone, and you can use these same principles to build out the product even more. Let's start off with a really small solution to provide these Azure environments. And when people want to have more features, everything is open, so they can contribute to how the automation works, so everyone can help building a better solution. Then, looking at more compliancy, pipelines in my story are really a big key. So what we did for another customer is creating a solution where people really get insights in the tools that they already use. So they don't have to go to other kinds of dashboards to see how their environments are doing. What we did with a specific customer as an inspiration for you or what you could do is just creating some plugins into Azure DevOps so people could see how their environments were actually doing. And even having the option to see certain problems and from there on fix them. So in conclusion, do not enforce these tools upon DevOps teams, but really make a way that works for everyone. And the product owner owns the tools, so you can't cater for everyone. Work for teams that really work for everyone. So with that, I would like to recap and then open up for some questions. When you build a cloud governance, really empower autonomous teams. That's the power of the cloud. So build something that works for those teams so they can build their own solutions. Really focus on automation. This gives you so much insights and make it easier for everyone to use instead of using all these paper compliance and security checks. If you build a cloud platform team or a cloud center of excellence, make sure it only accelerates other teams and it does not own the whole cloud. And lastly, really focus on building an open source community for all the stuff you do on cloud. If you build certain building blocks, make them so everyone can contribute, so the adoption is a lot better and you can move faster. With that was my presentation. So let's open up for questions.
Hi again, Gert. Thank you very much for your talk. Actually, we have a question here. How do we make all those good stuff and good, tips happening in my company? Where should I start?
So what I often do is try to focus on one specific value stream and start doing that from top to bottom in making sure that they can do the stuff they want to do. As I said, you can't cater for everyone. So if you have a really specific case, help that team build their solutions, and from there on, grow the platform.
Okay. Well, is there maybe I can put your screen again? Yes, there's your email address and your Twitter handle when we can reach out to you, right?
Yeah, I'm really passionate about this subject. So if you're struggling within your company about, if you're a DevOps team, you're struggling with IT departments, or if you're working in IT or security and you have DevOps teams that are breaking all the stuff all the time, just reach out on Twitter. I'm always happy to discuss these things with you. So.
Thank you so much, Gert. Thank you for taking the time, for your commitment, and for sharing your passion here. We can definitely feel it. Thank you a whole lot.
Okay, you're
welcome.
See you soon. And see you soon.
Yeah, see you next year.
Good luck to the next speaker. Okay, bye-bye.
Bye. Okay, we're not done yet. No, we're still going strong indeed, as we have in a few minutes JJ coming from Austin, Texas. How does that sound, really? I feel like we've, leveled up to a certain kind of coolness now. Okay, so we'll go into JJ's talk in a few minutes, but please catch a little break before we go. We'll talk about migrating a monolith to cloud native and the stumbling. It sounds like it comes with a lot of experience indeed. See you in a bit, and just see you after the break. Bye. Hi again. Hi again. It's the middle of the afternoon in Paris, but what time is it? In Austin, Texas. Hi, JJ.
Hi, how are you?
I'm doing great. How you doing?
Good. It's almost 8 o'clock in the morning, which
I don't
isn't
feel
too
so
bad.
bad then.
Yeah, but I'm also a late riser, so this is actually quite early for me.
Oh, okay. So, well, what we'll do is that we'll make sure to send you a little care package from France,
Oh,
so
some
we
coffee.
can. Yeah. Awesome. I just want everybody to know that JJ is here for migrating the monoliths to the cloud native and the stumbling blocks that you don't know about. Why do so many companies fail? Why? And first thing first, JJ, there's something about you that people need to know. You hate computers.
I really do. I really, really do. They drive me crazy. They really do.
That's great. This is why you are at the TheCloudFIrst
Yep.
European conference. That's wonderful. Tell
Awesome.
us why. What's wrong?
So I've been in the industry a long time, and I know computers do exactly what you say, right? That's what they're supposed to do.
Sure.
But they're really complex and they're really hard to understand. And I have no problem with saying that I genuinely hate them because they just drive me crazy, like just completely crazy. So it was just kind of, it's a fun little jab at my career, but you know, it's true. Like if you're probably here at this conference trying to learn something new, you've probably been driven crazy yourself. So hopefully I'm in good company.
Oh, definitely. And this problem has no frontier, no barriers. I believe that everybody goes through the same thing. So I will give you the floor. And please know, guys and girls, in the YouTube chat that you can ask your questions, and we'll make sure that JJ has the time at the end of the session to cover them. And also, you can tweet at us again, TCF21. This is where we at. And JJ, floor is yours. Have fun.
I would like to say just real quick,
Yeah.
if you'd like to interrupt me with a question, please don't hesitate to jump in and be
You
like, hey,
shouldn't have
there's a
said that.
question. Yeah,
That
no, I
sounds
have no
good.
problem with that whatsoever.
Okay, sounds
Awesome.
good, JJ. Thank you. See you in a
Thank
bit.
you. Well, hello, everyone. Oops, I got to hit the button, don't I? There we go. So, hi, my name is JJ Asgar, as Charlene introduced me. I'm a developer advocate for the IBM Cloud. I really do have the email of awesome@ibm.com. You can actually reach me there. And you can find me on Twitter at JJ Asgar, which is pretty straightforward. Today, I'm going to be talking about migrating from a monolith to the cloud native with the stumbling blocks you probably haven't thought about or don't even know about. So hopefully you'll learn something new. Hopefully you'll have a little bit of fun while I'm talking about it. I try to make this a little bit entertaining so we can kind of work with it. Also, if I have a little bit of a Texan accent, I'm sorry about that. And I might have a handful of, I try to enunciate to make sure that everyone can understand me. But if you do have any questions afterwards, please, my job is to be a resource. Reach out and I'd love to have another conversation with you. All right, let's go. So I'm going to start everything off by talking about a company called Asgar Labs. Asgar Labs is a multinational tech conglomerate bought hard into the VM ecosystem. It makes the ones and zeros of the world better than any other company. And notice it was falling behind. In all seriousness, Asgar Labs is just a collection of different companies that I've seen stories taken from of their failures or their stumbling blocks. And I use Asgar Labs as the catch-all kind of statement for it. So basically, if you think of random company, I'm just going to call it Asgar Labs to kind of keep the narrative going. And yes, it is fake, completely fake. It's actually my domain that I use for all my domains and things like that. And no, they aren't hiring if you want to come work for it. That's supposed to be a joke. So we'll start off with what Asgar Labs thought they needed to do. So because they were in the VM, or they moved from bare metal to VMs a while ago, they saw containers coming down the line and they were like, oh, okay, cool. So let's take what we know about moving from bare metal to VMs, and we can just take VMs to containers, right? Like we've already done this modernization. Here's another opportunity for us to do that. Let's just take what we've learned and make that happen. I mean, they were genuinely thinking that moving from bare metal to VMs is the same as VMs to containers, right? Like that works. They believe they could just move to cloud native and not have to worry about anything. Well, honestly, the narrative goes where I come in at the point where they have 2 or 3 quote unquote successful migrations, right? So you might know that company out there that have been trying to move into cloud native. They might have 1 or 2 apps that have actually moved on to Kubernetes or OpenShift or Nomad, and they're just kind of they're humming along, but other apps just aren't kind of happening. Normally, that's where someone like me comes into the conversation and starts talking about the things they haven't thought about or wondering why this is taking so much time and effort and honestly money to try to get these apps to move into cloud native. I try to ask some very simple yet tough questions to force the conversations that probably they didn't have when they first started down this path. So you can take these lessons learned if you're just about to start into cloud native. If you've already moved into cloud native and try to like do a couple apps, or maybe you think you've been successful, but you didn't realize that there are some things that you might haven't seen coming down the line. And hopefully from this presentation, we'll highlight some of those things. So before I start with anything, I want to start asking some questions you should ask yourself that are very straightforward, but are deceptively hard to answer. Every time you come together and have these conversations, these are the questions you should ask yourself, or for that matter, your team, to make sure that you're going to be getting the best bang for your buck, or bang for your euro, I guess. Again, it's supposed to be a joke. Okay, first thing first, who containerized your app? Was it a developer and operations team? Was it a completely different team out of your normal cycle for your application, right? Also, were there more than a quote unquote a couple status meetings, Asgard Labs, between the project team and when they shipped it? You need to know who actually spent the time to containerize your application. The operations team and the development team are going to look at it 2 totally different ways, and that could be a huge problem that you haven't identified. And you might be dealing with things that aren't being leveraged in the correct way. And I'll go into more detail on that in just a moment. The next question is why? Actually ask you why. At Asgard Labs, I saw one org, they went ahead containerized because they were told to. That was what their CEO, CTO said. We have to containerize our application because we need our core software stack to be now next gen. It wasn't really for any other reason than that. They needed to be able to go to their cohorts and their friends and their investors and say that they were next gen. Not for the business, other than that was a little checkbox on their bonus structure. And that's not great. Like, take a moment and really think about why are you moving into this world? Because as I show later on, it's a good question to ask. The next, where did you deploy, or where you plan on deploying your containerized application? What cloud are you actually going to use? I mean, did you you decide to deploy to whatever cloud because you have an ELA with them? Or was it a choice? Was it an actual choice? Did you spend your time and effort to look at all the different opportunities out there, all the different clouds out there? Or for that matter, did you spin up your own Kubernetes cluster? You should not spin up your own Kubernetes cluster, but let's just say you might have decided to do that. Is it the best one for you to use? I mean, as an IBMer, obviously I should say that IBM Cloud is a great opportunity, but frankly speaking, every business is different, and it's a really hard conversation to see if you can use the correct tool for the correct job. And then finally, what did we actually containerize? Like, really, what did we do? Did we just take a WAR file or maybe an EAR file and throw it into a Java Docker container and called it a day? Like, this opens up so many different conversations about what you are actually containerizing. It's no longer as simple as spinning up Tomcat and throwing a WAR file in there, and now you have your application deployed. There's a lot more conversations you need to have, and a lot more integrations and discussions that need to happen between many, many teams. So let's take a quick aside and look at some architectural changes that, as you are trying into moving containerization, that you kind of helps map out what we're going to be doing. So let's take the first simple example of that, the tongue-in-cheek of taking that WAR file and throwing it in a container and calling it a day. That's what we call a re-platform example. So obviously I'm an IBMer, so I'm going to be showing some IBM technology on here. So before you had IBM WebSphere, you had your legacy app with your middleware. You just take that whole kit and caboodle and you throw it into a Liberty container and you dump it on Kubernetes or OpenShift, hopefully OpenShift, and you call it a day. Congratulations, you're now cloud native. No, you're not cloud native. You've just re-platformed to a different platform that you are not taking advantage of. This is the quote unquote easiest path, but this is the path that is most sought with peril along the lines, because you're no longer using the technologies for what it is. There's so many little, dragons in this re-platform example that you're nowhere near where you need to be. So let's take it one step farther. We can look at repackaging into microservices. Now, this is a great intermediary step from that re-platform to repackaging. So you start taking all those different WAR files and creating a bunch of different containers that have their own containers. So they have their own namespace, or not namespace, but they have their own container that they can talk to the shared resources. This is a little bit better. This is working towards where you want to be. So now, if you need to spin up multiple instances of your application, or if you need to scale out either vertically or horizontally, it's much easier to do. Problem is you're not quite there yet. This is the intermediate step that there are fewer dragons because now you're leveraging the technology for what it does, but there are still some growing pains. Where you really want to get to is moving towards what we call the strangler pattern, where you refactor your application with the strangler pattern. So yes, this is the first thing that hopefully I've hit home, is that if you're moving into the cloud native ecosystem, yes, you are going to have to refactor your application. You absolutely will. No one, if you've gotten out of not being able to do it, you will be doing it down the line, because that's the way this ecosystem works. The traditional monolithic app needs to be refactored. So one of the best ways to do it that is the most effective is using the strangler pattern, where you slowly but surely take your massive monolithic app and you find the different services inside of it, and you start spinning them out as their own microservice. So that it has its own container, and it has its own history, and over time, everything starts breaking apart. So let's talk about some of the very good advantages and the painful disadvantages of going down this path. First of all, velocity. You will have a change in velocity for your application. In the monolithic ecosystem where you are running your monolithic app, you might have a release every 6 months. If you're lucky, maybe every month or even every week, right? Well, moving towards microservices, because they have their own history and their own deployment process, and because the way you work with cloud native, now you can actually have 30 releases a day. There's nothing stopping you from doing that, leveraging the technology to do it. And you can actually scope your clusters and your actual usage to what you actually need. That is something that people forget, is that this stuff costs money to run. And you might have a bunch of hardware out there that's literally doing nothing because you haven't written your applications to work on it properly. So that's something great to keep in the back of your head. But at the same time, there's some disadvantages. It requires a higher level of cooperation. And you need to be able to build out more than just simple integration tests. You start building advanced integration tests where things really do talk to one another. You need to have this whole world of understanding to be able to get to there. And also, honestly, you're probably going to need a different deployment system, because now you have all these different ways and leverage it, all these knobs and dials. Wow, can't speak. It's 8 in the morning. You're gonna have to work and change the way you deploy things. So to take that one step farther, so our goal is to move away from the CCB. If you don't know what a CCB is, it's called a Change Control Board. If you've ever read the Phoenix Project, the Change Control Board is something that the main character is one of the first things he's involved in, which is that team of people who decide to say yay or nay on a change in an operations aspect. In the waterfall environment, or even in the monolithic resource or way of doing stuff, a CCB is really important, because then you have everyone sign off. The dev team, the QA team, the operations team, the networking team, the whatever team, all get to say, yes, we should make that change. Now, moving into the cloud native ecosystem, if you're making, I say this with all seriousness, 30 changes a day to your application, you'll never be able to have a CCB again. It just doesn't work that way, right? Like, could you imagine 7 or 8 people in a room every single time a pipeline kicks off that they have to check in a box to say, yes, this is okay to release? You'll just never nothing will ever get done, because they'll be sitting there waiting for that. I did see at Asgard Labs one CCB that was just a complete and utter failure of an example, which was, I was sitting in that room and I had the privilege of being part of that CCB. And we were making a change to our production infrastructure. And we were trying to make a change to a back-end database system. For whatever reason, we needed networking to sign off on something. And networking came along and said, no, we can't do that. So we had spent 6 months trying to get this change on the database to be tested and verified, QA, integrations, operations, everyone signed off. And then networking comes along and says, no, sorry, you can't open port 3306, or 330, whatever the MySQL port was at the time. I'm saying that with jest, but you get the point. You know that conversation. Because they needed another 6 weeks to get the change ticket in, to get it on the front end, to allow for that communication to happen. Now, that was a normal day in a CCB at Asgard Labs. That doesn't work in the cloud native ecosystem. It just doesn't. So, yes, one of the main goals is to move away from that. But you still have the ability to, what's a good word for it? Have accountability. You just have accountability in a different way that, frankly speaking, middle management doesn't like, because they don't have those meetings anymore. You use automation. And let's talk about that in a little bit. So, are we doubling up on things? Are we making this harder for ourselves? Well, you'll need to audit and verify that you aren't doubling up on things. One of the greatest examples for Asgard Labs was that they had a scheduler built inside their application. And this was one big monolithic pod that they just threw all their Java stack into and put it on a 3-node cluster. Well, they had a bunch of services or jobs that would spin out out of that application to do different things. So they scheduled jobs to make things happen. I remember this was actually one of the first conversations I had with this Asgard Labs. And it was, they said, hey, JJ, we see one machine that has like 50% usage and then like 99% usage. And we don't see anything else running on the other clusters. What's going on here? So I dug into it and I realized that they had just thrown everything into one pod and it was all spinning out inside that pod. I asked them, you realize you don't need you need to leverage the scheduler that is Kubernetes. You need to create microservices so it can spin those out to level set across the whole cluster. And they're like, oh, JJ, we already have a schedule. We don't need to do that. And it was a really weird conversation because they weren't leveraging the technology for what it was trying to do. Eventually, I got through to them, and yes, they are in the process of refactoring that now. But it was one of those things that they just thought they could dump something onto Kubernetes and congratulations, they were cloud native. Another story goes along with load balancers. Now, if you look at how a load balancer is done with an F5 and on your old DC or whatever, or data center, you probably have a load balancer in front of it for your whole network. Well, you're not going to need that load balancer if you have Kubernetes there, because Kubernetes has a load balancer built inside of it, or OpenShift for that matter. So when you start looking at your applications, there's that F5 that you have there. It's an extra hop. So think about it and really understand that with the technologies of cloud native, you could be doubling up on things, and you really need to sit and verify these. So isn't automation good here? And why is everything so complicated now? Well, of course, automation is good here. Yes, you should absolutely let the bots do the work for you. I mean, that's the reason why they exist. We've created computers to make sure that human error-prone situations don't exist, or are no longer part of that equation. So yes, you are going to be leveraging automation down the line, or even sooner than later. And now, why is everything so complicated? I want to turn that on you. It might be complicated. You might be complicated now, but honestly, it's probably always been this complicated. You just didn't know at the time if it was complicated, or you didn't have that visibility. So you'd be amazed on when you start seeing how the microservices come together and your application stack comes together, how truly, how interesting you can get. And to say tongue in cheek from a good friend of mine, Ken from GoCD, he stole this quote, so I'm stealing it from him. We replaced our monolith with microservices, so every outage now is a murder mystery. And take a moment and think about it. It's true. Like you're gonna have to deal with that. It's one of those harsh realities of it. No longer can you just look at one log file to look at what's going on. You're going to have to set up some aggregate log monitoring. You're going to have a log file unique to every service, and you have to bring everything together. You'll have to walk through each process and what it did when. You're going to have to create standardizations between different teams, and I'll talk about that here in just a moment. So I mentioned the CCB earlier, and at Asgard Labs, the CCB became almost like what the Phoenix project was at the beginning. Eventually, no one showed up. I remember I was part of that CCB at the time, and nobody was engaging. Like people, if QA decided not to show up, they couldn't get the +1 or the thumbs up on that change, and we have to wait till the next window. And that's another thing. You'd have to have windows for releasing things, which is ridiculous. When you're moving to cloud native, you naturally start thinking of self-orchestration and rollouts and updates. It becomes a cultural shift. No longer do you have people sitting in a conference room giving your thumbs up or your thumbs down. Now you are the drive to get things done. And when you get things happen, successes do happen. It just requires a cultural shift that a lot of corporations have trouble with. So of course, you build that pipeline, right? You have to have that pipeline to be able to allow the bots to do the work for you. CI and CD. The gentleman before was talking about Azure DevOps. It's an amazing tool if you can leverage it for what you need to get done. Same thing with any other thing. I mean, if you want to use Jenkins, by God, go use Jenkins. It doesn't matter. One of the most easiest reasons why Go can be so easy to read is the Go format command. And this goes back to those standardizations. Go format gives you a standardization to make sure that every single Go file looks the exact same, or at least reads the same. And the reason why I bring this up is because at 3 in the morning, when you have a production outage, right? Do you really want to spend the cognitive overhead to read code to figure out what happened? Or if you know that it's always formatted the exact same way, you can just read it like a book. Of course, it's going to take some time to get used to it, and you're going to have an agreement across your whole org for it, or your whole team, or your whole application stack. But it's worth it. And when you have that pipeline, you can enforce it, and that is unbelievably powerful. So you have to learn to collaborate with other teams. And I mentioned this about having the standardization and the way to make things work, and it becomes more challenging and challenging. So you're going to need some architects that understand the umbrella of the application, but you're also going to need different teams to focus on the different widgets of the actual application. Now, you're probably wondering like, oh, JJ, that's ridiculous. That's never going to happen. Well, I want to say collaboration is not just meetings. It's more than that. It's shared contracts between application teams and understanding of how their APIs talk to one another and they expect from other things up and downstream from them. But this doesn't work with just Jira tickets. One of the most successful things I ever saw at Asgard Labs was every sprint. There were 2-week sprints at this company, or Asgard Labs. And what they did is they randomly chose someone from each tribe that was taking part of the different microservices, and they would change it with someone else inside of that stack. So let's say we had 5 teams, 5 people would switch teams. So obviously going back to the cultural change, that could be a really hard problem to have with like policies and procedures. But this corporation actually experimented with it, or Asgard Labs, I should say, experimented with it, and it became super successful. Because all of a sudden, now imagine every 2 weeks, you have to train someone new on how your little widget works. So all of a sudden your documentation becomes better because you need them to be successful in 2 weeks because they're going to be gone, right? All of a sudden you need to be able to, now when you grab that knowledge and go to your next team, all of a sudden you have an empathy for them across the board. It's unbelievably successful. Challenge was, not all companies can do that. But if you can move to something like that and that kind of collaboration, you'd be amazed on what can happen. And I would absolutely love to talk to anyone who is at least thinking about going down this path, because I really have seen some awesome successes with it. So the next step is visibility and monitoring. Back to how complicated your application is, you are going to need visibility and monitoring. As badly as Asgard Labs wanted a single pane of glass, it's unrealistic. There's so many moving parts from a cloud native application that you can't. You need to have people understand different layers and how the application works. Your operations team is going to have this global knowledge that usually they're not super comfortable with. Traditionally, Nagios did everything you needed. Now you have so much more involved. So you have to spend some time with that. I'm going to speed up just a little bit here because I believe I have only about 5 minutes left, and I do want to give an opportunity for people to ask questions. So I do want to talk quickly about the economics of moving to cloud native or the cloud in general. Just to touch on it, because it is something that's important. All companies require to deal with money, so it's important to recognize that there are dragons in the money side too. When you move to the cloud or cloud native, you start spending time inside of with a credit card. Well, excuse me for a second. With that credit card, all of a sudden it becomes relatively easy to buy more. So when you buy into a cloud, if you decide to use something in a cloud, if you're not careful, your actual OpEx can be higher than your CapEx was for your data center. So you need to really pay attention to your spending. Hell, there are companies that are based just around spending on AWS. But don't forget, your CFO, on the flip side, can't depreciate the hardware of the data center anymore. So there could be actual tax implications. It's a good conversation to have with your executive team to make sure if you are moving down to cloud native that you really thought about these things, because depreciation and money for a company is a really hard thing to deal with. And if you just moved into cloud native and started going down this new path, it could actually have issues down the line that you haven't even thought about on the money side, that is. So what do you mean all our support is now on Stack Overflow? Well, in a few places that's true, right? You now that you've moved down to cloud native, yes, there are companies like IBM that sell products around it. But if you have something that goes really, really wrong, honestly, you're going to have to reach out to the community. And dealing with an open source community is a skill. It really is. Like you can't just go out and be like, hey, I have a problem, help me. No, you're going to have to work with that community and be involved in it and really understand it. So you're going to have to spend some time there and really, really take those moments. So let's talk about some tangible things to help you to become more successful as I'm finishing up this talk. The most important thing you can do is have a large conversation about why you're moving down this path and what we are doing. Like, it's so many times have I seen companies just want to move down that path because it's the next gen, or their CEO has said that they are now cloud native, not realizing that if you're making money using VMs on a monolithic app, unless there's a really strong reason to move that to microservices, don't. Just use the new, like, you can make new apps, right? You need to make new stuff. Don't move your old stuff there. Spend your time writing an app that actually fits that technology. Like, really have those hard conversations. And this is weird coming from a developer advocate for a cloud, but I want you to be successful, right? Like, that's how I'm successful, is seeing people successful on the cloud. And a lot of the times, it really is like we didn't really know what we were doing, and hopefully this has opened some eyes. So, as I said a moment ago, where can you go from here? Again, it's the best thing, the really committed to do this. Well, you need to take a moment and look for those optimizations instead of features. You need to understand your application stack to see if it can fit inside of the cloud native. So I want to end right here with a quote from a great friend of mine. You wouldn't use a saw when you needed a hammer, or a hammer when you needed a saw, right? Thomas Kate is a good friend of mine. When he said this bottles up this whole talk in such a great way to think about it. Like, yeah, of course, you can use a saw. Yeah. You can use a hammer when you needed a saw. It does the same thing. I mean, you imagine you hitting it to try to cut a piece of wood, or you'd use a saw when you need a hammer to hammer in a nail, but it's just not the right thing. So think about it for a moment and really take that beat and realize it. I want to say thank you again at JJ Asgar on Twitter and awesome@ibm.com. I should have a little bit of time for questions? Question mark?
Yes, you do. Well, first thing is maybe, and just to recap again what you've been saying, but just to put it in a nutshell, like, what be the first one action, let's say, that if you want to make it like bulletproof, what would be the first action you should do? Or support or communion you should get in front. Yeah, it depends.
It depends. But yes, so I have seen many companies, the first thing you should do is not take your application and your WAR file or your EAR file, put it in a Java container, and put it on Kubernetes. Like, if your management tells you to do that, to say, test it, what is the best permanent change is a temporary fix. Right? So if you're just testing it, you'd be amazed on how many companies, especially massive corporations, that's what they do. And they're like, oh, this tested fine. Let's keep it this way. No. Look at that strangler pattern. Look at the new features you want to do and spin that out as its own microservice. And because if you're going down this path, or if you started going down this path, you've already invested a significant amount of money and a significant amount of time. So you need to do it the right way. And there's the wrong way that is the easy path that you are just going to have painful down the line. And the right way, that's the harder path, that requires collaboration and actual conversations with real humans and actual refactoring. Did I answer your question?
Oh, you do. And actually, I was wondering if there's some kind of a, because it shouldn't be for everybody. We hate it sometimes when we say, oh, everybody should be, going full cloud native. Yeah. Can we just put that aside and say, no, it's not for you, and that's all right?
Absolutely. Like, I guess I didn't reiterate as much as I like to during the talk, but if your company is making money using a monolithic app on VMware inside your own data center, and you are in the black and you're not in the red, why touch that? Right?
I know.
Like you have probably other things you could be focusing on, right? Or your next application or something like that. Write your application to be cloud native. Like, moving that application that is actually making you real money to cloud native, mightn't be the wrong answer. Like that could take it down and it might not work. And then all of a sudden that plus money becomes negative money with human time, with engineering time, with actual downtime for that matter.
Actual
right?
downtime, yeah, indeed.
Yeah. And you have to have these conversations. And so many and as I said, I'm a cloud advocate. Like I'm trying to get people to be the cloud. But I want you to be successful in the cloud. And there are conversations where people are like, yes, let's do it. And you're like, no, you really shouldn't.
And actually, how do you help also clients, colleagues, and so on to make sure they have the right capabilities, competencies, skills? How do you approach that?
That's a great question. A lot of it is engrossing yourself into the open source communities that are around these things, mainly because you can, like, yes, there are courses you can take and things like that, but those are all opinionated. And one of the worst things about the cloud native ecosystem in general is that everyone has opinions, right? Like I tried not to show any strong opinions during this presentation because, again, it depends, right? Like your application is your application. And my opinion of how to run your application, I'm not an expert in it, right? Like, okay, sure, let's talk about WordPress all day, but your actual business logic of your application, you are the expert. So you actually know what is most important for you to get done and spend that time with. I'm just here to tell you, these are the tools and this is the ecosystem that you're trying to get into. I can be like, okay, yeah, you don't need that tool, or you don't use Linkerd, use Istio for your service mesh or something like that. But at the same time, it's a conversation that needs to happen, and you need to walk through those things. Did I answer your question?
No, you did. Yeah. And okay, but well, I'm sure there will be more questions going to your Twitter handle. I just want to make sure that it's right here.
Yep.
Yes, here it is at JJ Ashgar. The awesome at IBM is awesome.
Thank you.
Please keep it forever. Don't change it.
It turns out at IBM, I was actually a contractor a few years ago at IBM, and everything sticks with your name at IBM. Nothing changes. So when I claimed this was a couple of years ago. When I claim this, yes, this will always be my email address as long as I'm an IBM employee.
Oh gosh, this is what I should have done. I didn't do that. That was stupid. Next time, maybe next company, if I ever go to another company, yes, definitely. Thank you so much for your time. Have a wonderful day, JJ. And yes, please go to his Twitter account just right here for more questions, for more content, views, and ways to hate computers but still be working with them.
Thank you so much.
Have fun, have a good one, and thanks again for your time. See you soon, JJ. All right, everybody. We are almost at the end of the day. I know it sucks. We'll still have 2 great talks that will come up in 5 minutes. Next one is Shira. She is based in Israel. I'm telling you, we have people coming from all over. It's insane. But it will be in 5 minutes. We're taking a short break and we'll see you right after. Hi, everyone. Microsoft is very, very happy to support this one-of-a-kind conference, TheCloudFIrst. And this is not our only way to support developers and communities, isn't it?
No, it's not. And we are all part of the developer relations team here at Microsoft. And you may have already seen us at other conferences or events. We are here to meet you and help you familiarize with our tools like Visual Studio Code, Azure, .NET, and many others.
You can also find us on Twitter at msdev_f4. We're also there on meetup.com, where you can find lots of Microsoft communities that we support. And lastly, find us on YouTube at Microsoft Developer France. Also, if you have a second, have a look underneath the video at the link to register to our monthly newsletter. We hope to see you soon and enjoy the conference.
See you guys.
Bye.
Hi again. Hi again, everyone, girls and boys all over Europe. We are getting towards the end of this conference. Yes, I know. It's not great news. It's not great news. But what you need to remember is that we have two wonderful speakers coming in. And actually, we have now Shira coming in, and she is right here. Hi, Shira.
Hey, how are you?
Doing great. It's now sunny and beautiful in Paris. So what can I ask for? You know?
That's really good.
Well, where are you based, Shira?
I'm based out of Tel Aviv. Already sunset over here.
I guess. And I believe you've seen it, but we have people from all over today. And I think this is quite amazing to see all this engagement and commitment and energy coming from all over Europe and outside of Europe. It's wonderful. Thank you very much for being here. Shira, you will be talking about managing identity today. It's definitely a pitfall that we can go and dive into. But first, there's something kind of nice about you, something that's not kind of nice. I think it's kind of a superpower what you did there. But who are you taking to your office?
Well, I have a little friend. That's my dog who comes to the office with me. She's actually right here next to me. I can maybe at the end of the talk, if we'll have a moment,
please.
I will show our audience. She comes to the office with me. She greets everyone who comes in. And whenever I have to stay late in the office, she keeps me company.
Oh yeah, I believe that. I wish we could do the same thing. And actually, did you manage to make that change in your previous job? Is that right?
Yes, that's true. So I used to work for another company that got acquired by a very large company, and they didn't have a dog-friendly policy in the office. And again, I used to bring my dog to the office every day, and she was absolutely a part of the company. And after the acquisition, the big company changed the dog policy so that I could start bringing my dog, but it wasn't a policy just for myself. It was a policy for the entire company, of course. So since then, they've been having dogs in the office. They make great atmosphere, and I think they make a very good workplace, a better workplace.
Oh yeah, no doubt, no doubt. Fingers crossed we can do that soon. In Paris, I don't think this is something very common, but it needs to change. So thank you for inspiring that change. And now let's go down to business. We're going to take a look at the common pitfalls and learn from handling identity management and how we can prevent that being as autonomous as possible. All right. I'll leave you the floor. You have 40 minutes ahead of you, so you have enough time, and we make sure to get the questions at the end of the session. Please go into YouTube for all the questions you need to ask to Shira. I'll see you in a bit. Have fun.
Thanks. Hi, everyone. Great to be here with you today. I'm really excited to share everything you need to know about identity and access management, and let's get started. So, first of all, a little bit about myself. I'm Shira, and I'm the CEO of Solvo. We're a new cloud security company. Other than that, I have a great passion for security, and I have a great passion for women and minorities in the security industry. So I try to mentor, and I also started my own mentorship program where lots of other women from the security industry can help each other out. You can ask me questions about that later as well if you want to. But let's get to talking about identity and access management in the cloud. So we moved from the on-prem to the cloud, right? We no longer just deliver code and let IT handle everything else. The software developers have so much responsibility today that they didn't have in the past and never asked for in the past. Now think about it. We were given the power to provision any cloud asset or service that we want, at any size, with any compute power from anywhere in the world. In the cloud, we don't only deliver code. We now deliver a microservice or an application, and our entire architecture is API-based, so there are a lot of decisions we have to make around it. Again, it's no longer just writing the code. Some decisions are also related to security, of course. Where the bare metal ends, our responsibility begins. We are responsible for security for infrastructure as a part of our application. Today, there is a very, very thin line between the infrastructure and the application when running in the cloud, because some of our infrastructure is actually a managed service. A managed service by itself is a small application that now became a part of our bigger application. We will talk about it more. Now, the cloud providers created a few security services and mechanisms for us to make our life easier and more secured. And today, I'm going to drill down on a specific one called Identity and Access Management, IAM. I decided to speak specifically about it because it describes very well why cloud security is so different from the on-prem security. Again, in the past, we used to do security in the network layer by filtering traffic. We had the firewall, we filtered by port and protocol. And today we have a much stronger tool to do that. We do security in a very, very granular form, but we have to do it very wisely too if we want it to be very, very meaningful. Let's get started. What exactly is IAM? It's a security mechanism that allow us to define and manage in a very granular manner all the access to our services and resources in the cloud account. We can give or deny access, and we can require for certain conditions in order to approve an access or an action. Let's have a look at the building blocks of IAM. An action on an AWS resource can be performed by a principal. A principal can be a user, a person, or a role. I will elaborate on a role soon, but basically, just for you to know, it means a role means a temporary credential. All the principals need to be identified and authenticated with credentials. Credentials can be, for example, a username and a password, but it can also be a unique ID, which is a public, and a token, which is obviously a secret. The principal's attempt to access any cloud service is actually a request to AWS. The request has a specific action like put or get or delete, depends on the service that you're using. The next thing that happens after that is checking and deciding if to allow or deny the request. In AWS by default, all AWS requests are denied. Only the admin user is allowed to do everything, but I know all of you know much better than this and you don't use the admin. So all requests are denied unless a specific one is allowed. I'll show you what that looks like in a minute. We can do different actions with different cloud resources like view an item, create, delete, and so on. And that's and now as for the resource is where we actually perform the action. On which resource are we performing the action? And this is what it looks like. So if, for example, we have a Lambda function that needs to read something out of a DynamoDB, we need to grant it with relevant permissions. So if I attach the admin permissions to the Lambda, for example, it could access all my cloud resources and perform all the actions on them. Of course, it can do read from a DynamoDB, but it can also do everything else. So we don't want to do that. In this case, we should try to limit the Lambda's access and to create a more granular and specific permission for this specific use case. So someone might look at this policy and say that it's a good policy for this case. You can see the JSON file that describes the permission. And in this case, you can see that we have action and we have resource. And inside actions, we can see DynamoDB asterisk, S3 asterisk, and resource asterisk. What this actually means is that I can get access to all the DynamoDBs in my account and perform all the actions on them. So again, using asterisks, using all, is never something that we want to do. We always want to restrict access to the relevant and most minimal or least privileged principle. That means that we only need to give the relevant access to the relevant resources. So using asterisks is a very bad practice. We should create a granular permission that only allows what we need. So in this example, I created a policy that allows specific actions with the DynamoDB. You can see DynamoDB query, DynamoDB get item, and in resource, you can see a very specific resource, a very specific table inside the DynamoDB to which I allowed access. This is what we should always do. We should always be specific about the action and about the resource that we want to give access to. It means we should know very, very well how our application is working and what resources are we using. And this is not trivial to know in such a granular and specific way, but I'm going to show you a way to do it easily. Before I do that, there are a few more terms I want to go over. Users, it might sound trivial. Users or a user can be, the new team member on your dev team. It can be the new SRE on the team. So we usually relate to a person when we say user. When we say group or groups, we mean a group of people who share some common characteristics, like all the DevOps team. In this case, the characteristics are the privileged needs for these people. Now, a policy is a set of permissions that controls the access to the AWS resource. We just saw that in the JSON file before, where you could see the resources and the actions. So they specify who can access to a resource and what action can they perform there. Now, the last thing is roles, and this is the interesting part. So remember we talked before about the API-driven architecture? That means that very often we need to connect a third party or a service to our AWS account, and we're going to need to give them access to our environment or to send or receive data, for example. So does that mean we have to give them a username and a password to our AWS account? I want to get service from a third-party vendor, so I give them a username and a password to my cloud account? This is not only a serious headache to manage, this is, of course, a bad practice. And this is exactly why sometimes we see hard-coded credentials in GitHub, because this is a mistake that people sometimes do. And this is exactly why AWS or the cloud vendors came up with a role which lets us create a temporary credential that can be assumed to an instance. They are time, service, and action limited. So this is a great solution for us. Now, how exactly are we going to create these policies? One way is to go to the AWS policy builder and just create one ourselves. It's rather simple to do it, but it's also very risky because very often people do mistakes. In this example, I wanted to create a policy to get access to an S3 bucket. So as you can see in service, I chose S3. And the next thing I have to do is choose the access or the actions, the S3 that I can execute on the S3. So you can see I have list, read, tag, write. And very often when you start writing your application, you don't know all the actions beforehand. You're not sure exactly what do you want to do. So you just check all S3 actions. This is exactly what I did here. The problem is that, as you can see in the bottom of the checkboxes, there is a checkbox that says permissions management. And that means that I just gave here access to change security permissions. And this is obviously not a good thing to do. And I don't want other cloud assets to be changing security permissions, absolutely not granting security permissions. Now, the next thing I have to do is choose a specific resource, a specific S3 bucket to which I will attach the role. The problem is that S3 buckets have a unique name, and I don't always remember all of the names of my buckets. So this is why very often we just go with a asterisk option. And this is what I just did here. So the bottom line, the policy that I just created, because it's very natural to create this kind of policy, I wanted to put an object in an S3 bucket. That's all. As a developer, I want to run fast in the cloud. I don't want to stop and think what kind of permission do I actually have to build here. The result is that I just created a very broad, very not least privileged kind of permission. And by using it, I might be creating an attack surface in our cloud account. So some of you are thinking to themselves, and this is a good thought, let's use an AWS managed policy. AWS have policies that they created. They have over 700 policies for all of their services and for many different use cases. Many of them are they contain full access, but let's take a look at a read-only kind of policy, because you assume that a read-only is probably a safer policy to use. This is a DynamoDB read-only access. It's exactly the kind of permission I needed before in the example with the Lambda function. And if you take a closer look at the policy AWS is creating for us, again, this is a DynamoDB read-only. So you expect to see only access to a DynamoDB and the type of call, which is the read. But actually, AWS are granting a lot of permissions here that are not relevant, that I never intended to give. They include access to IAM, to EC2, to Lambda, to KMS, to the key management service. So mistakenly, by using this kind of policy, I'm granting a lot of excessive permissions. The next thing I decided to do is to have a look at the IAM Policy Simulator. It's an AWS service, and I highly recommend all of you to have a look at it and try it out. I took the DynamoDB read-only policy, pasted it here on the left side, and checked the simulator to maybe better understand what kind of permissions do I have in the DynamoDB read-only. If you use this service, make sure that on the top bar, you have a multi-select, and you can choose all the services that you want to test it. So you can see how this policy affects them. So I chose rather a long list of services. And as you can see, I checked a total of 200 actions. Most of them were denied, but a few of them were allowed. 8 actions were allowed. Now let's look at what kind of actions were allowed here. One is get function configuration. I remind you that we're looking at a read-only policy from DynamoDB. This policy allows us to get information about Lambda functions in our account, including the name, the ARN, the alias. It allows us to list all the Lambda functions. It lets us, again, have information like the version of the Lambda, to get a pagination token. It also lets us describe security groups. So obviously, it gives us a lot of dry information, like the description of the security groups, the IP CIDR blocks, the port ranges for inbound and outbound, IP protocols, names of security groups and IDs. But it also lets us do a dry run. So it lets us see if there is the right permission to perform an action without actually executing the action, which is pretty meaningful as an attacker if you want to see what kind of access do you have in this account. Next is describe subnets. It lets us, it gives us information about availability zone, about CIDR blocks, subnet ARN, subnet ID, the VPC ID, pagination tokens again. I think you see where I'm getting here with this kind of thing. Describe key gives us the key ARN, the creation date of the key state, the origin and expiration date of the key. It also gives us particular information to asymmetric keys. It gives us the usage of the key, if it's used for encryption or for signing, the encryption algorithm. So again, lots of information in a read-only from DynamoDB. We have a get role action, and we have list roles. So it gives us a lot of information about the roles in our account. It gives us the specific path to relevant roles with the policy. So this is a lot of excessive information that we just gave here to a potential hacker in a potential reconnaissance process, and all because we wanted to allow read only from DynamoDB. Now, what should the policy really look like? I talked about it a little bit before. We should be specific about the action. So in this case, we have S3 delete, S3 get, and specific about the resource. Over here, we have a specific partition, and specific path, and in this case, even a specific file type, a .raw file. We splitted this permission because we needed two types of action to the S3. One was for a specific partition with delete and get, and the other was for a different partition to do the put action. So the AWS cloud provider gives us a very granular tool to build very, very good security permissions. We should actually try to see how to use them in the best way possible. So what can we as cloud users who were given so much responsibility can do to improve our security? First thing is I think that it's our responsibility to learn more about the cloud capabilities and mechanisms. The better we understand them, the more we can make out of them. But you already know that because you're attending this conference today, and that means you're always trying to learn more and get better at what you do in the cloud. The second thing is that we should always remember that security is everyone's job. Even when you have a security team, even when you have an AppSec team, security is something that should be in your mind always, as a DevOps, as a security, as a developer. For the developers and for the QA and for the DevOps, it should be a part of everyone's job. Don't wait for someone to come and tell you that you should get better at security. Security starts at the design phase, and it should happen throughout the entire CI/CD process. Unfortunately, not everyone has enough experience with security, but at least when it's in your mindset, you'll be able to ask the right questions or use the right tools to prevent security failures in your application. Now, there are plenty of open source tools and free tools that I recommend you to try out based on your needs and your application. So you will have access, or you can take a screenshot of this, or you can take my deck later and have a look at these tools. I chose a few of my favorite tools for different phases of R&D, for the pre-commit, for the secret management, for software dependencies check, for Dust, and for permission adjustment. These are all free open source tools, and I highly recommend you checking them out, and I will have the links for them in the deck later on. You'll have access to it. Now, one other thing that I can suggest is that you try out the Security Genie tool. Security Genie is a free tool that we released that actually gives you an overview of your AWS account and lets you know if we found any misconfigurations in your IAM, in your identity and access management, so that you can fix them really easily by yourself automatically. So this is a free tool that, again, you can use, you can run it and get a PDF report to your mailbox. Another thing that you can do by using Solvo is get list privileged automatically. I showed before how easy it is to give lots of excessive permissions, and our statistics show from our customers that over 84% of cloud permissions are excessive. They are unnecessary at all, and people give them unintentionally, and then they have to start removing them. Our mission is to make you list privilege from day one, and this is why Solvo creates list privilege list privilege policies automatically, and this is also a tool you can try out for free and see it in action in your application. So at this point, I'm going to stop and thank you everyone for listening and for being with me today. I'll be happy to take any questions you might have.
Hi again, Shira. Thank you very, very, very much. I think we've covered a lot of topics here, and actually there's a question that comes in. Is it possible to see that? I think you touched that, but is it possible to see a reverse view of the roles granted?
Yes, absolutely. Okay. Absolutely, yeah. It's possible. You can see in the AWS console what permissions did you give. I have to say it's not the most comfortable tool to look at permissions in the AWS console, but it's a start. You can then see what permissions did you give, have a look at them in the IAM simulator to better understand what just happened here, what have you allowed. And when you do that, when you see allow in green to actions you did not know that were allowed in your account, you should think about it again and maybe have them removed. So don't wait for a security incident to remove these excessive permissions off of your account. We usually wait for a bad event or when we hear in the news that something happened to someone and only then start removing security policies. And I know that it's always a hassle. It's always a headache to stop what you do in your everyday life and do some security reviews and security enhancements. But doing it now will maybe cost you some time. Doing it later is going to cost you time and money and reputation, and it's going to cost you with very angry customers. So there isn't an ideal time for this. The ideal time was yesterday, and right now you have to, So my mission is to help developers and DevOps engineers to have security done automatically. Because I know that we can talk about security being everyone's job and security is a culture, but at the end of the day, developers want to write code and run fast in the cloud. They don't want security to slow them down. I don't blame them when they use the asterisks, the S3 asterisks, DynamoDB asterisks in the security policy. They just wanted to write code and run fast. This is what they love to do. And for us as security practitioners, it is our job to give them the right atmosphere and the right tools to be able to run fast. Let us do the hard work for them. Let us do the lift and shift for them. Now, it's not really making any sense to be sitting and writing security policies, because today in the cloud, security policy is as dynamic as your application. If you deploy several times a day, you can't expect your security policy to be static. It will be as dynamic as your cloud application. So by using an automated tool, either one of the open source tools that I mentioned before, or using Solvo, is going to create that dynamic security policy that you always wanted to have but didn't have the time to create.
That makes sense. And what do you see next for Solvo? Is there like new challenges that you like to top off or anything in mind?
Yes. So we have a lot of things coming up. One of them is our upcoming support to Azure, because the world is moving fast, and we see many AWS customers either migrating to or adding another cloud vendor to their portfolio, or just building from scratch in Azure. It's becoming more and more popular, so we definitely have to support that. After that, we're going to support GCP. Another very common questions that we get asked, and we're working on that as well, is supporting the users, right? Because today we're talking about access to infrastructure, but obviously the users also have access to the infrastructure. The majority of actions in the cloud are made by machine to machine, asset to asset, but we also want to support the user to asset and make sure that the users have the least privileged principles that they need. So we will do that automatically as well, because I think that it was a few months ago that we heard that there was a company that have a very popular meeting streaming service that left credentials for an employee who didn't work with them anymore, and he deleted some of the machines in the cloud. So obviously it makes we think that it's so trivial to make sure that only the right users get the relevant permissions, but what do you know? We forgot to remove permissions from an employee who is no longer with us. So we think that it is still a problem, and we will tackle it automatically, because obviously manually is not working anymore.
No, it's not. And obviously you cannot, there's always where the error is between the keyboard and the chair. So obviously
That's
this is why to automate as much as possible. That's very cool. And Solvo is only, is it only in Israel or available everywhere, I guess? Do you have offices outside of Israel?
Right now, our office is in Tel Aviv. But luckily, using the cloud, you can get access to Solvo from anywhere in the world. So we have customers anywhere from Asia to Latin America and everywhere in between. So anyone who wants to can visit our website. And if anyone wants to, you can email me to securitygenie@solvo.cloud, and I will give you early access to our new product. So that's only for the TheCloudFIrst listeners or audience.
There you go.
Early access for you guys before our GA that's coming up in a few weeks. Email us and get early access.
That's wonderful. Thank you very much, Shira, for your time and commitment and for giving us all those great tips and tools that are already available, actually. Thank you, and we'll see you next year, I hope.
I hope so too. Thank you for having this great conference, and thank you so much for the audience.
Thank you, Shira. Let's talk soon. Take care. Bye-bye. All right, everyone. We'll have a longer break for our last conference, which will be at 4:35. So you have a little break here. Enjoy. Take a big cup of coffee or at least like a nice tea, a nice little break here. We'll see you at 4:35 with Dominique Torneau talking about Canary releases. You'll see, and Dominique is from Cisco. Know that because you're gonna love it. We'll see you very, very soon. Hey everyone, this is the end. Yes, it is the end. How sorry we are. We've been getting feedbacks of people saying we want the same one next year. We don't know if we're going to be able to do that, but sure is that we want to make it memorable. And this is why we have Dominic joining us right now. Hi, Dominic, how are you?
Hey, good morning. Pretty good. How are you doing today?
Wonderful. We've been here since this morning and we've been loving it. Time goes by fast when you're having fun, you know? So, loving
That
it.
is true. I have been listening to the music and I'm all hyped up for the presentation.
That's the whole point of the music. That's the whole point. Thank you for enjoying it and for telling us so. The team behind has been doing so much work, has been working so hard to get this exciting for everybody. Dominique, you are the last one. Thank you for closing this wonderful conference we had today. Dominique, you are a principal engineer at Cisco, and I want to get right into it. But there's actually something that's kind of cool about you. Cool, but something that you don't want to do again, right?
Never again.
Tell us, what is it?
Never again. I have been on Kilimanjaro and I have been on Mount Everest base camp. It was fantastic and I'm not willing to do it ever again.
What happened?
Oh, nothing. It was really just fantastic, but it is quite strenuous trip. So it's like once you're up there and it's like, okay, I'm going to make it back down and I'm never going to turn around.
So how much time would it take? Like a few days, few weeks, preparation, all that? How much time do you take?
Oh, so the actual trip, Kilimanjaro, if I'm not mistaken, was about 8 days, and round trip, and Mount Everest base camp was about 11 days round trip. And it does not take like a ridiculous amount of preparation, and it also does not take a ridiculous amount of acclimatization, but you do need to know what you get yourself into. And let's be honest, my wife in both instances carried me up the mountain, quite literally.
Oh my gosh. Well, it's been a dream of mine, but I thought that you needed like so much preparation and so on. But thank you. I will go into it, and then when I get up there, I think of you. I'll be like, nope, not doing it again.
Not doing it again.
All right, Dominique. Today, what we have is Canary releases. Canary releases, you're going to tell us what it is, how it can help us gradually roll out new services, revisions. And yes, it is nerve-wracking these days to get all these rollouts. And you have something up in your sleeve so it can help us put that at ease and talk about Canary releases. It is now your time. You have until 5:20, 5:15. If you want to include some questions, and everybody, this is your last chance to get talkative with us in the chat section. Talk to you soon. Have fun, Dominique.
Hey, thank you very much. Hello, everybody, and thank you very much for joining my session today on Canary releases. I'm Dominic Torno. I'm principal engineer at Cisco Systems, and I focus on systems theory and systems modeling, specifically on conceptual and on formal modeling to support the design, the development, and the documentation of complex software systems. Now, what is systems modeling? Systems modeling is an analytical method. Traditional analytical methods divide and conquer. That is a process that is formally called analytical reduction. The system is decomposed into subsystems, and individual subsystems are examined individually. System modeling focuses on the system as a whole, not on individual parts. It is holistic. Now, today, we are going to talk about Canary releases. Deploy a new revision of your service, gradually roll it out. If the new revision does not perform well, roll back to the previous revision. The end. But we have another 40 minutes. So what are we going to talk about? What do I have up my sleeve? Well, this presentation is all about the concepts behind releases and canary releases. So this presentation is not about one specific approach, not about one specific library, one specific framework, one CI/CD offering, or any target platform. In this presentation, we will develop a mental model that is a set of internalized facts, internalized concepts and their relationships, so that we may accurately, concisely, and confidently reason about releases and canary releases. So the goal of this presentation is to develop a mental model so that you may engineer a release strategy and possibly a canary release strategy that aids the development and operation of your software system. So again, we will not be looking at Kubernetes and Flagger or Kubernetes and Spinnaker or whatever combination of technologies. We will explore the concepts and their mechanics. And there we have a lot to talk about, all in the spirit of nothing is more practical than a good theory. So first, we will talk about software systems and development and operations. Well, what is a software system? Here, the definition of a software system coincides with the definition of a distributed system. A software system is an unbounded set of agents, where agents interact with one another by exchanging messages via a network. Generally, the behavior of a software system is the result of the behavior of the agents and the interactions between the agents. The complexity of a software system is the result of the autonomy of the agents and the intricacy of the interactions between them. Now, you know, in your day-to-day, sometimes we reason about a software system, or more specifically about the set of agents, as a set of services. Sometimes as a set of processes. Now we will use the term agent for statements that are valid for both services and processes, and use the term service and the term process for statements that are valid respectively for a service or a process. Both services and processes have identity and integrity. They exist in their own rights from their respective viewpoint. But of course, they are related when transitioning between viewpoints. And we will further explore this relationship between services and processes later in the presentation. Now, we will begin our exploration with a rather obvious statement. Software systems shall guarantee functional correctness, scalability, and reliability. All three of them, functional correctness, scalability, and reliability, are properties of a software system, specifically properties of its observable behavior. But like so often the case, that seemingly simple statement already raises many hard questions. What is functional correctness, and what is scalability and reliability? Let's start with functional correctness. What is functional correctness? Surprisingly, the simplest question is already the hardest to answer. A system is functionally correct with regards to a specification if the system is an implementation of that specification. Now, anybody show me their specifications? Exactly. Typically, our specifications are ambiguous and at best partially complete, leading to everybody's favorite discussion: is it a feature and not a bug, or is it a bug and not a feature? Well, here we settle on the notion that a system is functionally correct if the observable behavior of the system matches its intended observable behavior. What is scalability and reliability? Scalability and reliability are both defined in terms of responsiveness. Responsiveness is the ability of a system to meet its service level objectives. The canonical example of service level objective are response time and error rate. Scalability is responsiveness in the presence of load, and reliability is responsiveness in the presence of failure. As we all know, software systems do not just spring into existence. They have to be developed and operated. Now, from the point of view of development, a system consists of a set of agent prototypes. And from the point of view of operations, a system consists of a set of agent instances. Every agent instance is an instance of an agent prototype. An agent instance inherits its behavior from an agent prototype. Now, that notion of prototypes and instances is a bit abstract, but it is actually easily relatable. For example, if you think of agent prototypes as container images and agent instances as containers, we have a lot of experience with those. Then every container is an instance of a container image, and every container inherits its behavior from that container instance. A system configuration is a set of agent instances. Or, again, if you want to think about it a little more practical, a system configuration is the set of running containers. But again, software systems do not just spring into existence. They have to be developed and operated. Now, this presentation focuses on the operational point of view, specifically day 2 operations. In this presentation, day 1 operations refer to the sequence of actions that are necessary to transition the system from the 0 state to the initial state. And day 2 operations refer to the sequence of actions that are necessary to transition the system from the current state to the next state. Transitioning from one previously desired system configuration to the subsequently desired system configuration is not necessarily one atomic transition, but in fact it may require multiple transitions. When we change the system configuration, our objective is to always maintain the functional correctness, the scalability, and reliability of our system. So now we have formulated our objective. Change the system configuration while maintaining functional correctness, scalability, and reliability. However, it is still a long way to go before we talk about canary releases. First, we got to talk about contracts. What is a contract? A contract is an agreement on the valid interactions between a consumer and a provider. The different type of interactions can be manifold, but in this presentation, we limit our discussion to REST-style request-response type of interactions. So here, a contract is a set of endpoints that may be called. We call a specific interaction consisting of a set of request-response pairs a trace. Here, this is a valid trace under the contract, as we are calling the contract's endpoints bar and buzz. Here, this is an invalid trace under the contract, as we are attempting to call the non-existing contract's endpoint foo. So a trace is said to be a valid trace T given a contract C, or an invalid trace T given a contract C. Contracts relate to each other. A contract C1 is compatible to a contract C2 if every trace T that is valid under contract C1 is also valid under contract C2. So in effect, every contract C1 may be replaced by contract C2 without affecting valid interactions. This will be the basis for versions and revisions later in the presentation. If a contract C1 is compatible to a contract C2, that is equivalent to saying that a contract C2 is backwards compatible to contract C1. Contract compatibility forms a chain. a chain between contracts. However, here we will only show immediate compatibility relationships between contracts and not show transitive compatibility relationship between contracts. So the term compatibility, and more specifically backwards compatibility, suggests there is a time component to the compatibility relationship. For example, first there was a contract C1 offering an endpoint foo. Then there was a contract C2 offering endpoint foo and bar, backwards compatible to contract C1. And finally, there was a contract C3 offering endpoints foo, bar, and buzz, backwards compatible to both contract C2 and C1. This time component, this notion of time, reflects our experience. First, there was C1, second, there was C2, and then third, there was C3. However, the compatibility relationship itself does not imply a timeline. Here, contract C11 and contract C12 are both compatible with contract C2, which in turn is compatible with contract C3. Therefore, contract C3 is backwards compatible with contract C2 and backwards compatible to contract C11 and C12. A timeline is much less apparent in this scenario. Okay. So now we discussed contracts and compatibility. However, still a long way to go before we talk about canary releases. Next, we'll talk about services and processes, as well as revisions and revisions. As well as versions and revisions. Both intuition and definition of service, and to a lesser degree of process, are surprisingly elusive. Ask any two engineers in this audience, and you will not receive the same answer to the question, what is a service? So let's slowly move from agent to process to service. An agent is an individual component that shows an observable behavior by altering its local state and exchanging messages with other agents in the system. Now, contracts and agents enter two different relationships. An agent may implement a contract. That is, the agent is in the role of the provider. From here on, the implementation relationship will always be depicted as a solid line. And an agent may depend on a contract. That is, the agent is in the role of the consumer. And from here on, the depends on relationship will always be depicted as a dashed line. Simple constellations are super straightforward. Some agent, the consumer, depends on a contract C. Some agent, the provider, implements a contract C. So therefore, the consuming agent may interact with the providing agent. So the consumer depends on the provider to consume contract C. Again, super straightforward. But relationships may actually be more complex. Now, in this scenario, the consumer depends on a contract C1 and a contract C2. The provider implements both contract C1 and contract C2. So the consumer depends on the provider to consume either contract C1 or contract C2. Now, in this scenario, the consumer depends on a contract C1. Both provider 1 and provider 2 implement the contract C. The consumer depends either on provider 1 or provider 2 to consume contract C. Here, the consumer has a choice. In this scenario, the consumer depends on a contract C1 and a contract C2. provider 1 implements contract C1 and provider 2 implements contract C2. The consumer depends on provider 1 to consume contract C1 and depends on provider 2 to consume contract C2. So far, so good. But here is an interesting scenario. Provider P1 implements contract C1. Provider P2 implements contract C2. And in addition, contract C1 is compatible with contract C2. And therefore, provider P1 is compatible with provider P2. So if the consumer depends on contract C1, the consumer depends either on provider 1 or provider 2 to consume contract C1. Again, the consumer has a choice. But if the consumer depends on contract C2, the consumer depends on provider 2 to consume contract C2. The consumer does not have a choice. Now, all of this leads up to versions and revisions. Versions are contracts that are not in a compatibility relationship. A consumer depends either on version 1 or version 2. They may be similar in spirit, but they are different in the flesh. That is an explicit choice the consumer has to make. However, revisions within a version are in a compatibility relationship. So revisions are an implicit choice. Let's look at versions and revisions again, as both of these are central concepts to Canary releases. So here we got an agent foo that sends requests to consume an endpoint bus to agent bar. If bar exists in different versions, foo has to make an explicit choice whether foo wants to consume version 1 or version 2. In many REST-style APIs, this is done by a version prefix in the URL path. However, foo is typically unaware what revision within a particular version of bar it is consuming. Here, the dependency on agent bar in version 2 changed from revision 1 to revision 2, and subsequently from revision 2 to revision 1. Similarly, the dependency on agent bar in version 1 changed from revision 1 to revision 2. So foo makes an explicit choice between consuming version 1 and version 2, but consumes any revision of either version without explicit choice and most of the time without explicit knowledge. Okay. So far we've spoken about agents, but we have still not spoken about services and processes. Services and processes exist on different points of view and may not be conflated with one another. However, there is a relationship between services and processes. A service, a super agent, emerges from a set of processes, the sub-agents, and their interactions. However, the service boundary, the treatment of a set of processes and one services, is a choice that is made by an observer. It is not absolute. So we may reason about systems from a service-to-service point of view and a process-to-process point of view, but we may not arbitrarily switch between viewpoints and arbitrarily attribute characteristics of one level to another. Here we see a popular realization of a service A as a set of processes. We have a proxy or a load balancing process to dispatch a request, and a set of processes to receive a request. The set of processes to receive the request may itself be divided. For example, the set may consist of a set of processes in revision 1 and a set of processes in revision 2. The service boundary includes all involved processes. But some processes may be involved in more than one service. For example, the proxy process may be the proxy process in service A, in service B, and service C. Now, the duplication of containers, both in revision 1 and revision 2, ensures the scalability of the service. So here we have an emergent property. The service itself is scalable, while an individual process is not. The proxy process manages the interaction with the other processes. For example, the proxy process may implement a traffic split and a 3-time random retry policy. If a request refails for the first or second time, the request is randomly retried. Or alternatively, the proxy may implement a traffic split and a deterministic retry policy. If a request fails for the first or second time, the request is retried only with processes of revision 1. The retry of failed requests, especially if the first attempt was handled by a new revision, ensures the reliability of a service. Now, again, reliability is an emergent property. It's a property of the service, not a property of an individual process. All right, so now we discussed agent services, processes. However, we are still one step short before we talk about canary releases, but I do promise it will come up. Next, we will talk about releases, deployments, and rollouts. What is a release? A release is a deployment followed by a rollout. What is a deployment? A deployment is a sequence of action that is necessary to alter the system configuration to add additional agent instances. Sounds a little complex, so let's just say get a new container in there. A rollout is a sequence of actions that is necessary to alter the system configuration to route requests to the new agent instance. Again, a little complex. Send the traffic over to the new container. So releasing subsequent revisions of a service entails deploying and rolling out subsequent revisions of a service. So the rollout of an agent instance, like a service, a process, or here a set of processes that make up a new revision of a service, is the shifting of requests from one set of agents to another set of agents. And we have two choices. We may switch traffic instantaneously or gradually. First, let's look at instant rollout. As the name suggests, instant rollout shifts all traffic from one set of agent instances to another set of instances in an instant. Here, at T1, all requests have been routed to the set of agents making up revision 1. And at Tn+1, all requests have been routed to the set of agents making up revision 2. Now, let's examine gradual rollout. Again, as the name suggests, gradual rollout shifts traffic from one set of agent instances to another set of agent instances over a period of time. Here, at T1, all requests have been routed to the set of agents making up revision 1. At Tn+1 and Tn+2, requests have been split between the agent instances, making up revision 1 and the agent instances making up revision 2. And finally, at Tn+3, all requests have been routed to the set of agents instances making up revision 2. So now we discussed releases, deployments, and rollouts. And believe it or not, at this point, we are finally ready to talk about canary releases. A canary release is a release that features a closed loop gradual rollout. That is a gradual rollout with a feedback loop. A feedback loop is a concept from the world of control systems. Open loop control systems do not take the effects of their actions into account when determining the control input. But closed loop control systems do take the effects of their actions into account via a feedback loop when determining the control input. This is where the literal and figurative canary comes into play. So early in the 20th century, coal miners brought canaries into coal mines as a warning signal for toxic gases, primarily carbon monoxide. The birds are more sensitive, and they would show distress before the miners were affected. So here, depicted as a control system, the control laws demand that if the canary shows any sign of distress, the workforce has to evacuate the mine. So in our world, the new revision of a service serves as a canary. Traffic is split between the old and the new revision. The system monitors the performance of the new revision. And the control laws state that if the performance of the new revision is unsatisfactory, roll back traffic to the old revision of the service. Okay, let's walk through a few scenarios. First up. These scenarios are going to be fairly repetitive, which is not great for a presentation, but is actually great for operation, because once something is repetitive, it may be automated. First scenario. The objective of this scenario is to release a new revision of service B, but no new functionality, no new endpoint. Here we assume that the rollout of the new revision will succeed. The initial configuration of service B is a set of containers of image B in revision 1. And here we assume an error rate of 0.1%. First, we have to deploy, bring into existence a set of containers of image B in revision 2. And next, we have to gradually roll out traffic to the set of containers of image B revision 2. At 33% traffic, we observe a 0.1% error rate for revision 2. At 66% traffic, we still observe a 0.1 error rate for revision 2. And at 100%, we still observe a 0.1 error rate for revision 2. So with adequate performance, we consider the rollout a success. Our canary is happy and healthy. Now, same scenario. Again, the objective of this scenario is to release a new revision, service B, but no new functionality. However, here we assume that the rollout of the new revision will fail. So initially, same configuration. Service B is a set of containers of image B in revision 1. And here we assume again an error rate of 0.1. So first, you have to deploy a set of containers of image B in revision 2. Same thing. We gradually roll out traffic to the set of containers of image B revision 2. And at 30% traffic, we observe a 0.1 error rate for revision 2. But at 66% traffic, we observe a 0.5 error rate for revision 2. With inadequate performance, we consider the rollout a failure and roll back traffic to the set of containers of image B in revision 1. The canary showed distress, and we evacuated the mine. These are the baseline scenarios. But there are more complex scenarios that you have to take into account. We just walk through one more. And that is, the objective in this scenario is to release a new revision of service B with new functionality consumed by service A. So here we assume that the rollout of the new revision will succeed. So initially, the configuration of service A is a set of containers, image A in revision 1 and an error rate of 0.1. And the configuration of service B is a set of containers of image B in revision 1 and an error rate of 0.1. Image B provides one endpoint bar. Image A consumes one endpoint bar. So first, we modify service B by deploying a set of containers of image B in revision 2. Image B revision 2 provides two endpoints, bar and buzz. Next, we gradually roll out traffic to the set of containers of image B revision 2. And at 33% traffic, we observe 0.1% error rate for image B revision 2 of endpoint bar. We have not updated service A. Buzz is not being hit. At 66% traffic, we are still at 0.1 error rate for image B revision 2 endpoint bar. And at 100% traffic, we still observe 0.1% error rate image B revision 2 endpoint bar. Now we need to coordinate across services. Next, we modify service A by deploying a set of containers of image A in revision 2. Image A revision 2 consumes two endpoints, bar and buzz. So as soon as traffic hits, we will hit both endpoints. So next, we gradually roll out traffic to the set of containers of image A revision 2. And at 33% traffic, we observe an error rate, 1% of image B revision 2, endpoint bar and buzz. 66%, same thing, 0.1% error rate for image B revision 2 of endpoint bar and buzz. And at 100%, we still observe 0.1 error rate for image B revision 2 of endpoint bar and buzz. Again, Canary is happy and healthy. So with adequate performance, we consider the rollout a success. Now, the most interesting scenario of this presentation. The objective, again, is to release a new revision of service B, but the new revision of service B will add a new endpoint buzz, and we will run into trouble. So initially, again, the configuration of service A is a set of containers of image A in revision 1, 0.1 error rate. Configuration of service B is a set of containers, image B, revision 1, 0.1 error rate. Image B, revision 1, provides one endpoint bar. Image A, revision 1, consumes one endpoint bar. So first, we modify service B by deploying a set of containers of image B in revision 2. And image B, revision 2, provides two endpoints, bar and buzz, same as before. Next, we gradually roll out the traffic to the set of images, image B revision 2, and at 33% traffic, we observe 0.1 error rate for image B revision 2 of endpoint bar. At 66% traffic, we observe 0.1 error rate image B revision 2 endpoint bar. And at 100% traffic, we still observe a 0.1 error rate for image B revision 2 endpoint bar. So we may be fooled into believing that the rollout of service B was a success. After all, the performance of the new revision seems to be adequate. But we have not even hit our new endpoint yet. So next, we modify service A by deploying a set of containers of image A in revision 2. Image A revision 2 consumes two endpoints, bar and buzz. Next, we gradually roll out traffic to the set of containers of image A revision 2. Now both endpoints are being hit. At 33% traffic, we observe a 0.1 error rate for image B revision 2 of endpoint bar, but a 0.5% error rate for image B revision 2 of endpoint buzz. With inadequate performance, the Canary is unhappy. We consider the rollout a failure, and we have to roll back traffic. Interestingly so, even so the failure is located in service B, we have to roll back service A to the set of containers of image A in revision 1 to avoid depending on the new contract that exposes bus. Okay, the conclusion of a very long ride. The basis of gradual rollouts themselves are contracts and the compatibility relationship between contracts, and therefore between implementing agents. The system may gradually shift traffic from the old revision to the new revision because the old revision is compatible to the new revision, or alternatively, the new revision is backwards compatible to the old revision. Services are constructed from a set of processes so that the consumer of the services chooses a version of the service, and the provider of the service chooses a revision of the service. Now, a canary release is a deployment followed by a gradual rollout, where the rollout itself is controlled by the performance of the revision that is being rolled out. Canary releases are one possible way to change the configuration of a system while simultaneously ensuring the functional correctness, scalability, and reliability of individual services and the entire system before, in, and after the transition. So with that, thank you very much to everybody who made it to the end. And I would like to open this for questions. Thank you.
Thanks a lot, Dominique. Indeed, very comprehensive. You went through all the details that we needed. And actually, we have a question for you. Do canary releases have to be automated? Is that an obligation?
So the automation of canary releases is not a defining criteria of canary releases. So you may very well walk through canary releases manually. But even so, it's not a defining criteria. It is definitely a desired property. So the end goal is that canary releases are automated, and that the automation is considered part of your system, part of the control plane of your system. In that setup, the system itself makes sure that it is in a happy and healthy place.
Oops, sorry. Okay, cool. I believe we'll have a few more questions coming to you through Twitter. I didn't see your handle. Can we reach out to you maybe on social media in any way?
Absolutely. My handle was in the beginning. Maybe I can update my profile somewhere here on StreamYard, but my handle is Dominic Torno. Very imaginative.
Right. Very imaginative indeed. All right. Thank you so much for your time, and know that you can send feedback, and I'm talking to the audience here. You can send feedback to get very, very cool swag from the TheCloudFIrst conference. You don't want to miss that. Thank you for your time, Dominique. Thank you for your engagement and for walking us through canary releases. I believe the sessions will be available later on, and people would be definitely enjoying to get back to this. Thanks for your time, and we'll see you next time, I hope, Dominique.
Thank you very much for having you. Oh, for having me.
But thank you for having me. Thanks a lot, Dominique.
Thank you.
Take care. Bye.
Bye-bye.
All right, everybody. Now I'd like to welcome somebody who's been helping me and helping the track one, François. Hello. Can you, hold on. Can you unmute your mic? Oops. Can you unmute yourself, François? I don't know if François is hearing me. Yes, here you are. You can't hear me. That's all right. You'll be back when you be back. Just I wanted to share a few things with you guys. Let me share my screen with you right here. Actually, we have a few things for you. Oops. Voila. I hope you can see my screen. So yes, you've been to the Cloud Native European Conference by developers and for developers. This was your conference only for you guys and girls. Everything Cloud Native, obviously. We hope this won't be the only one. This won't be just the first, but the first to many very, very long conference call. And know that you can share what you've thought was very cool about today. You can share what you've learned. You can share what amazed you or what the few things that you did not agree with. Sharing is caring. You can tweet at TheCloudFIrst IO TCF21, and each tweet will get a chance to win a sticker pack. Actually, I have this sticker pack with me. I should show it to you, but they are very, very cool and definitely going onto my laptop as we're talking. And now, did you like this session? I did. So if you did, give us your feedback and take a chance to win this little pack, sticker packs that we talked about. See the link just right here, actually, at the bottom of your screen. You can see HTTPS feedback at TheCloudFIrst.io. Your feedback means everything to us. We want to make sure that the experience is as smooth as possible. And also, if you like to provide insights or maybe provide the name of a speaker you would like to see, this is exactly the type of feedback we need. Yes, we are concluding this conference, but making sure we have your insights will make a second version of the TheCloudFIrst possible for everybody. And now, know that tomorrow you will have free workshops coming in. Let me see if I can get François. Yes, here you are, François.
Yes, I'm back.
Here you go. Thank you, François, and clap, clap, clap 1,000 times because you are the person behind everything on this track. One, thank you a lot for your help.
You did a lot.
And, well, we've been having fun on this track one, definitely since 8:30 this morning. We've been getting ready and excited, and getting your feedbacks and messages has been awesome for us. So I was just talking about the free workshops we have tomorrow. The tickets are still available from what I can hear. So this might be the right time to get your ticket now. I hope so. Will you be there tomorrow, François?
I can't, but I would love to take a look, sneak peeks during the day.
Me too, actually. Me too. I like to go to the Infra Ascod one. This is definitely something that I would love to go to, or the DevOps one. But please, as we can't do it, just go. Go for it. It is your only chance to get it. And now that you have this, we just wanted to thank this amazing team: Arnaud, Christophe, Philippe, Adrien, François, Denis. Maybe François, you'd like to talk on behalf of everybody?
Oh, it's been like 4 months since we made up the idea of creating this conference, and yeah, it's been a long journey and a great journey. I think this day has been great also. So yeah, I'm proud of it.
Exactly. And oops, I'm getting all the messages, but that's all right. And we'd like to thank also our sponsors: Microsoft, Square Mild, Reboot, the MIC Dev Apps, also Sense of Tech, obviously the MUG Strasbourg, .NET User Group Luxembourg, and Boglers Consulting. And yeah, this is we cannot do it without you guys. Thank you for sponsoring community events. We need support, and we cannot go on without your very strong support and your hand. And communities are the only way to make this work. So, and they are strong as ever. So hopefully we can see them grow as we go. Oops. And finally, last point. That's it. That's it for me, actually. That's all I had. And just wanted to say a massive, massive thank you to the organizers. They've worked so much for this conference. And hopefully we'll see you next time.
Yeah,
all right.
We're looking forward for this.
See you next year, everybody.
Bye-bye.
Take care. Bye-bye.